Hello everyone, I'm Siddharthan. This is the fifth part in our complete machine learning course series, and this is probably the last section in the series. And in total, there would be around 56 or 57 hours of content. And throughout this four sections of this machine learning course, we have seen what is the basis of machine learning, what is the Python basics required for it, and we have also seen several machine learning use cases. And in this last part, we are going to discuss about how we can deploy our trained machine learning model, and we are also going to see some deep learning use cases that would be helpful for you if you're going to start learning about deep learning. So first, I'll give you a quick recap of what we have seen in this four parts before this one, and I'll also explain what you can expect in this fifth part of this machine learning course. Okay, so let's get started. So the first part of this machine learning series was on four modules. So the first module was on what is the machine learning basics. So what is meant by machine learning, what is meant by artificial intelligence, and so on. And the second module was on Python basics. So we have discussed about some basics such as how to write for loops in Python and how to write this if statements and functions and so on. So the third module was on some of the important libraries that we often use when it comes to machine learning use cases such as NumPy, Pandas, Matplotlib, and Seaborn. And the fourth module was completely on data. So where you can collect the data for your machine learning use cases or data science use cases and how to pre-process them. And we have also seen three machine learning use cases that are listed here, such as rock versus mine prediction, diabetes prediction, and spam mail prediction. So this was the first part of the video, and I'll also give the link for each of these parts in this video description. You can check that out. And the second part was on the mathematics basis for machine learning, where we have discussed about linear algebra on vectors and matrices, and we have also discussed about statistics and probability. And the sixth module was on about machine learning models. So how a machine learning model works, how to select models, and what is meant by this overfitting and underfitting issue, and so on. So we have discussed like all these topics, and also we have seen like three other machine learning use cases. So the third part was completely on building machine learning models from scratch, and we have seen like four important models such as linear regression, logistic regression, SVM, and lasso regression. And the fourth part, the last part that we have seen, again consisted of like two modules. So the eighth module was on how to optimize your model. So we have discussed about this cross validation, how to cross validate your model, and how to tune your hyperparameters, and also how to select your models and model evaluation. So these are all the topics that we have discussed in this eighth module, and there were about like five machine learning use cases such as this big mart sales prediction, breast cancer prediction, calorie burn prediction, movie recommendation system, and customer segmentation, which is a clustering problem. So far we have discussed all these things, and now in this fifth module, again there will be like two sets of topic. The first topic will be on how to deploy your machine learning model. Again, there are like several ways to deploy your model, and here we are going to discuss two of them. One is how you can use the Streamlit framework, which is basically a library in Python, and how you can build simple web apps using the Streamlit. So in the first video, I have explained you like how to install this Streamlit setup and how to install libraries in Anaconda. So that will be the first video in this section, and we will also see how we can build this web app using the Streamlit, and how to make this web app as a public web app. So the second topic that I have mentioned, so here we will build this web app to run on a local machine. And the next step will be how you can make this as a public web app so that someone else can access it using the link that you provide, so they can like see how your web app works. So in this case, we have deployed this web app on Streamlit Cloud, and there is also another option where we can deploy this web app on Heroku. And the next way of deploying your machine learning model, which is the most widely used one, is deploying your ML model as an API. So for this, we use a library or a package called as Fast API, and those things will be covered in this section. And also, again, so this will be running on your local machine. And if you want to deploy this as a public API, so there we will deploy this ML model in the form of API on Heroku. So these things will be covered in this machine learning model deployment, and also we will build this multiple disease prediction system where you can select between like three diseases, and you have built three different models that can predict like three different diseases. So this will be the first set of topics in this video, and in the next set of videos, we will be discussing about this simple deep learning use cases. The first one will be on this breast cancer classification using neural network. So the reason behind putting this video is that we often use like image data and text data with deep learning. So in this topic, I have explained you how you can use a structured data like a table with numerical data for neural networks. So that will be the first video, and the next two videos will be on how to process your image data. So we can't feed our image data directly to our neural network. So in the second video, I have explained you how this image data is converted to numerical data so that a deep learning model can learn from it. And in the next video, I've also explained this in the form of a Python implementation. So in Python, I have explained you clearly on how we can convert this image data in the form of numerical data. And then we have like two use cases. So the fourth one is this MNIST and 10-digit classification, where we will build a neural network and train it to recognize like and 10 digits. And the last video will be on transfer learning. Transfer learning is nothing but using pre-trained models. So here we will use a pre-trained neural network to classify an image as either a dog or a cat. So these are all the topics that we will be covering in this particular part, and I hope you have learned a lot. And like, you're in a better place since you have started learning this, machine learning series. Okay, so I hope you have a good time watching this particular video. So let's get started. So, as you might know, there are a lot of requests from the viewers of my channel in order to make a video on machine learning model deployment. So, I'm planning to make videos on how you can, deploy machine learning models in web apps. So, these are the prerequisites for it. So, Streamlit is the library. It's basically a Python library which is helpful for us in order to build those web apps where we can easily deploy our machine learning models. So, before going to that video, I would like to make a tutorial explaining how you can install Anaconda and Streamlit in your PC. As you might know, in our channel, we have worked mainly on Google Collaboratory. So we did all the Python programming on Google Collaboratory. So I just wanted to show you how you can do this installation, and then we can move on to the model deployment part. Okay, so let's see how we can do that. So I'll go to my Google Chrome. So first you need to install Anaconda. Okay, so just search install Anaconda. So you can see this particular site here. So you can go to this individual edition. So there you can download the Anaconda software from here. So this Anaconda is very helpful for us in order to install Python, and there are also other IDEs like Spider, PyCharm, etc. Okay, so mainly we will be using Spider IDE, and it installs Python by itself. So 3.8 version of Python will be installed, so you don't need to install Python separately in your system. So you can download this software from here. Okay, so I have already downloaded my software. So if your system is a 64-bit operating system, you can download the 64-bit version. So in case your system is a 32-bit version, you can just scroll down here and you can see the 32-bit version here. So you can download the 32-bit version if your system is a 32-bit operating system. So if you are not sure how to find what is the system specification, just come to your this PC and you can right click and go to the properties. So if you click this, you can see whether your operating system is 32-bit or 64-bit. So download it based on it, and you can, if you are on Mac OS, if you are in Apple, or you are using Linux OS, you can download the software respectively. Okay, so I have already downloaded this software. It's around as you can see here, it's around 477 MB. Okay, so you can download it, and once you download this, I'll just show you. So I have this already downloaded, so you can just run the installation procedure. It's actually very simple. So just download it with the default settings. Okay, so just give all users, so which requires admin privileges, it is easier for us. Okay, and let's run this. So okay, so you can give this default setting. So register Anaconda 3 as the Python 3.8. So the use for this particular choice is that if you are running other IDEs like PyCharm and other things, and even Visual Studio, the Python which is installed through this Anaconda will be used there. If you use this, it will create a separate path. So in case, I'm assuming that you haven't installed this Anaconda before and you haven't installed Python before. So in that case, so go ahead with the second option and install. So it's better to install with the already predetermined default settings there. Okay, so I'm registering Anaconda 3 as the system Python 3.8. So I'll install this. So this will take some time. Okay, so this may take around 10 minutes or even more than that, depending upon your system. So here I'm going to pause my video and I'll resume this once this installation procedure is complete. So you can also try to install this side by side as you're watching this video. Okay. So my Anaconda got installed. So I'll just give my next, and the installation procedure will basically get completed. So these are some basic tutorials. I'm checking this. So this installation will now get completed. So now I'll open my Anaconda navigator. Okay, so you can open this or you can run this as administrator. Okay, so we need to install our Streamlit library. So in order to install that, we need admin privileges. So run this Anaconda navigator as administrator. So this is how you can open it. So go to your search bar and type as Anaconda. So you can find this Anaconda navigator here and just run as administrator. Okay, so it will take some time to open, maybe a minute or two. So let's wait for it. So in the meantime, you can go to Google and search install Streamlit and Anaconda. Okay, so you can see this Streamlit docs here. So documentation is it. So just click it. So here we can see the methods which we can use in order to download the Streamlit library through Anaconda. So the Python version should be 3.7 to 3.9. So this is very important. So for this Anaconda, we are getting 3.8 version. Okay, so if you just scroll on to the downwards, you can see how you can install navigator and how you can create an environment and all those things. So we'll be creating a separate environment here. Okay, so let's come to this at a later time. So this is how your Anaconda navigator looks like, and all these apps get installed to your environment. So this base root environment. Okay, so it's actually a good practice in order to create a new environment. So you can see this home, environment, learning, and community. So come to this environments, and so this is the base root. So this is the base application that has got installed, and it's better to create a new environment. So you can create. So you can see this create option here. So click this. So here you can create a new environment. I'll name this environment as machine learning. Okay, so it's better if you don't give any space between this environment name. It is better in some cases, so just give that. So now it will create a new environment, and this new environment again Python 3.8 will get installed. So I'll create this, and within this environment you can create you can install the libraries and other things that you need. Okay, so the IDE which we will be basically using is the Spider IDE, or you can also use PyCharm also, but I prefer Spider IDE, so it's up to you. Okay, so this will take some time in order to create this environment. So once this is complete, what we need to do is you can come to this Streamlit documentation. So here you can see this pip install Streamlit. So this is the command which you need to run in your Anaconda prompt in order to install the Streamlit library. So once this installation okay, so now our environment got created. Okay, so now we can just copy this particular command. Okay, so pip install Streamlit. So this is the command in order to install the Streamlit library. So I'll go to my Anaconda navigator. So it has loaded the packages. So now you can see here I have two options here. One is the base root environment, and the other is the new environment which we have created. So that is our machine learning environment. So as you can see here the Spider IDE is not yet installed, as you can see here. So only these two apps are installed. Our Spider IDE is not installed. You can go ahead and install this Spider IDE. Okay, so this is going to take some time, so I'm not going to do this. So once you complete all the procedures, you can install the Spider IDE and this Qt console. Okay, so you can do that. And now we can come to this environment, and in this environment we are going to install our Streamlit library. Okay, so you can click this play symbol here. So once you click this, you can see this open terminal option. In that we are going to paste which we have copied, which is the pip install Streamlit. So this is how you can install libraries through pip install. So just come to this environment. So don't select this base root, select this machine learning. So in that you can click this open, so sorry, the play symbol and open terminal. And now we need to paste that particular command, which is pip install Streamlit. Now press enter. Okay, so this will download all the packages, and it will install the Streamlit library. And the important thing is that you need to open Anaconda Navigator as an administrator. If you don't do that, there will be this error called as access denied. So you won't get access to install the library. So open Anaconda Navigator as an administrator, and that is very important. Okay, so let's wait for this to complete the installation. Okay, so this is almost done. So once the installation got completed, we can run this Streamlit allow. Okay, so in the same terminal. So I have copied this from here. So once the installation got completed, we will again see this particular line. So this machine learning C uses the same thing. So we will see this particular line. That means our installation got completed. So let's see whether it is okay. So the process is going on. So let's wait for it. Okay, so it has completed the installation procedure. Now the cursor is here. Right now we can paste this Streamlit allow, so you can go through this documentation. So these are all the things that I've already mentioned. How to install Anaconda, how to create this environment, and all those things. Okay, so now we are going to run this Streamlit allow, which we have copied from here. So when we run this, we will get a web page. So let's wait for it. So this will open your browser. So in this, my default browser is Google Chrome, so it will get open. So let's wait for it. Mm, it's taking some time. So you can also install the other libraries from here. Okay, so yeah. So my Microsoft Edge has opened. I think it's my this is my default browser. So I'll just cancel this. So this is how the home page of Streamlit looks like. Just a second. So this is how the web page, the home page looks like. So what happens is when we build our Streamlit code and we run this, this web page will be opened, and in this we can give some values, and we can try to predict some values and so on. So basically, what we will do here is, so we have worked on several machine learning projects, right? So let's consider one example. So let's say that we have worked on this diabetes prediction project, and let's say that we have trained our machine learning model. So once we train this model, we will save this model. So I'll show you in the next video on how you can save the trained model. So once we save that model, we will integrate that particular code along with this Streamlit library. So once you do that, so we will create a simple web page which looks like this. So it will contains various options where you can enter the data set values and other things, and it's basically like creating a web page in HTML. So we will do all those things. So once that is done, so if we give new values, this particular model can predict what are the values that we want. So this is how basically deployment works, and these are the prerequisite for it. So you need to install Anaconda, and the main thing is you need to install Streamlit. Okay, so just close this, and if you want to install other libraries, so I'll just close this one. So you can search for libraries here. So you can search for NumPy and Pandas here. So before that, you need to give all. So this will show only the installed library. So you can click this drop down menu, and you can select this all. From here you can install the libraries like NumPy and so on. So like sometimes it's not showing yet. So let's install it through pip install. So what you can do is, so I'll show you how you can install the sklearn library. So you go to Google and search sklearn pypa. Okay, so pypa basically stands for Python package installer. So you can click this sklearn pypa. So this is the command we need to give in order to install our sklearn through pip install. So I'll copy this, and again you can come to this Anaconda navigator, and you can click this play button, open terminal, where you can paste that particular command, which now will install the sklearn library in our Anaconda path. So this is how you can install libraries in your Anaconda system using this pip install command. And so you just need to go to Google. So type the name of the library which you want. Let's say that we want to install the matplotlib library. Okay, so matplotlib pypa. So here we can see the pip install command and so on. So we just need to copy this and paste it in our command prompt. So the command prompt of Anaconda navigator, and it will install the libraries that we need. So you can install the basic libraries like NumPy, Pandas, sklearn, and all those things. So the main thing that we need for our deployment is Streamlit library, and I hope everyone is clear on how to do this. So and the other thing is that you need to install this Spider as well. So I'll just install this. So this in Spider will be doing all the Python programming. Okay, so we will deploy the model from this Python IDE, and after that it will open a web page where we have this Streamlit web page and so on. So this is how we can create web apps using Streamlit, and make sure to install all those things. So in the next video, I'll show you how we can train a machine learning model and how we can deploy it using Streamlit. Okay, so that's it for today is machine learning model deployment. And in this video, we will be discussing how we can deploy a trained machine learning model using Streamlit library in Python. So we will be taking the diabetes prediction project, which we have already worked on in our channel, and we will be creating a web page where the user can give in some values, and this trained machine learning model can predict whether a person has diabetes or not. So this is the web app that we are going to create in this particular video. So let's get started. So first of all, I'll go to my diabetes prediction code in my Google Collaboratory. So as you might know, I have already made this video, and if you haven't seen that particular video, if you don't know how this thing works, I'll give the link for the diabetes prediction project in this video description. You can check that video out, and after watching this video, you can continue with this one. Okay, so these are all the basic data processing and all those things. So I have already uploaded my dataset file, which is this diabetes.csv, and we have did this importing the libraries and all other things. So the complete code is here. So what I'm going to do now is, so I'm going to my runtime, and I'm running all the cells. Okay, so this will run the entire cells. So in this, the model we are using is a, now you can see here it is a support vector machine classifier. So we'll be saving this trained model, and we will be using it to deploy in our web app. So once we have completed all the things, so once we have trained our model, once we have evaluated our model, so finally we have this predictive system where we can give some values in this particular list, and it will tell you whether that person is diabetic or not. So this is what we have done in that particular diabetes prediction project. Now we can see how we can save this model, how we can save this trained support vector machine model, and how we can use that in our Streamlit code. Okay, so I'll just make a text here as saving the trained model. So saving the trained model. So for this, we need a library called as pickle. So I'll write here as import pickle. So this is one of the libraries that you need for this particular project. So I'll run this. So this will import the pickle library, and this pickle library has the functions that we need in order to save this model. So I'll create a variable here as file name. So in this variable, I'm going to give the name of the file that I'm going to create. So I'll name this as trained model, trained underscore model dot sav. Okay, so it is basically a saved file, and I'm going to use the function pickle dot dump. So pickle dot dump, and within this I need to give the model, I need to mention the model that I want to save. So here we have named the model as classifier, right? So I'll copy this classifier term, so you can paste it here. So pickle dot dump classifier, and we need to mention open and file name WB. So let's try to understand what we are doing here. So these are some file operations that we are doing here. So I'm naming this particular file as trained model.sav. So this is the name of my file that I'm saving, and I'm storing this in a variable called as file name. So in this file, I wanted to save this particular model. So I'm using this pickle.dump, and I want to save this model, and this model is loaded in this variable called as classifier. So I'm basically opening a file, and the name of this file is trained model.sav. So I'm mentioning the file name here, comma WB. So W means write, B means binary. So we are writing a file in the binary format, and what we are writing is nothing but the classifier, the model which we have trained using the diabetes dataset. So in this we have used a PIMA diabetes dataset. So you can see all the details here. So it is basically helps you to predict whether a woman has diabetes or not. So the input features we have are the number of pregnancy a particular woman had, what is their blood glucose level, blood pressure, and so on. So this is one of the standard data sets that we have in machine learning. And finally we have the outcome, one being the person is diabetic, and 0 being a person is non-diabetic. Okay, so this is the data set that we have, and this model is trained with this data set, and it is this classifier term. And now we are storing this model to this file. So it basically contains all the parameter values, so weights, bias, and other parameters of this particular model. So when I run this will create a file called as trained model.sav. So I'll run this. Okay, so this will create a file. So you can see the file here. So trained model.sav. So this file gets created. Now let's see how we can load this model and how we can use it. So this part is about loading the saved model. So this is also very important for you to learn. So let's see. So we have now saved our model. Now let's load this. So I'll create a variable here as loaded model. So in this term loaded model, I'm going to load my model. So is equal to, again, I'm going to use pickle function called pickle.load. So this dump function is used to save your trained model, and this load function is used in order to load the saved model that we have saved. Okay. So here also you should mention open, and within that mention the name of the file. Okay, so the name of the file is nothing but trained model.sav, right? So I'll copy this and paste it here. So it is nothing but this particular file. You can also go to this option and copy the path and paste it here. So I'll just paste the name here, and here we should mention RB. So RB means reading the binary formatted file. So first we have written the file here. So hence we have used this attribute WB, and now we want to read this file and load it to this loaded model variable. So we have to mention this RB, which is the parameter here. So this pickle.load will load the saved model that we have. So let's run this. So now this loaded model will contain the model which we have, which is actually trained with the diabetes dataset that we have, and this particular model has an accuracy of around 77%. Okay, so the only difference in the code which I have shown here from the diabetes prediction project which I have worked on is that in that particular video I have used the standard scalar function, but in this case we won't be using the standard scalar. The reason is that the accuracy doesn't change, so it is almost the same when you standardize and don't standardize the data in this particular project. So the reason I didn't include that is, in case you are using the standardization function, you need to save the standardized that standardization function as well to your pickle. So that's why I didn't mention it, because it might be too much to handle right now. So first of all, let's try to understand how we can save the model, and we can work on that. So afterwards, let's see how we can save that standardization function and all that. So I didn't include the standardization part in this particular code, so that part will be missing when you compare it to the diabetes project which we have worked on already. Okay, so that is one difference. So we have successfully loaded our model. So now what I'm going to do is I'm going to copy this entire thing. So I'll paste it here. So here we have used this classifier, the classifier which we have trained using the data set. Now I'm, instead of this classifier, and I'm going to use this loaded model, which it's basically the same model loaded from the pickle. So I'll paste it here. So this will also give you the same value. So one, which basically means the person is diabetic, and the new data is this. So now what we are going to do is use the saved model. Okay, so this loaded model, in order to predict whether a person is diabetic or not. But the only difference is that we will be creating a web page where there will be a user interface where the user can give in these details, what is the number of pregnancies, and what is their BMI, what is the blood sugar level, and so on. And our web app will predict whether that person is diabetic or not. So this is the goal that we are interested in. So now I'm going to save this model. So trained model.sav. So you can go to this option and download the file here. Okay, so it is actually a very small file. Okay, so now I'll minimize this and I'll go to my spider. Okay, so the spider is the IDE which we will be working on in order to build this user interface using the Streamlit library. And in my previous video I have explained you what is or how to install the Anaconda, and how to install spider, how to install Streamlit library, and so on. I'll give the link for that video as well in this particular video description. You should watch those videos before watching this one. Okay, so now what we are going to do is, so I'll just import the basic libraries that we need. First is NumPy library, import NumPy as np, and then I'll import pickle. So we need this pickle library because we are going to load the data, load the model, right? So for that also we need pickle, and you should also install this pickle library. And if you are in Python 3.8 version, so if you install the Anaconda, so the default Python version in the Anaconda is 3.8, and for that you need to install the pickle library. So for that purpose you need to run pip install pickle mixin. So in my previous video I have shown you how you can do this pip installation. And so what you basically have to do is you need to go to your Anaconda, and you can go to this environment, and you can go to this play symbol. There you will see an option called as open terminal. So there you can paste this command called as pip install pickle hyphen mixin. So this is the version of pickle which is suitable for Python 3.8. so install that library, and there are also other libraries like NumPy, matplotlib, and other things. So install all the basic libraries that we need. So I'll close this. Now what we are going to do is we are going to do the same thing that we have did here. So we will be loading the pickle model and we will try to predict this particular data. So I'll copy this, loading the saved model. Okay, so I'll go to my spider. So I'll paste it here. Now we should mention the location of this trained model.sav. So where that particular file is saved. So I'll go to my downloads and I'll copy my trained SAV. Okay, so this is the model that we have downloaded, the trained model that we have downloaded. So just create a separate folder and work on this particular folder. Okay, so I'll paste this here. So I'll just change this numbering. Okay, so the name of the file is trained model.sav. So now in this, I need to mention the path of the file. So I'll go to my directory and I'll copy the path where this trained model is saved and I'll paste it here. Okay, so trained model.sav, and you need to mention the slash. Okay, so now the important thing is that whenever you are working in Python, so it should be a forward slash should be used for this directory location. So I'll change all the backward slash into forward slash. So model, train model, and yeah, so now the code knows where this particular train model.sav file is, so it will load this model to this variable and we can use this loaded model in order to make new predictions. So I'll go to the next part, and now we are going to copy this code. Let's paste this in spider. Okay, so now we can run this and see whether this is working in spider or not. So this is the same thing that we have worked on Google Colab. So now we are going to do the same in Python, in this spider IDE. So once you have pasted this code, you can go to this run option. So this will run this file. Okay, so the label we got here is 1, and 1 is basically means that person is diabetic, right? So we get this particular statement as this person is diabetic. So we are going to do this same thing now. The only difference is that we need to showcase this everything in the form of a web page. So what we will be doing is we will be creating a function and we will be including all these things in the form of a function. So this is the next part. So before that, we need to save this file. I'll go to this and save my file as, so I think it is stored in a different directory. So file, save as, I'll go to the folder in which I'm working on. So I'll name this as predictive system. Okay, predictive system. So it is a Python file. So the extension is .py. Okay, now let's go and let's create a new file, and this is where we will be using our Streamlit library in order to create our web app. So this part of the code will begin with importing the basic libraries. So the libraries that we need are NumPy. Just a second. NumPy, pickle, and Streamlit. So I'll give import NumPy as np, and I'll import pickle, and the last library we need is Streamlit. Okay, so Streamlit is used for deployment, pickle is used for loading the saved model, and NumPy is used for working with those NumPy arrays. So we just need to copy and paste all these codes. The only difference is that we need to put this in the form of a function. So I'll copy this part of the code. Okay, so let's start with saving this file. So I'll save this as in the same folder, and I'll name this as diabetes prediction web app. Diabetes prediction web app.py. So let's save this. Now let's create a function. So I'll put a comment here as creating a function for prediction. So in my previous video, I have explained you what all these things mean. So why we are converting it to a NumPy array, why we are reshaping it, and what all these things means. Okay, so you can refer that video if you're not sure. So we are going to create a function now. So for that, we need to use the keyword def, which basically means define, and I'll name this function as diabetes prediction. And within the parentheses, let's mention this as input data. Okay, so input data is nothing but the data that the user has to give. So you can see the data here. So all this details the user has to give. So whenever we are calling this diabetes prediction, so we need an input, and that input is nothing but your input data, which tells you, those things, the number of pregnancies, BMI value, and other, basic things. So now let's complete this code. So it's basically the same thing, the predictive system that we have built. I'll copy this and let's paste it here. So make sure the indentation is same. So the indentation line should be the same in this case. And we just need to, just make one thing, one change. So instead of this print, I'm going to write it as return. Okay, so return, and let's remove this parenthesis. And the same thing here. Return the person is diabetic. So what we are basically doing here is, so first we need to get the input data from the user. Okay, so we don't need this, so we don't need this particular line because the data is pre-made here. So I'll just remove this. Okay, so what we are doing here is, so whenever we call this diabetes prediction function, so the user will give in the input, and once it is done, so we are basically converting that input data in the form of a numpy array. Okay, so that's this second line of code. So we are creating a numpy array using this input data, and after that we are reshaping it in order to make prediction. Prediction is nothing but this model will predict whether the value is either 1 or 0, where if it is 1, we need to tell that that person is diabetic. If the label value is 0, then we should say that that person is not diabetic. So once we convert it to a numpy array, we are reshaping it. After that, we are using this predict function. So this predict function is in the SPM library. Okay, so the library, the classifier which we have trained. Okay, so we are using the loaded model. So the model which we have loaded using the pickle function. So once we load the model, and we are using this predict function, and this prediction will be stored in this variable called as prediction. So label, in the sense, the value that you get from here will be either 1 or 0, and we are storing that in this term called as prediction. So it will be in the form of a list. So this is the term prediction. Okay, so this is nothing but the term we have mentioned here, prediction. So it is basically a list which contains only one value. So the value which is present in this list is 1. So if the value is 0, then we should return the statement as that person is not diabetic. Sorry, if the value is 0, okay, so we should mention not diabetic. If the else condition, so the other condition is the label will be 1, and if the label is 1, we should mention that that person is diabetic. Okay, so this is the code that we have worked on. Now we can move on to the Streamlit part, where we will be building some user interface. So now let's come out of this function, and this part is using the Streamlit library. So for this, I'm going to create a main function. So there is a reason why we are naming this as main. So I'll explain you at the end of this code. So for now, just remember that we are creating a function named as main. Okay, so main function. So the first step is giving a title for our user interface, a title for our web page. So I'll make a comment here as giving a title. So for this, we should use the function from Streamlit. So, and the other thing is we can import this Streamlit as st in a short form. Okay, so we are importing Streamlit as st. Okay, so giving a title, so st.title. So this title is the function within the Streamlit library, and within the parentheses give any name, so the any name you want. So in this, I'm going to name this as diabetes prediction web app. So this is the name of my page, and now we should create some data fields, some input data fields, where the user can give in some values. So all these values, so if you come to this data set, so the data that you need should be the same as the data that you have here. So if your data contains pregnancies, glucose, blood pressure, and so on, so the user also should give the same values. So same, it's, I didn't mean that it should be the same values that is present in this data set. So what I mean is, so you should give the pregnancy values, glucose value, blood pressure value, and so on. Okay, so now we are going to create this input data fields. So that is the next step. So we need to see what are all the different fields that we have. So totally we have about 1 2 3 4 5 6 7 8 9. So totally there are 9 columns, and out of this 9 columns, the last column is the outcome column. So this is the target column, which says whether a person is diabetic or not. So we shouldn't mention this. So apart from this outcome column, because the model predicts this particular outcome column. So apart from this, we should mention all these 8 columns from pregnancies to age. Let's see how we can create those input data fields. So this part is about getting the input data from the user. Okay, so let's create all the variables that we need. So I'll go to my data set. So I'll open, so I have my this dataset file in my desktop. I'll also give the link for this dataset file in the video description. You can download the dataset from there, and I'll open this in my notepad file. So we have all these things: pregnancies, glucose, blood pressure, skin thickness, and so on. So I'll just copy all these things except outcome. So we are going to create 8 variables. So this is just for reference purpose. Okay, so first we should mention this pregnancies. Okay, so pregnancies is equal to, so once we are done with this code, I will delete this particular line. Okay, so pregnancies is equal to st dot text input. So this text input will get the data from the user in our user interface. So st dot text input. So we have this text input function from Streamlit library, and you can mention some name for it. So number of pregnancies. And the second variable that we are going to create is this glucose, right? So I'll just copy this and paste it here, and we can change this to glucose. So we should do the same thing for all the 8 terms. cst.text, this will give us the glucose level. Okay, so blood glucose level, and the third thing is blood pressure. Okay, so I'll copy this blood pressure, and now we need the blood pressure value, which is basically the BP value. Okay, so blood pressure level or blood pressure value. So what this particular term in quotes represent is, so there will be a data field where the user can give in the values, and above that data field, so this particular statement will be seen. So above that particular data field, there will be the statement called as blood pressure value. So the user can see that and enter appropriate value. So that is the reason for doing this. So these are all just variable names for those values. So only this thing will be appearing on our web page. And the third thing that we need is skin thickness, right? So or else I'll do one thing, I'll just paste this 8 times. So we have 4 and we need 4 others. Okay, so I'll see whether there are 8. 1 2 3 4 5 6 7 8. Okay, so we have 3 terms here: pregnancies, glucose, blood pressure, and the fourth term we need is the skin thickness value. So I'll just paste this here, and then insulin level, and BMI, diabetes pedigree function, and finally the age value. Okay, so now I can remove this. So okay, so now we can change the text that we want to see above the data field. So this is skin thickness, right? So let's write here as skin thickness value. So our model will predict whether the person has diabetes or not based on these values. So here let's write as insulin level, and the next is BMI value, which is basically the body mass index value. So BMI value and diabetes pedigree function. So once we complete this, you can see how this user interface looks like. So diabetes pedigree function value, and finally what is their age of the person. So let's name this as age of the person. Okay, so these are all the 8 terms that we need. So pregnancies, glucose, blood pressure, skin thickness, and insulin, BMI, diabetes, pedigree function, and ages. Okay, so now we can move on to the prediction part, where we will be calling this diabetes prediction function. So it will predict whether the value is 1 or 0 from the model which we have loaded using pickle. Okay, and then we can say whether that person is diabetic or not based on the labels that we are going to get. So now what I'm going to do is, so this particular part is the code for prediction, and all these things should be enclosed in this main function. Okay, so you can see the indentation here. So code for prediction. And in this, I'll create a variable as diagnosis. So diagnosis is equal to, so I'm mentioning quotes. So two single quotes, one opening single quotes and closing single quotes. So you can also double quotes, it doesn't matter. So only is that you should have opening quotes and double quotes. So this is basically a null string. So a string that contain no values. So the reason is that, so we will give all these values to this particular function, so this input data, and this particular function will do all the processing and will try to predict the label which will be stored here, and we will try to check whether the label is 1 or 0, and the final output that we get from this diabetes prediction function is this, either this line or the second line, whether it tells that person is diabetic or not. So this string will be later stored in this variable called as diagnosis. So that's why we are creating an empty string here. So that's the reason for this. Now we can create a button. Okay, so what happens is the user can give all these values and can click a button called as predictor. So when they click that particular button, they will get this particular diagnosis. Okay, so that's the idea. So this part is about creating a button for prediction. Okay, so for this I'm going to create a if condition. So if st dot button, so st being Streamlit, st dot button, and we can name this button as diabetes test result. So you can give any names. So I name this as diabetes test result. Okay, and let's work on this if condition. So if this button is clicked, so we should predict the output based on the input that we have. So diagnosis, so we should store the final output. So final output is nothing but these two lines, either this line or this line. Okay, so diagnosis is equal to diabetes prediction, and within that we should mention all the 6 things here. So this diabetes prediction is nothing but the function that we have created, and within this list we should mention all the 6 things: pregnancies, glucose, and all the other values. So I'll just copy and paste all the things here. So first is pregnancies and glucose level, and the second one is blood pressure value, skin thickness, insulin level, BMI, so it should be in the same order that we have worked on. Okay, so that is very important. Diabetes pedigree function, and finally the age. Okay, so these are all the 8 terms that we need. So so what we are doing here is, so we are, first of all, we are getting the input from the user. So that is done by this particular part of the code. So once we do that, there will be a button called as diabetes test result. So when the user press that particular button, so all these things, all the data that we got from the user, so the input data will go to this function which is diabetes prediction. So you can see here, so this diabetes prediction will take all these values through that input data, and all the processing will be done, and the model will try to predict the label whether it is either 1 or 0, and if the label is 0, it will tell that that person is not diabetic, and if the label is 1, it will tell that person is diabetic. So this is the test result that we are interested in. Okay, so that's it for this, and now we can finally say that if this is success, so you should come out of this if condition indentation, and here you should mention st dot success. So this is another function, uh, and this will give you the final output, which is our diagnosis, right? Okay, so diagnosis. So we have created a null string, right? So we have created a null string, and we have stored the output of this diabetes prediction function into this variable called as diagnosis, and we should finally print this. And the last thing we should mention is if name. So you should mention 2 underscore and mention name again 2 underscore is equal to, so this thing should be exact. Okay, so you can mention coach here, and again 2_main, and finally you should mention main. Okay, so I'll try to explain what we are doing, trying to do here. So this particular file, this diabetes prediction web app, won't work if you just run this particular cell. So this code should be run from the Anaconda command prompt. Okay, so we have our Anaconda navigator, right? So we will open our command prompt and we will try to run this particular file from there. Okay, so when we run a file from the command prompt, so this file will this particular code will take the name as main, and when that happens only this main function will run. Okay, so this main function is nothing but the function that we have created for our web page. Okay, so the reason we are doing here is sometimes this file can be run on a different file. So just like we have imported the numpy and pickle and so on. Okay, so we can import this particular Python file through another Python file. So in that cases this function should not run. So that is the reason. So this define function or define main function should run only when we open this from a command prompt, and that's why we are running using this particular line of code. So it will take this value as main only when it is running as a standalone file. So when it is running from a command prompt, or this file is running directly. Okay, so that is the reason we are doing this, and this is the general thing that we do in any Python code. So when we are trying to run this in a command file or something like that. Okay, so this is the thing that you should do as such. So what we are trying to do here is, so first we are trying to import the basic libraries numpy, pickle, and streamlit that we need. So pickle is used for loading the saved model, and streamlit is used for creating the web page. And we are loading the model which we have saved from our Google Colab work that we have done using the pickle.load, and in that we should mention the directory of the file. So here the backslashes should be replaced by the forward slashes. So sometimes it may not work properly, so that's the reason. And we are reading the saved file as a binary format, so that is mentioned by this RB. So W means writing a file in the binary format, RB means reading a file in the binary format, and then we are creating this diabetes prediction function where it will take the input, and this input is nothing but our input data which will be given by the user, and it will try to make that prediction, where if the final prediction is 0, it tells the person is not diabetic. In other case, the person will be told they are diabetic. And then we are creating this main function where we can give the title from the Streamlit library, and the title here is diabetes prediction web app, and the important function that we are using as this st.text input. So this will get the input from the user. So after that we are creating a null string, and within this null string called as diagnosis, all the the result, the final result will be stored. And if this button, so again we are creating a button now, and you can just give any name, and here I've given the name of this particular button as diabetes test result. And when this button is clicked, it will try to call this diabetes prediction function, and all the input data given by the user will go to that function, and we will get the final diagnosis. And when all this is a success, so all this as executed correctly, we want to print the diagnosis. So that's the idea of this particular file. So I'll go ahead and save this particular file, and I know what is the path of this file, right? So I have the path of the file here. Okay, so now let's run this from our Anaconda command prompt. So I'll open my Anaconda navigator, and I'm working on this machine learning environment. So I have a base root environment, and I have created another machine learning environment here. So I have mentioned this in my previous video on how to do that. So here I can open my terminal. Okay, so make sure to open your spider from the environment that you are working on. Okay, so that is very important. So all the libraries should be installed in this another environment that you're working on. So go to this machine learning, you can see this play button, and open the terminal from there. And here we can run our code. So there is a different way to run this. So what you should do is mention streamlit dot run. So this is very important. Okay, so this command, so streamlit space run, and you should create two double quotes, one opening double quotes and closing double quotes, and within this we should mention the path of the file. So I'll go ahead and copy the path of this particular file. I'll copy this, and I'll paste it here. So here it can be the normal backslash, the default file location that we have here. So you don't need to convert that to a forward slash. And we should also mention the name of the file. Okay, so the name of the file here is diabetes prediction web app.py, right? So I'll choose this, and I'll copy the entire file name along with the extension, which is .py. So here you should paste this. So include a backslash and paste the name of the file. Okay. So what we have done is we have mentioned this streamlit space run space. You should mention the path of the file that you want to run. Okay. So if you press this enter, a web page will be opened. Okay. So it will take few seconds to get opened. So let's wait for it. So your default browser will get open now. So let's see. Okay, so this is a simple user interface where the user can give in the values and they can get the result as whether the person is diabetic or not. So these are the input data fields. So I'll open my data set file. Let's try to use some values and try to predict whether the label is either 1 or 0. So I'll have those things side by side. Okay, so let's choose some value. Okay, so I'll choose this particular one. So this is the value I'm going to choose. So the label here is 1. So 1 basically means that person is diabetic, right? So we should paste all these things. So the first value we have is the number of pregnancies, right? So 2 is nothing but that person has 2 pregnancies. So we should put in that particular value here, 2, press enter. And the second value is 197, which is the blood glucose level, 197, and again press enter. So press enter once you fill in this particular data field. And the third value is blood pressure, and the blood pressure value is 70. And fourth one is skin thickness value, which is 45. And then we have 543 as our insulin level. Yeah, 543. And BMI value will be 30.5. Okay. And the pedigree function value is 0.158. 0.158. And the age is 53. Okay, age is 53. So I have given all the input data, and when I run this, you can see the button here. So there's diabetes test result button here. So if I click this, it will tell me whether that person is diabetic or not. And I should mention here that you won't get the accurate prediction for all the cases. So we know that the accuracy score of this particular model is around 77 percentage. So yeah, so we have the test data accuracy here. So 77 basically means out of 100 values, we will get the correct predictions for 77 values. So that's the idea of it. So let's see whether we are getting correct prediction or not. Okay, so I'll go to my Streamlit, and now I can press this diabetes test result, and now it tells us that that person is diabetic. So we can check that out here. So the final label is nothing but 1. So we know that 1 means that person is diabetic. So this is how you can create a simple user interface where the user can give in all the values and they can see whether a particular person is diabetic or not. So let's try to do the same for a non-diabetic person. So we should get the label as 0. So it should tell that that person is not diabetic. So I'll try to reload this. I'll choose this value. So you can see this here. The label for this value is 0, which means that person is not diabetic. So let's try to put all these values here. So the number of pregnancy is 1, and the glucose level is 103, and blood pressure value is 30, skin thickness value 38, insulin level 83, BMI value is 43.3, diabetes pedigree function value is 0.183, and finally the age of the person is 33. Okay, so the label here is 0, right? So it should tell that that particular person is not diabetic. Okay, so let's get the diabetes test result, and it tells that that person is not diabetic. Okay, so you can see the label here which says 0. So this is how you can use this in order to predict what is the label and what is the corresponding statement, whether that person is diabetic or not. So you can get this diagnosis, and we should fill in all the input data fields here. So that's what we have built now. So you can see this title here, right? So diabetes prediction web app. So that's what we have given in this st.title line, and then we have created this 6 functions, right? So that's what is shown in this particular case. So you can see all the 6 data fields here, and you can see these names, right? So number of pregnancies, glucose level, and all those things. So those are nothing but what you have mentioned in this codes. And finally we have this button called as diabetes test result. So you can see that particular button here. So diabetes test result. So when you press that, you will get the diagnosis which tells us whether that person is diabetic or not based on the label we have predicted from our saved trained model. Okay, so this is how you can simply deploy a machine learning model using Streamlit in a web page. Okay, so I hope everyone is clear up to this particular point. So this is actually a very basic one. So there are a lot of things you can do. So you can have multiple tabs. Like say for example, we have worked on multiple projects like Parkinson's detection and breast cancer detection and all that. So you can have different tabs here. So let's say that we have one tab for diabetes prediction, one tab for Parkinson's prediction, and so on. So when user clicks that, the corresponding data fields will appear, and the corresponding test result will be shown. So there are a lot of things you can do here. So you can add some images and all those things. So it's up to you. You can change the backgrounds and all that, so you can make this look good and all those things. So this is a simple way of deploying a model that you have. Okay, so I hope everyone understood up to this particular point. And in the future, let's try to work more on this Streamlit, and let's try to explore different things that are present in this particular library, and what are all the different things that we can do with our saved model. Be building a multiple disease prediction system using machine learning, and we will be deploying the system as a web app using Streamlit in Python. So this is how the end result of our web app will look like. So we have a navigation bar or a sidebar here from which we can choose the disease for which we want to make the prediction. So first we have this diabetes prediction, and you can see various input fields here. So these are all the features based on which we have trained our model. Okay, so we have to give these give some values for this input field in order to predict whether a person is diabetic or not. And the second disease for which we are going to predict is the art disease prediction, and here as we can see the features will change. And finally we have this Parkinson's predictions. So this is the web app that we will be building for multiple diseases. Okay, so you can use this in order to add much more diseases than this. So we have also worked on the breast cancer prediction in our YouTube channel, so you can add this to this as well. Okay, so this is how all these things work, and I'll show you how you can build a similar web app from scratch in Python. Okay, so this is the agenda for today's video. And so we will be building the system in Spider. Okay, so I have my Spider here. So if you don't have Spider, you probably need to install Anaconda, and you have to install like Spider from here, and the required libraries for this particular thing. And I have already made few videos on getting started with Streamlit, how you can install the libraries that you need and so on. So I'll give the link for this specific playlist, and these are all the videos required, or you can think about these videos as prerequisite for this particular video, but you don't have to watch all these videos. So if you remember, we have already worked on use cases like this diabetes prediction, and art disease prediction and Parkinson's predictions, where we have given some data set, and we have trained a machine learning model, and we have made some prediction. And the first video is about how to install this Anaconda, and how to install the Streamlit library, and so on. So I've explained this, so you can watch this if you have no idea on how to install the Streamlit and how all these things works and so on. And in the second video, I have deployed a simple diabetes prediction app. Okay, so you can watch that as well. Okay, so if you have watched all these things, you can just continue with this one. Okay, so the first thing that we need to do is we have to save the models that we have built in these videos. Okay, so I have done this here, so you can see this one here. So we have this multiple disease prediction system. So this one is for the diabetes video that we have worked on. So this is the same code that we have worked on here. Okay, so in this video, I hope you have already watched this one. So it is the same code, and then we have this for the art disease prediction and the Parkinson's prediction as well. Okay, so here you can see this diabetes.csv. I'll just show you how you can get this model file. So first, just upload the dataset file. So I'll also be sharing this model file as well as the dataset file, so you can train your own model and you can save it. So I have a folder in my desktop called as dataset. So here I have this three dataset files. So first, let's upload this diabetes file, as this is the collab file for this collab notebook for diabetes prediction. Okay, so this CSV file is uploaded, and so in the end, you can see. So we have, like in that diabetes prediction video, we have done until this part where we give some input data, and it will predict whether a person is having diabetes or not. Okay, and this is the additional code that I have written. So this is to save the model. Okay, so this is not necessary. So this is just loading the saved model and so on. So the two most important things are like this import pickle, and we are like saving this model. So diabetes model.sav. So this is the important one. So we have already kind of saved the model. Sorry, so we have already uploaded the dataset file here as diabetes.csv. So I'm going to run all these cells. So what happens is, once my model is trained and once my model is evaluated here, so you can see the accuracy score that we are getting. So here we are saving the model. So I'm importing the pickle. So this pickle library is used to save your models to a specific file. So I'm saving the model as a sav file, and the name of this file is diabetes underscore model. Okay, so you have to mention, so this is the variable that I'm creating, and I'm mentioning the name of the file, and I'm saving it using this dump function. Okay, and I'm writing this as bytes. Okay, so that's what like wb represents, and here I'm reading the file as bytes. So if you open your file explorer, here you can see this diabetes model.sav. So you can go ahead and download this particular file. So this is the model file that we need in order to work on this disease prediction system. So similarly, you have to do this for this art disease prediction and Parkinson's prediction as well. Just go to the file explorer. If this is the art disease collab file, so you just need to upload that specific dataset file that we have worked on. So here you can see this art.csv. Okay, so once you have uploaded this, once your system is connected, just go to runtime and click this run all. Okay, so I will be sharing you all these collab files as well. So these are all the features that this particular data set contains. So we have age, sex, and so on. And finally, we have this target. So this target is nothing but whether a person is having heart disease or not. So if it means 1, that means the person is having heart disease. If the target is 0, that means that person doesn't have heart disease. So this is what we have represented in our web app. So if you go to this art disease prediction, so we have this age, sex, chest pain types, and so on. So that is what we have in this particular data set file. Okay, so I'll show you how we can determine what these features means and so on. But for now, understand that we just have to upload this data set file and just run all the cells, and you will get this model. So again, save this file and do this for Parkinson's as well. So in this case, you have to upload the Parkinson's data set and so on. So I'll just show you that as well. So I'm uploading the Parkinson's data, which is parkinson's.csv. As I've told you, we have worked on this in these videos. So if you want a detailed explanation of what we are exactly doing in this case, so please watch those videos. Okay, so here we have, so this parkinson's.csv is uploaded. Now I'll go to this runtime and run all the cells, and this will create the model. Okay, so as we know that we are saving the model in this case, so using this pickle, so import pickle, and I'm saving the model as Parkinson's model.save and dump model. So this model is nothing but, so we are loading our SPM. So in this case, we are using the support vector machine model, and we are loading this, training the model and evaluating it, and then we are saving this model in pickle. So these are like simple steps. So you just have to go to this individual collab files, upload the data set, and finally run all the cells so that your model file will be generated. Okay, and once these files have been generated, so you just have to go to this options and download these files. Okay, so I'll also give this model files as well if you don't want to run all these collab files and so on, but I suggest you in order to to run all the cells, so that will be better exercise. So okay, now I'll close this one. So I've already saved this model, and I have put all these things in this folder in my desktop. So this folder called as saved models will contain these files. So diabetes model.sav, rdisease model.sav, and Parkinson's model.sav. Okay. So these are all the models that we are going to use in order to make predictions in this particular web page. Okay. This Streamlit web page. Okay. Now let's try to build this UI aspects of this app. Okay. So for this, you need like 3 important libraries. So I'll go to this Chrome, and the libraries that you need are Streamlit options menu. So first is you need pickle in order to load the pickle files that we have created, or the SAV files that we have created. So just you can search as pickle pypi. So where if you go to this pypi, so you will get this command to install this specific library. Similarly, you can go to Streamlit pypi, and you can install this Streamlit library. And then the important thing is installing this Streamlit options menu. So this is like a add-on library that we have for Streamlit in order to create the sidebars. Okay, so we have seen the sidebars, right? So here we can, so we have created the sidebar. So using this Streamlit options menu library, we can create this good sidebars that we need. So that is the purpose of installing these 3 libraries. So you just need to go to this, copy the command here, and you need to come to your Anaconda navigator. So in this Anaconda navigator, so we have the swarm and we have this environment. So make sure which environment you are running. So I have this base root environment. I have created as another environment called as machine learning. If you don't understand what I'm talking about in this case, so just go to that playlist, watch this first video. So in this video, I've explained what does this environment means and how to create this environment, how to install libraries and so on. So in this environment, you just have to go to this play symbol, open terminal and paste the command that we have copied. Okay, pip install Streamlit option menu. So this will install that specific library. So you have to do this for pickle, Streamlit and Streamlit option menu if you don't have this library already installed in your system. So apart from that, you need this NumPy library pandas, the basic libraries and all those things. Okay, so that is another like mandatory thing. And so I've already installed these libraries, so I'm not running this one here. So sometimes you can get a error as access denied when you run this particular commands. So in that case, what you have to do is, so yeah, you have to run your Anaconda navigator as administrator. So if I search this Anaconda navigator, you can see this run as administrator. So in that case only your libraries will be installed. So that is another thing that you need to remember. Okay. So the next step, as I've told you, will be installing the specific libraries that we need. So the first step is, capturing or saving this model files. And the next thing is installing the libraries that we need. The three main important libraries, which are Streamlit option menu and pickle. Okay, so Streamlit is for deploying this as web app. Streamlit option menu is for creating the sidebars, and pickle file is for loading the models. Okay, so I'll close this one as of now, and I'll close this file. Okay, so let this be here. And the next thing, yes, we can go to our spider. Okay, so here, so this is where we will be creating the UI for our web app. So this will be completely done in Python, and for this only we need Streamlit library. Okay, so the next thing is, I'll go to my desktop, I'll create a folder, and I'll name this as multiple. This is prediction system. Okay, so multiple disease prediction system. So this is where I'm going to save all the files that I'm working on. Okay, so now I'll just close this Streamlit one. So this web app has been created already, so I'll close this one. So let's build this from scratch. And as I've told you, if you want, you can watch this playlist in order to get a better understanding of all the things that we are doing here. So I'll close this one as well. Let's have these three collab files as of now. Okay, now I'll go to the spider. So I have an untitled file. So this is just an empty file that we have. And if you want to create a new file, just go to this file and create new file. Okay, sorry. So you have to go to this new file. So a new file will be created. And now just press Ctrl plus S in order to save this file. And I'm going to save this file in the desktop, where I have created a folder called as multiple disease prediction system. And I'll rename this file to multiple disease spread. Okay, where it stands for prediction. Okay, so this is where we'll be doing all the coding aspect of things. So in this is multiple disease spread.py file. Okay, so the first thing is importing the libraries that we have just installed. The first is I'm importing my pickle library, which is used to load the saved models. And then we have this import Streamlit, and I'm going to import Streamlit in a short form as ST. Okay, so where ST stands for Streamlit. And finally, from Streamlit option menu. So this is the third library that we have installed. I've told you, right, the add-on library that we need in order to create the sidebars. So from Streamlit, import option menu. So this option menu is the function that will help us to create those sidebars. Okay, so we have done this. Now we have to load the models, as I've told you. So we have downloaded the models from this file explorer, right? So we have like downloaded those three models. So first is our diabetes model, then the art disease model, and finally the Parkinson's disease model, right? So we have saved this model, and I have kind of copied those model files to this folder called as saved models. Okay, as you can see, so a diabetes model is for predicting diabetes, art disease for art disease prediction, and finally we have the Parkinson's model as well. So I'll just cut this particular folder and I'll just paste it in this multiple disease prediction system folder itself. So here I have this Python file, which is multiple disease spread.py, where we will be writing our Python codes, and we have this second folder called as saved models, where all my models are saved. Now we have to load all these models in our Python file. Okay, so using pickle. So let's see how we can do that. So this is loading the saved models. So we have to load all those three models. First, let's load our diabetes model. So I'm naming this model as diabetes model. So you can just name this anything. So this is just a variable that we are creating. And so we have imported this pickle, right? So we have to say pickle dot load. So previously, in order to save the models, we have used pickle.dump. Okay, so dump will save all those parameters of the model into a file called as Parkinson's model or diabetes model or whatever the model that we are saying. In order to load that saved model, we have to use this load function from pickle library. So it's pickle.load and we have to say open. Okay, and within this open, we have to mention the path of the model file. So this is for diabetes model, right? So I'm going to this folder. Okay, so the saved model. So I have this multiple disease prediction system folder. In that I have the saved models, right? So go here and copy the path. So this is the path of this. So go to File Explorer, copy the path and just paste it in this open. So this should be pasted within quotes. So you can use either single quotes or double quotes. Okay, so it's up to you. Okay. So I'll use single quotes here and I paste this path of the folder, which is my saved models folder where all the saved models files are located. Here the main thing that you have to note is, so here we have like backward slashes, right? So you have to replace all those backward slashes with forward slashes, so then only spider kinds of understand that it is the path of the file that we are mentioning. So we know that we have created a folder in this desktop, so it is in desktop multiple disease prediction system and in saved models folder, right? So after the saved models, you have to mention the name of the file that we are loading. So this one is for diabetes model. So we have to mention the name of the diabetes model file. So I go to the saved model, I'll click this and I'll go to rename and I'll copy this entire thing, which is diabetes underscore model dot save. So you have to like do these steps very carefully. So here now you can see, so here we are creating a variable called as diabetes model, and this is where we are loading the saved model. So pickle.load open, and I'm mentioning the path of the file where the diabetes model has been saved. So diabetes underscore model dot sav, which is my saved file. Now I'll just copy this entire thing and I'll just paste it here. Okay. So the first line is for loading the diabetes model, and now let's load our art disease model. So let me put this. So instead of diabetes, let me write this as art disease model. Okay, so art disease model, and here you have to change the name of the file. So all these are in the same location, so we know that, so we just have to change the location of the file. So this is art disease model, just click it, go to rename. Okay, so just go to this rename and copy all those things, art disease model dot sav, and here we have this diabetes model dot sav, right? So just replace it. So this one is for loading our art disease model. So similarly, we have to do this for Parkinson's model as well. So I'll copy this one and I'll paste it here and I'll replace this diabetes with Parkinson's. So these are the three diseases that we are considering as of now. So if you want, you can also refer my breast cancer prediction video, and you can also include, along with these three diseases, you can build a breast cancer disease prediction model as well. So this is just, a demo or something. So it's not that you have to use only these diseases. So you can use this in order to build prediction system for other diseases as well. So this is just like a template that you can use for a later time. Okay, just a sec. Okay, so now we have to rename this diabetes model.sav to Parkinson's model.sav. So I'll go to rename, copy the name of the file, and I'll replace this here. So here we are loading all the three models. First, I'm loading my diabetes model, mentioning the path of the file, and the main thing is we have to replace the backward slash with forward slash, and then mention the name of the file, which is diabetes model. The second one is art disease model, and finally we have Parkinson's model. Okay, so the next thing that we have to do is create the sidebars that we have seen before. Okay, so this is where we will be using this Streamlit option menu. Okay, so here as you can see, we have imported this option menu right from this Streamlit option menu module. So let's see how we can use this. So this is for sidebar for navigation, where we can navigate to different diseases for which we have to make the prediction. Okay, so just save with sidebar st.sidebar. Okay, so this st is nothing but the Streamlit library that we have imported. So this Streamlit library as a specific module or a function called a sidebar, where we can create this sidebar or navigation bar. In order to have better sidebars, we are including this add-on library, which is Streamlit option menu. So in this, we can create a variable called as selected or select. So whichever you want. So again, this is a variable name. So here I'm going to call this function option menu. Okay. So option menu, and here we have to name this as, let's say, multiple disease prediction system. So you can just put multiple disease prediction system using ML or whatever you want. So it is completely up to you. And I'll just put a comma here, and now we have to create a list. So this list is for what are all the different pages that we want. So as we know, this is multiple web app, multiple page web app, as we have seen before, where in each page you can predict for different diseases, right? So here you have to mention the name of the different pages for which we are creating. Okay, so that is the purpose of this. And so I'll create a list with this square brackets here, and the first element will be uh, diabetes prediction. Okay, and next thing will be heart disease prediction. So these are just titles for our pages. Heart disease prediction. And so after this name you have to just mention a comma here, or else you will get an error. And finally we have this Parkinson's prediction. Okay, and let me put this icons predictions. Okay, so let's go to this icons later. Let me include another parameter, which is a default index. So I'll explain you what this default index means in a second. Is equal to 0. Now let's uh, okay, so there is an error. Expression cannot assignment perhaps. Okay, so let's worry about it later. So selected is equal to option menu multiple disease systems, and yeah, so default index is equal to 0. Let's see whether this one is running. So for this, I'll go to this multiple disease prediction folder. So here I'll just create a text file. So this is just for command. So I'll name this as Streamlit run command. So this is how you can run the file that we have created just now. So that is the purpose for it. And so the command that we have to use is Streamlit run, and here you have to mention, so there should be double quotes, and within this double quotes you have to mention the path where this Python file is situated. So it's multiple disease prediction system, and mention that path. And here you should not replace the backward slash with forward slash. Okay, so here it should be the backward slash. And now copy the name of the Python file that we have created. So I'll copy this one and I'll put it in this notepad file, and use the closing double quotes. Okay, so we have Streamlit run and the path of the Python file that we have created. So we have to use this command in order to run this Streamlit web app. So now you have to go to your Anaconda, and this is the environment that I'm working on, which is like the machine learning environment. So if you're working on your base environment, you can just go to this and you will see this play symbol near this base root. So I give this here, you will find an option called as open terminal, the same place where we have used the pip install command to install libraries. So here we have to paste the command that we have copied here. Okay, so which is Streamlit run and the path of the Python file. So let's paste it. This will open a page in Chrome or your default browser. Okay, so this is the local host in which we are running this. So diabetes model, so there is some error in this case. Okay, so let me check this one. So multiple disease prediction system. Okay, diabetes prediction. Expression cannot contain end. Okay, so selected is equal to option menu multiple disease prediction system diabetes prediction. Okay, so here we have used full stop, so that is the reason that we are getting this error. So I'll save this one, and this file has been changed. So you can see here that the source file has been changed. So you have to refresh this page in order to give that a particular change. Character maps. Hmm. Okay, so I'm just getting an error. So I'll just complete the remaining part of the few part of this code. Let's see whether it is running in that case. And now I have to say the first is diabetes prediction page. Diabetes prediction page, and if selected is equal to selected is equal to, we have to copy this diabetes prediction. So I'll explain you what I'm doing here. Just give me a moment. So diabetes prediction. So if this has been selected, we have to give the title of the page as, so let me put this as page title. So in the sidebar, we have to choose whether we want to go to diabetes prediction or heart disease prediction or Parkinson's prediction. Okay. So once we give that one, so it will go to the respective if condition. So we have the page title. So let me put this as st dot title, t dot title, and let's name this as diabetes prediction using ML. Okay. Now we have to do the same thing for heart disease prediction and the Parkinson's prediction as well. So let me put this as if this selected, so I'll open a bracket here. So if this selected is equal to heart disease prediction, so just copy this and paste it here. If the user chooses this one, in that case, the page title will be heart disease prediction using like using ML. So if you don't understand this, don't worry. I'll just explain this once I complete this one. Let's put this as heart disease predictions or heart disease prediction using ML. And finally, we can have this for Parkinson's prediction as well. So let's copy this Parkinson's prediction, paste it here. And if Parkinson's has been selected, the name of the title of the page should be Parkinson's disease predictions or Parkinson's prediction using ML. So you can give any names here. So I'll save this one, and now let's see whether the page is working or not. Okay, still I'm getting an error. So let me just check what this error is. Okay, so the reason we are getting this error is, so while saving the models, we have written this file, this diabetes model.sav file as bytes format. So that is what like this B represents. WB represents writing this file in a bytes format. But while loading this file or while reading this file, we didn't mention that it should be in the form of bytes. So that is the reason for this error. So this can be solved by including just this RB after this path. So here we are mentioning the path of the model file, right? So after mentioning that path, we have to just put a comma here and say RB, which stands for reading the file as bytes. Okay, so let's put that for all the models that we are working on. So just put RB. Okay, so here as well. So comma RB. Now this will resolve our issue. Okay, now I'll go to this page that we are working on. So just a second. Okay, so I'll go to this multiple disk spread which is running on our local host. I'll refresh this page, and now we will get our UI working. Okay, so we have created this multiple disk prediction system. So if we go to this spider, so this is what we are creating. So we are creating this with st.sidebar. So this particular line of code will create this sidebar. So you can just close this one or you can open this one. So that this is the purpose of this with st.sidebar, and selected is equal to option menu. Okay, so in this selected, we have different menus or different pages for which we are creating this, right? So first we have this diabetes prediction, and then we have this heart disease prediction and Parkinson's prediction. If you see this line, which is multiple disease prediction system, so this is what we are showing in this case. So you can see this multiple disease prediction system. You can also like put using ML if you want here. So if you just put this as using ML, and let's save this with control plus yes. And now if you go to this page and refresh this, so this will be saved here. Okay, so multiple disease prediction system using ML. So for now I'll just remove this one. Okay, so let it be multiple disease prediction system. Okay, now I'll run this one. Okay, so I didn't save this file. So once you change the file, just press control plus yes. Now you can go to this refresh. Okay, so yeah, so now this change has been involved. So I hope you remember how we are opening this local host. If you don't, I'll just show you again. So I'll just close this one which is already running. Okay, so you have to create this line which is streamlit run. So it's streamlit run, and you have to mention the path in which this Python file is situated, which is multiple display.py. If you remember, I have created a folder in my desktop, so this is where my file is. So you have to mention this. So Streamlit runs the path of the Python file where we are building the Streamlit UI. So I'll copy this. So after copying, I have to go to my Anaconda navigator to this environment, and with this play symbol I have to give open terminal. So here once you paste this, so your local host will be opened in your default browser. So my default browser is Google Chrome, so it's opening there. Okay, so here you can see my multiple disease prediction system. Now, so what we have mentioned here is selected if the user select this diabetes prediction system. So if the user select this diabetes prediction, then we have to open a page where the title is diabetes prediction using ML. Okay, and next, if the user select heart disease prediction, it should open the page where the title is heart disease prediction using ML, and similarly for Parkinson's prediction. Now you can go to this page and you can select this heart disease prediction, and now you can see the title change, and now we have this Parkinson's prediction using ML. So you can change the titles if you want. So that's what we are doing here. Now in each of this page, using the models that we have loaded, we have to build this system where we can get the input from the user and predict whether a person is having diabetes or heart disease or Parkinson's. So that's what we are going to do in the next step of our code. Okay, so, and I've told you, right? I'll explain you what this default index means is. So default index is equal to 0 means when you open this navigation bar, or when it opens for the first time, the page which is selected is diabetes prediction. So this is my index 0. So if I put my index default index is equal to 1, then this will be the starting page. The R disease prediction will be my starting page. So I'll go to the spider, I'll replace this to 1, and I'll press Ctrl plus S to save this file, and I'll come to my page and refresh this. Now you can see this is in this R disease prediction. Now you can change this to diabetes prediction or Parkinson's prediction. So in this case, if you just put this as 2, so the default starting index, so the default selected page will be Parkinson. So I'll just refresh this one. So it will be in Parkinson. So that is the reason of mentioning this default index. So let this default index be in 0. So I'll go to this one and refresh this. So it will be in diabetes prediction. Okay. Now, so before going on to building those input fields and prediction models and so on, let's try to add some icons to this. So if you remember the final web page that I've showed you, we have some icons here, right? Now let's see how we can create small icons before this diabetes, heart disease, or Parkinson's. So for that, you can just search Bootstrap icons. Okay, so this Streamlit option menu supports this Bootstrap icons. So go to that page of Bootstrap icons. So just go to Google, search Bootstrap icons, and go to the first page, which is icons.getbootstrap.com. Okay, so here you can search for the icons that you need. So you can search relevant icons for this diabetes, heart disease, and Parkinson's, and so on. So you won't get that much icons, but you can choose the closely related ones. So I'll search something like health. Okay, so health. Let's put this health. So these are all the stickers that we are getting. And for art, let's see. So we have this activity, right? So this is the icon for activity. So I'll just copy this term activity, and here we can. So after this default index or before it, so we can just So I'll just go here, and I'll mention another parameter as icons. So icons is equal to, again I'm creating a list. So for each of these three pages, diabetes prediction, heart disease prediction, and Parkinson's prediction, we are going to specify icons. Okay, so that is the reason. So the first icon that I'm going to create is this activity. So main thing is you have to put that in quotes. Okay, and the next icon I'm going to select from here is art. Okay, so let me just search this art. Let's see. Let's just choose a simple one. So we have this art here, right? So let's put this art symbol for art disease prediction. So I'll copy this and I'll paste it here. Okay, so art. And finally for Parkinson's, just go and search as person. So you can choose any icons that you want. So I'll search as person. So this is the icons that I've used before. So just search the icon, copy the name of that icon, and paste it in this list. Okay. So here we have like three pages, right? So hence I'm like selecting three icons. So if you have four different pages, select four icons. So this is how this works. And after this list, you have to specify a comma. So I'll create some space here so that you can understand what are all the things that we are creating. Okay, so I'll save this one. So first is the title of the sidebar, which is multiple disease prediction system. And then this is the name of each of the individual pages that we are creating. Okay. And then we have this uh, the third thing that we have is our icons. So icons for each of the page, and finally the default index. Okay, so the index in which the when we open our page initially where it should be. So I'll save this and I'll go to my page. So I'll close this one. Let's go to this. So here you can see there are no icons. So there is some bullet points or something like this. So I'll refresh this page, and now you can see, so this is my activity symbol, this is my art, this is symbol, and the person symbol. So this is how you can create icons. So now we are into the main part of this code of getting the input from the user. So input is nothing but in this diabetes prediction, so we are predicting whether a person is diabetic or not using the factors such as pregnancies, glucose level, blood pressure, skin thickness, etc. So we have to create input fields with these terms. Okay, so that is the thing. And I'll go to this diabetes prediction. So this should happen when the person select this diabetes prediction. Okay. So we have this page title thing. So after that, you can mention that. So first thing I'm going to say is pregnancies. Okay. So pregnancies. But I think I have these things like already. So I'll just copy this one so that we don't waste that much time. So I'll explain you what this columns means. But for now, let's just copy these things. So first is pregnancy. Let's paste it here. And the second input is glucose. So the important thing, so this is like very important, so you have to note here is, so this should be in order. So this should be in order in which it is present in our data set. In our data set, it is present as pregnancies, glucose, blood pressure, etc. Okay. In the collab file where we are saving the models, if you come to the bottom of this page, so for column in x is nothing but the we are just converting this uh, you know we are just loading this data frame. So after like dropping the outcome column and so on, so this is our data frame. So from this I am extracting all the column names. Okay, so that is what I have written here. So I have created a simple for loop so that I can print the different column names that I have. So that is the reason for this. And for column in x dot columns, print column. So this part of the this code snippet will tell you the name of the columns that we have, which is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and so on. So this order should be maintained. So that is like very, very important. Okay. So in this, if you see, we have this pregnancies, glucose. So this order should be maintained. So similarly, in all other collab files, there will be the respective features that we need. So in this case, we have this EH, 6, CP, and so on. So if you wanted to know what these things means, just go to Google, search art disease data set. So let's search this as art disease data set Kaggle. Okay, so here it will be mentioned like what is the so it will be mentioned here like what those specific columns means. Okay, so here we have this age 6, so we know that age of the person, sex is the gender, and CP. So if you don't understand what that CP is, you can go here and see chest pain type is what is referred as CP. So you can go through and understand what these different columns mean. And similarly for Parkinson as well, so you can go to just Google and search Parkinson's data, and you will see the description of these columns. Okay, if you wanted to know about that. And for diabetes also, you can see like this is self-explanatory for diabetes. For other things, you can search the Kaggle data description. So this is the final web app that we have created. I'll just copy these things. I'll explain you what all of these things means. And then we have the skin thickness, right? Skin thickness, insulin, BMI. The next thing is the insulin value. Then we have BMI, right? Here we have BMI, diabetes pedigree function. Copy this one. And finally, we have age of the person. So this is the order for that diabetes data set. So I'm pasting this here. Okay, so I have to copy this entire thing. So diabetes pedigree function value. Okay, so I'll save this with Control plus yes, and now let's run our web app to see what are all the changes that are made. Okay. Hmm. Okay, so let's go here and refresh this page. Yeah, so when you select this diabetes prediction, so you will say, so this is where the user will give the input. Okay, so that is what we have created using this st.text input. So st, we know that we have imported the Streamlit library, and text input is for creating those input fields. Okay, so that is the purpose of it. And okay, so and then you have this, little things here, right? So we have some strings, so number of pregnancies, glucose level, and so on. So this is nothing but what we want to display above these input fields. Say, for example, the first field, we know that it is pregnancy number, right? So we can say that it is the number of pregnancies. So that's what we have mentioned here. So the second one is glucose level. So this is the string that has to be mentioned on top of the second input field. So we have number of pregnancies, glucose level, blood pressure value, and so on. And these are nothing but, so these should be like single word. So here this is a string, so we have like space in between them. So these are like variables, so we cannot like mention space. So that's why we have the skin thickness, diabetes pedigree function, all those things without any space. So these are nothing but are variables in which we will be storing the value given by the user. Let's say the number of pregnancies the person is giving us 2, so that 2 will be saved in this variable called as pregnancies, and glucose value, which is given by the user, will be saved in this value called as glucose. So once we get all these values, we have to feed all these values to our diabetes model, and it will say whether that person is diabetic or not. So that is the end result that we are interested in. So now let's see how we can do that part. So this one is for prediction. So this one is code for prediction. Okay, yes. So it's code for prediction. And here I'll create. Okay, so yeah, so here we have to create a empty string. So I'll call this empty string as diagnosis. Okay, so let's create an empty string. So in this codes, there is no space or nothing. So this is what we call as empty string. So there will be this opening quotes and closing quotes. So in this empty string only, we will be saving the end result. So the end result is nothing but it is a statement which says the person is having diabetes or the person doesn't have diabetes. Okay, so that's why we are creating this. And now let's do this prediction. So creating a button for prediction. So once the user give all these values and click a button, it will tell whether the person is diabetic or not. So that is the idea here. So creating a button for prediction. Cool. Now let's create an if condition. If st, so st, we know that it's Streamlit, and in Streamlit we have the function called as button. And let's name this button as diabetes test result. Diabetes test result. So once the user click this button, we will get the result. For getting the result, we have to pass this all these values. So all these feature values to our diabetes model, right? So here you can say if st dot button. So that means, so if st dot button means if this button is clicked, then we have to predict the output, which is, let's name this as prediction, which is diabetes prediction is equal to diabetes model. Okay, so this diabetes model is what we have loaded here. Just a second. Yes, so it is the diabetes model that we have loaded here. So I have this diabetes model dot predict. So we know that predict function, when you give the input values, it will give you the output, which is 0 or 1 in this case, where 0 means the person is not diabetic. If the value is 1, that means the person is diabetic. That is the thing. And in this predict, we have to give in the values. Okay. So pregnancies, glucose, blood pressure, skin thickness. So we have to give all these values. So first in the list goes, okay. So within this predict parenthesis, we have to mention all these values and mention like another, square bracket. So this is very important. Okay. So within this parenthesis, you have to create a list using the square bracket, and within this, you have to create another square bracket pair. So this is where you have to put all these values. So then only the model understand that we are predicting for only one data point or one person. So this is very important. So just create two square brackets and close it with two square brackets, and within this we have to give the values as pregnancies. Okay. So first value is pregnancy, and as I've told you, this order is very important. First is pregnancy, then we have the glucose level, and then we have blood pressure. So just use a comma to separate them. So this is just a list that contain all these values. So it is like there is nothing complicated in it. So we have the skin thickness, and then we have the insulin value, and after insulin we have BMI and diabetes pedigree function. Let me just type in BMI here. BMI and diabetes pedigree function and age. Okay, so this is the last one. This age. Let's paste it here. Okay, so first we have pregnancies, which is given here: glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. So as I've told you, we are just putting all these values in a list. Okay. So all these are in a list, and all this list should be enclosed in another square bracket. So this is just to tell the model that we are predicting for one data point. So that is the reason. So yeah, this pregnancies, glucose, blood pressure, and all those things and so on. So this is to give all these values to the model, and the model will predict whether the person is diabetic or not. Okay, so that is the reason. And so the end result is you will get either 1 or 0, so just like this, so which we have already worked on. So the end result will be a list that contain one value, so the value will be either 1 or 0. So now we have to check what is this value. So if this value is 1, we have to say the person is diabetic. If the value is 0, we have to say the person is not diabetic. So for this we have to create like another if condition, and this should be within this if condition. So once this button has been pressed, this diabetes test result button has been pressed, so this model will predict the value for all these values, and we will get the final result. So if this diab diagnosis or this diab prediction, okay, so diab prediction is equal to, oh, sorry, so this diab prediction of 0 is equal to 1. In that case we will say that diab diagnosis is equal to the person is diabetic. Okay, so let's change this to the person is, okay, so diabetic. Next is else. That means, okay, so this else should come here. So else we have to say diab diagnosis is equal to the person is not diabetic. Let's put this as not diabetic. Okay, I'll explain you what we are doing in this case, and the end result is we have to say st dot success. This st dot success will give us the diagnosis. Okay, so yeah, I think we are done with this one. So let's try to understand what we are doing. So the flow will be, so the user from this navigation bar or the sidebar will select whether he wanted to predict diabetes or heart disease or Parkinson's. Okay. So once he select this diabetes prediction, so it will open this particular page where the title will be diabetes prediction using ML, and we have this input fields: pregnancies, glucose, blood pressure, skin thickness, and so on. And we are like creating a null string or an empty string as diab diagnosis, and within this diab diagnosis, if you see, we are storing the final output which says whether the person is diabetic or the person is not diabetic. So that is the reason we are creating this empty string. And if so, there will be a button, and the name of this or the text over this button will be diabetes test result. Okay, so if the user click this button, so we are feeding all those values which are given by the user to this diabetes model which we have loaded here. Okay, so once we have loaded this, we are just predicting whether the value is either 0 or 1. So if the value is 1, then we have to say the person is diabetic. or if the value is 0. So else means if the value is 0, so this 0 means the list. So if you go here, so the final result won't be an integer value as either 1 or 0, so it will be in a list, and that list will contain the value as either 1 or 0. So that is how the model will predict the values. Okay, so if the value is 1, here we have to say, so if the value is, so this diab prediction square bracket 0 means the element within that list. So if that value is 1, we have to say the person is diabetic. Else, if that's not the case, we have to say the person is not diabetic, and st.success will display this result. So we are just creating this strings, and this st.success is another text bar which will display the results. I'll show you how all these things works. So let's go to this multiple disk spread. I'll just save this with control plus yes, and I'll go here and refresh the page. Okay. Okay, so you can see, okay, so diab diagnosis is not defined. Okay, so we have some error here. Diab diagnosis is not defined. Let me just click this one and see. Okay, so I just made a spelling mistake here. So it should be diagnosis. So I'll copy this one and paste it here. Okay, so that is the reason. Just press Ctrl plus yes, and here refresh the page. Yes, now we don't have any errors. So this is the input field where the user has to give in some values, and after that, once we press this click this diabetes test result, we will get the result here. So I'll show you how this one works for you for here. So let's go to this data set. So this is the diabetes that data set that we have worked on. So I'll open this and I'll fill in those values. Okay, so I'll select this one. Okay, so this is the diabetes prediction app. So pregnancy value, let's put this as 6, and glucose level is 148, and blood pressure value 72, skin thickness is 35, insulin level. So I'm just checking this for this first data point. Okay, insulin, the value is given as a 0, and BMI value it's 33.6, and diabetes pedigree function is 0.627. Okay, and the age of the person is 50. So in this case, the outcome is 1. So 1 means the person is diabetic. So after this, once we click this diabetes test result button, it should say that that person is diabetic because the actual value is 1, right? Let's see whether our model is predicting correctly. So I'll click this diabetes test result. So the person is diabetic. So it gives me the correct value. Now let's check this for non-diabetic person. That means the outcome or the value should be 0. So let's check for this particular data point. For this, in order to remove this, just refresh this page, so you will get this. And the number of pregnancies. So in the second data point, it's 1, right? So I'll put 1. Glucose level is given as 85. Yeah, so it's 85. And blood pressure value is 66. And skin thickness value is given as 29, and insulin value is again given as 0. BMI value, second data point, to 26.6. Okay, and diabetes pedigree function is 0.351. 0.351, and age of the person is 31. So it should say the outcome is 0, right? So that means it should say the person is not diabetic. So I'll click this diabetes test result, and it says the person is not diabetic. So this is how it works. So the user will give in all these values, and our model will predict whether the person is diabetic or not once this button has been clicked. So this is how this works. Okay, so you can open this navigation bar that we have. So this is what we are going to do for art disease prediction and Parkinson's prediction as well. So I'll show you quickly on the previous file that we have created, so that we don't have to waste any more time typing all these things. So only one change that I wanted to create is, so like we have like a lot of empty spaces here, right? So what I wanted to do here is, I want to like have number of pregnancies here and glucose level next to it and blood pressure value next to it. So I will be having 3 input fields in the same line. So that will be the next change that we will be doing. Okay, so for this we have something called as columns in Streamlit. Okay, so that is what is mentioned in this particular code. I'll explain you how this works. So let's make some space here, and here we have to say, so this is for getting the input data. Okay, so getting the input data from the user. Okay, so here I'm going to create columns for input fields. Columns for input fields. Okay, so here we have to create some variables as column 1, column 2, column 3. Okay, so is equal to st dot columns. So columns is again the function that is there in Streamlit. Okay, so columns of 3. So columns 3. The important thing that you have to note here is the number of variables that you are creating. So here we have created column 1, column 2, column 3. So we have created 3 columns, right? So the number here should be 3. If you are creating 4 columns, so that means if you want like 4 text fields or input fields near to each other, in that case you have to mention like column 4 as well, and you have to put st dot columns, and in the parentheses you have to mention 4. Okay, so after that we can say with column 1 I want this pregnancies. Okay, so I'll cut this one and I'll paste it here. And next I want column 2. So with column 2, so if you don't understand this, I'll explain you how all these things come together. So the next one is glucose. So I'll copy this and paste it here. Okay, and then we have column 3. So totally we have 3 columns, right? So it should be repeated. So with column 3 we have blood. Okay, so we have already completed this glucose, and the next thing is blood pressure value. Okay, so we have this blood pressure value. So once this column 1, 2, 3 has been completed, after that it again should be column 1, 2, and 3 because we haven't created column 4, column 5, column 6, and so on. So it should be column 1 again, and now it should be the skin thickness. So it's the same procedure. And now I would say, so this is just for creating those horizontal input fields. So instead of having these input fields like one after the other, we will have it like side by side. So this is another interesting feature that we have in Streamlit. So with column 2, so I've done this for the skin thickness, and now it's for insulin, right? Insulin with column 2, and again it should be column 3. For column 3 we have the BMI. So let me just put this as, so just give a tab here, and with column 1 again, tab with column 2. Okay, so yeah, that is all. So here we are just creating some columns. So we have created like 3 columns, and first column we have pregnancy, second column glucose, third column blood pressure, and then we are repeating it. So the second, and then we have column 1 skin thickness, column 2 insulin, column 3 BMI, and then diabetes pedigree function, age, and so on. Now let's save this. So I'm pressing Control plus yes now, and now let's see what is the change that is being implemented here. No, so this is the previous version that we have. So this is the navigation bar that we have. So I'll refresh this. So this is how it will look like. So this is like more compact, right? So this is why we are creating this columns. So the reason we have 3 columns here. So this is my first column, this is my second column, this is my third column. So the reason we have here is we have created like 3 columns here, column 1, 2, and 3, and we have given this st dot column of 3. So that's why. So if you want 4 columns, so you just have to include, after this column 3. So I will just put column 4, and in this 3, I will just mention 4. So that is what we can do here. So here we need like 3 columns is enough. That's why we are doing this. So let me just go to this page, refresh this one. Yeah, refresh this. So in this we have this number of pregnancies in the first column, and then there is skin thickness value, right? So the reason is, so we have with column 1, that means in first column we have pregnancies, and if you come here in the first column we have skin thickness, and after that diabetes pedigree function is in the first column. So if you go here, that's why we have these things in the first column, second column, third column. So this is like more compact, right? So in this, the user can give in some values to predict whether a person is having diabetes or not. So this is how this works. When we have to do all these things for you know for this art disease model and for Parkinson's model. So I'm not going to type in all those things because it is kind of repetition. So it is like almost the same thing. So I'm just going here and I'm going to just copy all these codes. Okay. So I'll just copy from this itself. Okay. So multiple disease prediction. So I'll copy all those things. So it's just a repetition. So as we have done for diabetes, we have to do this for heart disease and Parkinson's as well. So that is the change. So I'll replace all these things so that we don't have to do all these things again. Okay. Yes. Now let's see how all those things come together. So it is like the same codes that we have built before. So just I've completed for this art disease as well. So the only change that you will see here is for art disease we have different columns name. Okay, so age, sex, chest pain types. As I've told you, if you wanted to know what how I'm determining chest pain types, resting blood sugar, and so on, you just have to go to that Kaggle site in order to see the description. And we have the order in which we have to give the features. So age, sex, CP. So CP stands for chest pain, and then we have this TREST So here if you want to see, so that one is for resting blood pressure. So as I've told you, you can go to this and search for art disease dataset Kaggle, and here you will see the description of all the columns. Okay, so let this load. So you will see the column name. So similarly, you can find what those specific column means for Parkinson's as well. So it is like that simple. Okay. So the idea here is once the user select this diabetes prediction menu, so I'll just collapse this one. Okay. So let's try to understand the flow once more. So first we are like loading this models that we have saved before, and then we are creating this navigation bar where we have diabetes prediction, disease prediction, and Parkinson's prediction. So these are just icons and the default index that we have. So now if the user selects this diabetes prediction, so here if they click that diabetes prediction, so if I go here, if they click this diabetes prediction, this part of the code will be executed. So if they click art disease prediction, so if this art disease prediction has been clicked, so this code will be running. Okay, so we have this st.title as art disease prediction using ML, and here also we have like three columns, and the features are age, sex, chest pain types, and so on. Okay, so I'll close this one. Okay, so now if the user selects Parkinson's, and this will be running. So these are all the columns that we have. You can also refer this collab file, which I will be sharing with you. So these are all the column order that we have, and you can also see the Kaggle for those descriptions. I haven't given any description here. So here we are creating 5 columns as we have like several features in this case. Okay, so in this case, if the user selects Parkinson, so this part of the code will be running. Okay, so you can just collapse this here, or you can expand this here. So if you want, so it is like another feature that we have in Spider. So I'll expand this. So it all the things are like the almost the same. So the only difference is, so instead of the diab diagnosis we are creating this art diagnosis, and the name of the button is art disease test result, and here the features change age, sex, CP. So whatever the features that is present here. So similarly for Parkinson's, so this is the Parkinson's model that we have saved and so on, and finally it should give us the result. Now I'll just press this Control plus yes, and now I'll go to this uh, local host that we have created here, and I'll refresh this. Now let's see how our entire app come together. Okay. So this is the diabetes prediction. So you can give in some pregnancy number value, glucose level value, insulin value, and so on. So after that, if you click this diabetes test result, it will give you the result. If you go to this heart disease prediction, you have different features here. Okay, so age, sex, chest pain types. So here also we have like 3 columns. Okay, so after giving all those values, just go to this heart disease test result. The values you can refer here. So I will also share this dataset files with you as well. So I'll put all those collab files, all these dataset files, and these model files in a single folder, and I'll share you the drive link from which you can download it and you can run it for yourself. But I prefer you to write your own code so that you will get a better understanding of it. Okay, so we have this diabetes, art, and Parkinson. So you can go to this art, and you can just give in all those values. Okay, so we have this diabetes data, and then we have this R data. Okay, so this is the target. So apart from this target, you can give all these values. Okay, because like target is the final output to predict whether a person is having heart disease or not. So apart from this, you have to give this age, sex, CP, and all those things. If one means that it will be predicted that that person is having heart disease. If zero, if you scroll down, you will find the values, the target values as zero. This means like these person people doesn't have heart disease. So you can just look at those values and type in here for heart disease. And for Parkinson's prediction as well, you can check this particular data set. So this Parkinson's data set which contain like all those values, and make sure you are like giving correct values. So just look at this column name and fill in the corresponding values that we have here. So here we have like five columns as I've told you. So that's why we have like this one here. So after giving on all the values, you can like click this Parkinson's test result in order to predict this. So this is how you can create a multiple disease prediction system, which is basically a multiple page web app. Okay, where you can navigate to one or the other. So I'll close this one and I'll show you again how you can open this fresh. So I'll close this one also, which is already running. So here in this notepad file, so this is the path of this Python file in my system. Okay, so you have to replace this with where the path or where your Python file is situated in your system. So this is the main change that you have to do. Okay, so first thing is you have to change the location here or path of the file here depending on where you have pasted or where you have this Python file. And after that, you have to copy this entire thing and go to this Anaconda, open your terminal, and main thing is you have to install all the libraries, Pickle, Streamlit, and Streamlit option menu. So I'll paste this. So it will be Streamlit run, double quotes, and the path of the Python file that we have worked on. So press enter, and this will open your default browser, and you will have your web app ready. So now this is not a public app. So this is running in my local host. Okay. In the next video, I'll show you how you can put all these things in your GitHub repository and how you can deploy this as a public app where you will get a URL, and if you can share that URL with anyone and they can access this app and they can kind of see what you have built. So this will be like very useful for you to demonstrate your project in some interviews and things like that. So instead of showing them the code that you have worked on, so you can put this in GitHub and create this public web app, and you can share that URL with the interviewers where they can just see how you have built your app and so on. So I'll show you in the next video on how you can do that as a public app. And before that, so the other thing that I wanted to mention here is, so you have to change the path of the saved files as well. I hope you know this. So this is the path of the saved file in my system. So it is C user Siddharthan desktop and so on. So here I have this saved file, right? So you will be saving this models in a different folder. So you have to replace this path of this with where you have stored the models. So the diabetes model, heart disease model, and Parkinson's model. Okay. So these are the two things that you need to do. So one is change the path of this Python file depending on where you are storing it, and within this code you have to change the path of the models where you have stored. So these are all the two things that you need to do. Apart from this, the all the coding part are the same. Okay, so I know that this video is a bit large and it is like a bit hard to understand probably because of the number of things that we have done. So if you have any doubts, please mention in the comments. I'll try my best in order to clarify your doubts depending on how my time is looking. Okay, so that's it from my side. So please watch the next video as well where I'll be explaining you on how to deploy this as a public web app, which will be like really useful for you. And I'll give the link for all those collab files and this Python file and the models, etc. And as well as I'll give the link for the playlist that I've shown before, which you have to refer in order to, before watching this video. So that will be helpful for you. So where you can just click and check for different diseases. So I hope that this video is really helpful for you and hope you have learned a lot from this. Please practice this codes by yourself. So instead of running the file that I'm giving you, please write this code by yourself line by line so that you get a better understanding. And if you have any doubts, reach out to me. I'll try my using machine learning, and we have also deployed those machine learning models using Streamlit in localhost.
And in today's video, we are going to understand how we can deploy these machine learning models as a public machine learning web app. So this will be the agenda for today's video, and let's get started. So once you deploy this models as a public web app, you can share this link so that others can access it and see what it can do. So it will be very helpful for you in order to demonstrate how your machine learning models works in interviews, or to someone else who are interested in your projects. So this is how this is gonna work. Okay. So if you haven't watched the previous video, you must watch it in order to understand what we are exactly doing in this code. Okay. So this is just basically a disease prediction system where we are predicting multiple diseases based on certain factors, and for prediction we are using machine learning models. So that's the idea. And this video is all about how we are going to deploy this in public, and these are all the required files. So first I have this requirements.txt file which contains all the libraries that we need for our deployment. Okay. So we have numpy library, and then we have pickle. So this pickle library is used for saving the trained model and loading it in order to make prediction. And then we have, of course, Streamlit in order to make some simple UI for our web app, and Streamlit option menu. So this is just for creating the navigation sidebar for our web app. And finally, scikit-learn, which is used for for building our models and things like that. And here I have also mentioned the versions of the library that I need. Okay, so this is the first file that we have. And then we have three models files. So I have saved the models as .sav files, and we have this diabetes model and art disease model, and finally Parkinson's model. So these are all the three diseases for which we are going to make our prediction. And this MDPS, multiple disease prediction system public, is what contains our Streamlit and Python code in order to deploy this model in a simple UI. So you can see, so this is a Python code, and this is what we have done in our previous video. So I have explained you like what we are doing in this entire part of the code and so on. So if you don't understand this, please watch the previous video. I'll also give the link for that video in this video description. You can check that out. So the only difference that I made in that code and this code is, so here I have mentioned the path of this model file because it was in different directory. Now you should remove this path. So how this will be, like I have mentioned this local disk C folder name and so on. So here I have removed all those things. I have just mentioned this diabetes model.sav. So this is nothing but the model that we have saved. So this is this diabetes model, and then art disease model and so on, and we have all these things there. So we are putting this code, so this Python code and all these models in the same directory. So you don't need to specify the path of these saved files. So you just need to mention the name of the model files that we have. So this is our first model, a diabetes model, and then the art disease model, and finally Parkinson's model. So these are all the code for building our UI. So this is for creating the sidebar, the navigation bar, and this is for getting the input from the user in order to make the prediction for diabetes and so on. And then we have this for art disease, and similarly for Parkinson's as well. So these are the three parts of the code that we have. Okay. So the main thing that you need for this deployment is this Python file which contain all the Streamlit codes, and the three model files, and the requirement.txt basically contains the libraries that we need for this deployment. So that is all. So I'll put all these files in a Google Drive folder, and I'll share you the link. So this will be also posted in GitHub, and so I'll also give the link for that particular GitHub repository. Okay. So I'll close this one. So the only difference between the previous code and this code, as I've told you, is only that you have to remove the path here. Okay. So that's the thing. So I'll close this now. And now the next thing that you need is you have to create an account in GitHub. Okay. So just a second. So two things that we need here are, so you need an account in GitHub, and you need to create an account in Streamlit Cloud. So just go to Google and search Streamlit Cloud, and before creating an account in Streamlit Cloud, create an account in GitHub. So if you don't have an account already, please create one. And once you create this, you can create an account in Streamlit Cloud mentioning your GitHub account. Okay. So these two should be linked in order to kind of deploy this model in public. Okay. So this is very, very important. So this Streamlit Cloud account should be linked with your GitHub account. So then only you can access the files from this GitHub repository. So what we are going to do here is, so we have these files, right? So we have three model files, one Python file, and a requirement file. So we will upload all these files in a GitHub repository, and we will mention the specifications of this GitHub repository in Streamlit Cloud. So from this repository, the Streamlit Cloud will access all this file and deploy our app in public. So this is how it's gonna work. So once you have created your GitHub account, you can see this new option. So this is for creating new repositories. Okay. So I'll click this new. and then you have to mention the name for your repository. So I'll give a name here as public ML web app. Okay, so public ML web app. So this is basically a multiple disease prediction system. Okay, so you can also give different names as well. So I'm not going to give description and all those things. So if you want, you can give that as well. So, and the other thing is, so this should be a public version, because then only you can easily access in Streamlit cloud. Otherwise it becomes a bit tougher. So I'm creating this repository as public, so can anyone else can see this file. So that's the idea, and I will also share the link for this repository as well, so you can get the files from this repository. So I'm not going to add a readme file, so if you want, you can do it. So I'll create this repository now. So once this repository has been created, you have to upload the files that you have. So here you can create a new file or you can upload it. So I'm going to upload an existing file here. So choose your files. So I'm going to my desktop, and in this desktop I have this ML web app folder which contain all these files. So you need, as I have told you earlier, so you need this model files, so three SAV files, and you have this public. So MDPS stands for multiple disease prediction system public app, and requirement.txt. So we know what is the use of this requirement.txt, and I'll upload all these things. Okay, so once all these files are uploaded, we have to commit the changes that we have done. Okay, so that is the next step. So all these five files are been, uploaded to the repository that we have created, which is public ML web app. Okay, so I'm going to commit the changes. So this will basically upload all the files. So if you want, you can create a readme mentioning what does this particular repository contains, and what does this web app does, and so on. So I'll create a readme later so that you can understand what it does. Okay, now so this repository has been saved, so I can go to my profile. So this will create a repository. So I have like two repositories here. So this is the trial version that I have created, and here we have this public ML web app. So I'll go here and I can see all the files here. Okay, now as I've told you, go to Streamlit, create an account. Okay, so if probably you might not have an account here, so you can sign up here. So you can just use the free version as well, so no need to go for priced one for this simple deployment. Okay, so for price, of course, you have some other additional features, but for now we can use the free version as well. So I've created my repository, uploaded all the files, and now I have to sign up my account. So I've already created an account, and after that you have to link it. So that process is pretty easier. So once you want to sign up, you will get an option like sign up with GitHub and so on. So you can do something like that. So after that, so this is how once you have signed up, your UI will look like, and this is where we have to create our app. So I'm going to give new app. Okay, so this is my repository, and so this will automatically go to this page. So once you have created your Streamlit account, once you click this new app, so this will automatically mention the repository. So if not, you can just paste the GitHub URL. So what is the repository URL? So you can just paste it here. So if you have linked your account, it will automatically create. And in this repository, I have to mention like this is public underscore ML underscore web app, right? So I have to mention it here. So so this is public ML web app, and main. So you just have to see the branch. So here the branch is main. So I have not created any other different branches and so on. So it is the main repository that we have. So public ML web app main, and main file path. So it is the name of the Python file that we have. So in this case, the Python file that we have is mdps underscore public, right? So here it will also show it. Okay, so mdps public. So you have just have to mention the repository in which you are working on, so the main branch and public. So the main thing is your GitHub account should be linked to this. Okay, so if you have created your Streamlit cloud account with Google account, you can also later link it with your GitHub, but this linking is very must. Okay, so this is a mandatory process, and once we have done all these things, we just have to click deploy. And the main thing to note here is it should contain this requirement.txt. So only then Streamlit can access this requirement.txt file and see what are all the libraries that we need for our processing. So this requirement.txt is nothing, as I've told you. So you can just mention the name of the library. So if you want a specific version of the library, you can see this here. Okay, so if you want to understand what is the version of the library that you are having in your Python, in your Anaconda navigator setup, I'll show you how you can do that. So you can just go to Anaconda navigator. So it is opening, so we just have to give it a moment. So from there we can run the command pip list in order to see what are all the libraries that are installed and what is the version of each individual libraries. So I'll show you how we can do that. So that is how I kind of came up with this version number. So that is like an important step. So yeah, so here the environment that I'm working on is machine learning. So I've created a different environment. So if you haven't created a different environment, so it will be base root only. So I'll go to this machine learning. Okay, and then I'll go to this environments tab, and here you will see this play option. So from this, this will basically open your Anaconda command terminal. So I'll open this terminal for this environment, and this is where we will, try to deploy our Streamlit apps in localhost. So we will type Streamlit run and path of the Python file. So this is the terminal that we have, and in this, if you just put the command pip list. Okay, so this will give you all the libraries that are installed. Okay, so you can see the versions and the corresponding libraries as well. So you can see the libraries that you have already pre-installed. So the thing is, I'm assuming that you have already deployed this model in your local host. So as I've told you, it is explained in the previous video. So once you have done that, you can see what is the version that you have used for sklearn, pickle, and so on. So if not, you can just use the same requirement.txt file as I'm providing you. So that is not like a mandatory thing, but I'm just showing you how you can access it. Okay, so that's the thing. So you just have to open the terminal and put the command pip list. Okay, so it will tell you the versions of the library. So this requirement.txt file basically tells the Streamlit cloud that like these are all the libraries that I need for working of this app, and all you need to give is deploy. So this process is that simple. Okay, so this will take some time in order to install the required libraries, run the code, and bring the UI and so on. So your app is in the oven, so it is in the preparation stage. Okay, so this will take probably a couple of minutes or even soon in order to run our app. Okay, so you can see the logs here. So what are all the things that are being processed here? So this is where our libraries will be installed, and our Python file will be executed and so on. Okay, so let's wait for this to happen, and I'll show you how our final app looks like. So once this Streamlit web app has been deployed, you can share this particular URL, and here also you will get the URL. So you can kind of share that URL with your friends, or whoever you wanted to share it with. So it's not like it will run in your system alone. So you can share it across. So the best thing I can so seems like our app is successfully deployed. So let me just close this one. Yeah, so this is what we have built. So we have a sidebar, and here we can we have like multiple disease prediction system. First is the diabetes prediction. So this is what we have done in the previous video. So I have shown you how you can create this navigation sidebar, how you can create this input data fields, and so on. Then the second thing we have is the art disease prediction, and then the Parkinson's prediction, and so on. Okay, so the models are trained already. So you can see the diabetes model, art disease, Parkinson. So everything are already trained. So you can just download it and put it in your own repository, link your account to your Streamlit, and you can work on it. So it is like that simple. So I'll show you how you can kind of use this one. So I'll open this diabetes dataset. So I have this diabetes.csv. So on this dataset only, we have trained our machine learning web app. So I just wanted to check only one instance. So let's check for this one. So this is the first data point. Here the last value is outcome. So 1 means the person is diabetic, and 0 means the person is not diabetic. Okay, so let's put all these values in our web app and see whether how this result we are getting. Okay, so the values are 6, 148, 72 for the first three things. Okay, so pregnancies, number of pregnancies, the value is given as 6, and the next value is 148, right? So 148 is glucose level. So you can see this here, glucose blood pressure. So it is also given here. So 148, 72. So 148, 72, and 35, 0, 35, 0, 33.6 is BMI. 33.6, and then we have two things: diabetes pedigree function, which is 0.627, 0.627, and finally we have age of the person as 50. Okay, so the output is 1. That means our model should say that this person is diabetic. Okay, so 1. So once I click this, I will get the result. So the person is diabetic, so this is the result. So what happens is, so all these values will be passed to our diabetes model.sav, the model which we have built, and it will give us the prediction as 1. So when it is 1, we have to say that the person is diabetic, and if it is 0, we have to say the person is not diabetic. So you can also see this in the Python file that we have uploaded. So this is for this diabetes one. So we have created this diabetes prediction. So this is the title of the page which you can see here. So diabetes prediction using ML. So that's what we have done using this ST, which stands for Streamlit. So we have imported Streamlit as ST, and title, which it tells that column means I want like these input fields in 3 columns. So that's what we have this, that's why we have that here. And once we have given all these values, so this will be passed on to this diabetes model dot predict. So we give all these features: pregnancies, glucose, blood pressure level, and so on. So if the value, if so this will be basically in a list, and in this list, if the value is 1, we have to say the person is diabetic. If the label is 0, we have to yes. So that's why we have this else condition is 0, we have to say the person is not diabetic. And this is how it works for our disease prediction and Parkinson's prediction as well. So you can see this our disease prediction, this as well. So it basically has different features, and Parkinson's prediction again it has different features and so on. So after giving all these values, we have to click this Parkinson's test result, and it will give you the diagnosis. So this is how this works. And you can kind of like share this UI across, and it will work. Okay, so this is how you can create a multiple web app. So that person need not do anything, so they can just go to this this particular URL, and they can just put in some values in order to understand whether that person will have diabetes, or whether that person will have disease, and so on. So they just need to put in some values for that, put in some values in these fields in order to understand what is the test result is. So this is how this public web app works. You can also like do some more things as well. So so I can go to the settings. I can also like like few things. Okay, so okay, yeah, yeah. So here you can go to the settings in order to change the theme. So if you want a dark mode, you can use it. So your app looks like this in dark mode. So you can do that if you want, and you can go here, and you can see the wide mode. So wide mode will kind of look like this. So these are some basic things that we can do. And yeah, so this is how you can deploy your public web app using Streamlit in Python. Okay, so I hope everyone understood this. So the main reason that I've told you is it will be very helpful for you in order to demonstrate your machine learning project. So instead of just putting in some data set, training your model, and doing some predictions, if you do this, it will look like a complete project. So if you are going to some interviews, so the best thing would be to deploy this model in Streamlit or some other means, and providing this URL, so that the interviewer can see this firsthand on how your app looks like, and what are all the different features that you have, and so on. So I hope you understood all the things that is covered in this video. I'll share the link for this GitHub repository, and I'll also share the link for all these files. So this Python file, and the model files requirement.txt, and so on. Okay, so you can access it, you can put it in your repository, and you can try to deploy this
models as a web app using Streamlit, and we have also hosted these Streamlit web apps on Streamlit Cloud. Later, we have discussed how we can deploy the machine learning models as APIs, and we have also hosted these APIs on Heroku. And in this video, we are going to discuss how we can deploy this machine learning web apps that we have built using Streamlit on Heroku. So this will be the agenda for today's video, and let's get started. So the ML web app that we will be deploying is the multiple disease prediction system that we have worked before. So In this video, I have explained you how you can build this simple UI using Streamlit, where we are building a multiple disease prediction system where we have different machine learning models working in order to predict whether a person will have diabetes, or we are, a person has heart disease or Parkinson's. So this is the multiple disease prediction system that we have worked before. So this is the video that you might need to watch in order to understand how we can build this. So I'll give the link for this video in this video's description, so you can check that out before going with this particular video. Okay, and for this we are going to use GitHub, where we will be uploading all the files that we need. Later we will deploy this machine learning web app on Heroku. Okay, so let's try to understand how we can do that. So you need like two files for this. One is the proc file and the another one is the setup.sh file. Okay, so I'll open this proc file. So it contains this particular line. So you have to create a text file like this. So I'll show you what you can do. So just create a notepad. So here you can just create a text file using notepad, and I'll give the link for these files to you. So just copy this text, or just like watch this text and copy all these details and put it in a new file. And here just save this as proc file, where P has to be in caps. So let me put this as proc file, and I'll just delete this one because it is already present there. So I'm creating this proc file and it will be saved as a text file. Okay, now if you see, this is what it contains. It contains like web sh setup.sh and streamlit run app.py. So I'll explain you what these things means. So setup.sh is the file that we have to create now, which contain like these details, and app.py is the Python file where you are building your Streamlit app. So these are all the files that you need. So this app.py, so this is where we have like written the Python script in order to load this machine learning models that we have built. So all these are explained in the video that I've shown you before. So we have this diabetes model, heart disease model, and Parkinson's model, and we are creating the navigation bar and so on. So like this basically contains three pages, where one page is for diabetes prediction, second page is for heart disease prediction, and the third is for Parkinson's prediction. And we are using this Streamlit library and so on for building this. So name this file as app.py, and that is what should be mentioned here. Okay, so Streamlit run app.py, and these are all the models that we need. So diabetes underscore model.sav, and then we have heart disease model and Parkinson's model. So we are like loading these models from this line. So we are loading these three models. Okay, so later we have this requirement.txt, which contains all the libraries that we need. So we have the NumPy library, pickle, which is used for loading, the saved model, or for saving the trained machine learning model, and so on. And then we have the Streamlit for building this simple UI, and then Streamlit option menu. So this is used for creating like navigation bars for our web app. And then scikit-learn, of course, for machine learning models. And then we have this protobuf. So this protobuf is, we need to like mention this, and this is like a requirement from Heroku's side. So if you don't mention this, you probably get an error because of this version errors and so on. So it's better to include this protobuf in this requirement.txt. So you can like mention this, versions, or you can like run this without the versions as well. But make sure you mention the version for this protobuf. So this is like very important. Okay. So I close this one. So these are all the things that you need. And then we have this runtime.txt, which basically tells you what is the Python version that you wanted to install. So here I mentioned 3.9.6. So these are all the files that you need. First is the Python file, where we are writing the script for loading the machine learning models and building this Streamlit web app. And then we are like putting together all the trained machine learning models. And then we have the proc file, which I have like shown you how to create. And then we have this requirement.txt, which contains all the libraries. And finally runtime.txt, which contains the version of the Python that you need. And now let's see how we can create this setup.sh. Okay, so I'll open this. So I'll put all these files in a GitHub repository, share that link. I'll also put all these in a Google Drive folder. I'll also share you that link, so you can get those files from there. So don't change any details here. So this is like the default file that you need. So one is the proc file and the another one is the setup.sh file. So I'll copy all these things, and I'll just delete this particular file and open my notebook. Sorry, I'll open my notepad, and I'll paste this, and I'll save this as setup.sh. Okay, so let's save this. Okay, so here you can see, so it is not saved as a txt file but as an sh file, and the proc file contains these details. So one is the setup.sh file. So here we are mentioning that we wanted to create a web app, so that is the purpose for it. So this is for the Heroku system to tell that we are interested in creating a web app, and the details about this are present in the setup.sh, and the Python file that it has to run is app.py, and Streamlit run is the command. So app.py is nothing but the Python file that we have created. So if you rename this app.py to something else, make sure that you are renaming it here as well, but try to give the same name here as well. So we have this procfile.txt. Now I'll close this. So here, rename this file by deleting the extension. So delete this .txt. So you will just have this proc file. So I'll just give you a yes. So your proc file is created. So the two main files that we need are setup.sh and proc file, and this should not contain any extensions. So I have like all these things ready already in this particular folder. So we have this Python file, and we have the three saved models, and then we have this proc file requirement.txt for mentioning the libraries, runtime.txt for mentioning the Python version, and finally setup.sh. Okay, now we have to like upload all these files to our GitHub repository. Okay, so make sure you create a GitHub account and like use the same Gmail or email ID for Heroku. So you cannot like create a GitHub account with a particular email ID, and you cannot like create a Heroku account with a different email ID. So in that case, your GitHub won't be connected to Heroku. So this is like one requirement. Make sure you are using the same mail ID for GitHub as well as Heroku. Okay, so now let's create a new repository, and I'll name this as Streamlit app Heroku. Okay, so let this be public. So if you want, you can also make that as private. So here you can just mention some description you want. So this is like deploying machine learning web app using Streamlit on Heroku. So you can, so this is like optional. You don't have to give this description, but just mention like what you are creating here. So I'm creating a public repository, and here I can give this create repository. Okay. Now, from here I can upload all the files that I have saved. So I'll give this uploading an existing file. From this you can like choose your files. So I'll go to this desktop where I have this particular folder called Streamlit app on Heroku. So you need like all these files. So I'll select all these files and click this open. So this will upload all the files that we have. And in total we have about 8 files. Okay. So all the files are uploaded. Now I can give this commit changes. So this will create my repository, and you will see like what are all the files that we have. So you can click this proc file to see its content. So I'll give the link for this repository, and you can copy this line from here and you can create your own proc file. Make sure that this proc file doesn't have any extension. And you can also create the setup.sh. So you can go to this repository, click this setup.sh, and you can like see this content. So you can just copy this and create a new setup.sh. Make sure you don't rename this proc file or setup.sh, and requirements and runtime. So all these things should have the same name. So in proc file, P should be in caps. Okay, and these are all the other files that we need. So now we have successfully created our GitHub repository. Now I'll go to this Heroku site. So make sure like you have logged in using the same email ID. So in this case I have like logged in with the same mail ID for GitHub and Heroku, and here we can create this new. So this is the previous video that we have worked on where we have deployed these ML models as APIs. Now I'll give this new, and let's create a new ML web app. So let's name this as Streamlit app or Streamlit on Heroku. So you can give any name that you are interested in, or let me put this as multiple disease prediction. Okay, yeah, so this name is available. So I'll create this app, and you can just choose this region to United States itself, so you don't have to change that. So let's create an app here. So all the process are like pretty simple. It's not like that much complicated at all. Now we are going to connect our GitHub account. So this is the like YAML app that we are going to create in Heroku, and here I'll give this connect to GitHub. Now we have to like give the name of the repository that we have created. So the name of this repository is Streamlit app Heroku. So you don't have to give the entire name. So you can just say Streamlit. and it will show all the repositories that begins with the Streamlit. So you can see Siddharthan23, which is my GitHub username, and Streamlit app Heroku. So this is the repository that we are working on. So like here we have to give this connect. So this will like take all the files from that repository. So we are just basically linking that repository to this Heroku system. And you can see the branch. So here we are not like creating any other branch, so we just have this main branch, so like we don't have any issue. So if you are like creating a different branch, in that case, like mention like what is the branch that you are working on. So after that you can click this enable automatic deploy. So after that we have to say deploy branch. Now it will like go through this runtime.txt file and see what is the Python version that it needs to install. So here you can see, so it's installing a 3.9.6, which is the version of the Python like version that we like mentioned there, and it will like install all the libraries that we have mentioned in our requirements.txt. Okay, so this will take a few minutes depending upon the app that you are working on. So in this case it will probably take a minute or two. So once this is complete, you will get a public URL, and like anyone can access that public URL and see the app that you have created. So where this will be helpful is, it's let's say that you are about to attend a machine learning or data science interview, and let's say that you have worked on, let's say, 5 or 6 use cases related to machine learning or data science. Instead of like showing the code or like just explaining what you have done, it's always better to create a simple UI for your machine learning model that you have built using Streamlit or Flask, and then deploy these machine learning web apps on Heroku, and you will finally get a public URL, right? So you can just share that URL to that interviewer, so that they can easily go through like what is the thing that you have worked on. So this will make a really good impression. So this would be something that like something like good to do in an interview. So this is the other thing, and I think it's about to get complete. Okay, so it's almost done. So this will be the URL for our ML web app. So let's wait for it. So if there are like any errors in your system, or any errors in the deployment, you can see what that particular error is by going to this more and view logs. So this view logs will tell you if there are any errors. So from that you can like kind of rectify that. So that is like other thing that you can remember. So this is taking some time. Yeah, now it is ready. Now I can just click this view, and this is the URL for my machine learning web app which we have hosted. So here you can see, so we have this navigation bar, and the first one is for this diabetes prediction using ML, and we have all these features, so the number of pregnancies, glucose value, and so on. And then we have this heart disease prediction and the Parkinson's prediction, and so on. So let's try this for this diabetes prediction. So I have this data set here in my desktop. So let's do one thing. So let's copy this first data point value and try to predict whether a person has diabetes or not. So if this outcome is 1, that means the person is diabetic. If this outcome is 0, that means the person is like not diabetic. So let's first like put these values. So first is like 6, 148. So the number of pregnancy is 6 and the glucose value is 148. So let me put that here. So number of pregnancies is 6 and glucose level should be 148, and blood pressure value is 72, and skin thickness 35, insulin 0. So 35, 0. And the next one is the BMI value, which is 33.6. So it's 33.6. And then diabetes pedigree function. So this value is 0.627 and age is 50. Let's give this as 0.627 and age of the person is 50. So now let's click this diabetes test result, and it will show that the person is diabetic. So here we can recheck whether the outcome is 1. So in this case, the outcome is 1. So the person is actually diabetic. So you can also check this for label 0. So you can check this for the second data point and see whether it says the person is not diabetic. Okay, so it will work. And if you want, you can like go through this heart disease prediction and Parkinson's disease prediction and so on. So as I've told you, I have explained, how to build these models and how to create this UI using Streamlit on this particular video. So please watch this video if you are not sure, how to like create this UIs and things like that. Okay, so let me just quickly show you how all these things comes together. So here you have seen, right, that once you give all these values and click this predict, it will tell you whether that person is diabetic or not. So what happens under the hood is, so I'll open this Python file. So here you can see we are loading the model called as diabetes model.scv. So this is a model that has been trained on this diabetes data that I've shown you. So similarly, we have our disease and Parkinson's model, and then we are creating this navigation sidebar where the person can choose either diabetes prediction or art disease prediction or Parkinson's prediction. So these are all the input values. So you have seen that input text fields, right? So we are creating that using this st text input, and like once you get all these values, we are using this diabetes model dot predict in order to predict whether a person is diabetic or not based on these values. So pregnancy, glucose, blood pressure, all these input features, and if the label is 1, we have to say the person is diabetic. Else that means if the label is 0, we have to say the person is not diabetic. So this concept is same for this art disease prediction and Parkinson's prediction as well. So I hope that you have clearly understood how we can deploy this ML web app on Heroku. So please try this by yourself. So this will be like really helpful for you, at some point of time. So all you need to do is create this proc file. So as I've told you, I'll share the link of this repository. So you can find this proc file here. So just copy this and put that in a notepad text file and save it as proc file without any extension. Later create this setup.sh. So again, it should have the extension as .sh. So these are all the contents for it, so you don't have to change anything. So if you wanted to deploy some other apps, make sure like you name that app to app.py. So if you want any models or some other Python files, you can like put that in the same repository, and make sure like you create this runtime.txt, which contains like all the libraries that we need, and make sure to include this protobuf library as well. And then runtime, you can mention the Python library that you need. So once you deploy this, so this is the link that you get for your for your ML web app. So like you can share this link to someone else so they can like uh, you know so this is like a remote app, so it's not like it has to be accessed from your system like local host. So this is like a public URL, so anyone can access it and check how this is working, and get this test result and so on. Okay, so this is how like all these things comes together, and I hope that you have understood all the things that is covered in this video as an API in Python. And for creating this API, we will be using the Python library called fast API. In our previous video, we have seen how we can deploy machine learning models using Streamlit, right? But the disadvantage of using libraries like Streamlit or Flask is that they are more of a prototyping tool. So we won't be getting that much detailed UI, and it is not like that much flexible as well. So the most widely used method is to deploy this machine learning model in the form of API, and then integrating this API with our UI system. Okay, so we, let's say we are creating our user interface using tools like React JS. And once we create that UI, we will integrate this API to this. Okay, so when we say API, we finally get a URL, and we will post this URL to that UI system. And now this will be a working system where your front end, which is your UI, will be connected to your backend, which is basically the API we are creating in Python. Okay, and I hope you know that the full form of this API is application programming interface. Okay, and the first step for this is to save the model that we have trained. So I'll open my Google Collaboratory. So for this, we will be using the same diabetes prediction model that we have already worked on. So I have already posted a video on how we can build this diabetes prediction machine learning model, and I'll give the link for that video in this video description. If you want, you can check that out. Okay. So in order to save this model, just I'll give the link for this collab notebook as well. So connect your system. So once it's connected, we have to upload this dataset file, which is diabetes.csv. So I have did all these coding parts, so I'm not explaining what we are doing in these steps. So if you want a detailed explanation of all these steps, please watch this diabetes prediction video. And now I'll go to my files, and I'll upload this dataset file. So this dataset file is in my desktop, which is diabetes.csv. Okay, So these are the basic step of importing the libraries and importing the data set into this data frame and so on. So after that we are training this machine learning model using support vector classifier model, SVC, and after that we are like predicting what is its accuracy score. So the accuracy score is like 78 percentage and 77 percentage. So this is for training data and test data, and this is the code for predictive system, which we have like already discussed. Okay, and finally we are importing this pickle library. So we are going to save our model as diabetes underscore model dot sav. So this is the file in which we are saving our trained model, as you can see here. So once we save this, it will, so we can like find this model here. Okay, so let's run all these cells. So this dataset file has been uploaded. I'll also give the link for this dataset file as well. So once you have uploaded this, make sure your system is connected and go to this runtime and click run all. So this will run all the cells. So this won't take like that much time. Okay, so yeah, it has completed running now. So this, until this part, like we are predicting the accuracy score. So this is like the predictive system which we have discussed already. Now this part is for saving our trained model. So we are creating a file name which is diabetes underscore model dot sav, and we are creating this file using this write function, and we have like saved it. So once you run this particular cell, you will get this file which is diabetes underscore model dot sav, and we will save this model, and we will be using this model file for deploying as an API. So this is the model which we will deploy as API, and these are like the steps. I mean, we don't need this, but what we are actually doing here is we are loading this same saved file here, and we are again doing this predictive system. So this two cells are not like that much necessary. And finally I'm just printing what are all the columns that are present in this data set. Okay, so we have loaded this diabetes.csv, right? So these are all the columns that are present there. So we have like the number of pregnancies, glucose level, blood pressure value, skin thickness, insulin, BMI, diabetes pedigree function, and age. So these are all the input parameters that we have. And apart from this, there will be this outcome column which we won't in, because that's what we are going to predict, right? So you can see this data frame here. So it has like all these values, and we have this outcome. So this will be our final thing. So we don't have to include this. Okay, so we need from this pregnancy to this age, which I have like printed in this last step. Now let's see how we can deploy this as an API. Let's download this saved model, go to this files, and I'll go to this option and download this model. So this is what we are going to use now. So this will be in your downloads. So you can see it here. So this is in my downloads folder. Yeah, so you can see this. Now so I'll open my Anaconda navigator, and I've already opened my spider. So you have to do this as well. And we need like certain libraries for this. Okay. So the libraries that you need are Fast API, UVCon, Pydantic, JSON, Pickle, Scikit-learn, and Requests. So these are all the libraries that we need. So if you haven't like installed these libraries on Anaconda, please download these libraries. So these are all the commands for installing these libraries. So pip install fast API, and then we have this pip install uvcon, pickle5, pydantic, etc. Okay, so how you have to install this is go to your Anaconda navigator, and this is the environment that I'm running. So in case you have not created a new environment, just choose base root itself. So go to your environments and choose which environment you are using, and in this you will find this play symbol. Click that and open this terminal. Okay, so this is where you have to paste these commands. So if you want to install this fast API, just copy this and paste it in this terminal. Okay, so once you press enter, this library will be installed. So I have already installed this library. So for me it would say that the requirement already satisfied. Okay, so do this for all the libraries that we have. Okay, so that is like the first thing that you need to do. So like install all these libraries. So just pause this video and install all these libraries before continuing with the other steps. So then only it will work. So I'll close this now. So once you have installed all these libraries, open your spider. Okay. So now the other thing that you need to do is create a folder. So in my desktop, I have created a folder as ML model as API. So you can create this anywhere. It's not that you have to create only in desktops. I have created this in my desktop, which is named as ML model as API, and I have created another folder as Python code. Again, you can create like give any folder name, And within this I have pasted my diabetes underscore model.sav. So this is the same file that we have downloaded from our collaboratory. Okay, so once you have downloaded that file, copy that file from your downloads and paste it in this particular folder, which you can name as Python code or anything else. So this is where we have to create our Python files in Spider. So I'll go to my Spider. So I'll go to file and give this save, and I'm going to save this in desktop, ML model as API Python code. Okay, and I'll name this particular file as ML underscore API, which implies that we are going to deploy this ML model as an API. So make sure that you use this underscore and not give any space between these words, and press enter. So now we have created this file, and this is where we will be creating this API using fast API library. So the first thing is I'll import from fast API, import fast API. So this F and this API should be in caps. And after that, let's import from Pydantic, import. So yeah, base model is the second thing that we have to install. Okay, so from Pydantic, import base model. Then let's import pickle. So I'll explain you what is the purpose of all these libraries after completing this. So import pickle, and finally let's import JSON library. So import JSON. Okay, so this fast API, as I've told you, it is used for creating these APIs in Python. And from this Pydantic library, we are installing this base model. So the purpose of this base model is we have to mention like what are all the formats of input that our model is going to need. So if you don't understand like what I said now, it's okay. So you will understand once we are like using this base model. And after that, we are importing this pickle library, which is used to load our saved model. So if you remember, we have saved our model using pickle, and we again need this in order to load our model. Finally, we need JSON. I'll also explain why this JSON module is again used. And now I'll create a variable and name this as app. So this app is equal to fast API. Again, this F and API should be in caps, which we have imported here. Okay, so we are loading this instance of fast API to this variable called as app. Now I'm going to create a class as model input. Okay, so model input, and within this we have to mention base model. So this base model is what we have imported from Pydantic library, and this is why we need this Pydantic library as well. Just a second. Yeah. Okay, so I'll give a column here. Now we have to mention what are all the input parameters that our model need. So those are nothing but this pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, and age. Okay, so these are all the things that we need. So let's copy all these things and paste it in this spider. Okay. Hmm. Okay, so first is this pregnancies, mention a column, and we have to mention what is the data type that it takes. So if you just go here, you can see pregnancies, glucose, blood pressure, all the way up to this insulin are integer values. This BMI and diabetes pedigree function, so these two alone are floating point values, that mean decimal values. Okay, so we have to mention that. So apart from this BMI and diabetes pedigree function, all are integers. So I'll just scroll here. So we have this pregnancies, and after this pregnancies I'll mention this as int. Okay, so this parenthesis should not be there, so delete it. Okay, so let's delete after like completing this. So second one is glucose, so I'll write glucose here, and this should also be an integer value. Later we have this blood pressure. Okay, so I'll copy this blood pressure here, and this also should be an integer value. And the next one is skin thickness. Again, skin thickness is an integer value. And then we have insulin, BMI, and diabetes pedigree function. Finally, we have this age. So I'll copy this diabetes pedigree function, and finally age. Now we have to mention their data types as well. Okay. So, so I'll give a column here, and let's say this is int. So BMI should be a floating point value. So I'll mention this as float. And diabetes pedigree function is also a float, which we have seen there. So I'll mention this one as float. And age should be an integer. Okay, yeah. So now let's remove all this parenthesis, so it should not be present there. So these are all the parameters or the input features that we will pass to our model, and we have to mention what is its data type. So this one is like necessary. So pregnancy is glucose, blood pressure, skin thickness, and insulin. So these are integers along with this age, whereas this BMI and diabetes pedigree function, so these two things alone are floating point values. Okay, so now I'll just minimize this one. So this is just telling the API that this is the format of data that I'm expecting. So totally, I think there are like 8 values. So 1, 2, 3, 4, 5, 6, 7, 8. So there are like 8 values, and out of this 8 values, two are floating points. So this is for the API to know that this is the format of data that I need. Now let's say load the saved model. So loading the saved model, and for this, let's call this model as diabetes model, and this diabetes model is equal to pickle.load. And within this we have to say open this diabetes model.sav. So go to the folder in which you are like saving this Python file. So this is the folder where I have created this YAML underscore API, and we have this model file saved here, right? So copy the name of this file, paste it within this quotes, and after this we have to say RB. That means we are reading this file in bytes. Okay, so this step is very important. The reason we are putting this model file in the same directory of this Python file is that we don't have to mention any directory. So if this file and this Python file are in the same directory, so that's the reason we need to save this in the same directory. And so this will load this diabetes model.sav to this variable called as diabetes model. Okay, and after this we can create our API. So the first step is importing the required libraries, and loading this instance of fast API, then mentioning what is the input format that we need, and after that we are loading the model. Now we can create our API. Okay. So here we have to say at app.post. So there are like two main methods for API. So there are like other methods as well, but the most widely used methods are app.get. So this is what we call as get method, and the other one is app.post. So we use this post method when someone has to give some values to our API. In this case, the values that our API need are these things. So in other words, these values will be posted to our API, and that's why we are using this post method. Okay, so app.post. So if you don't understand much about this API and fast API and all those things, don't worry. I'll create a series of videos on how to create this fast APIs, basics of API, and so on. But for now, let's discuss how this can be implemented in machine learning's perspective. Okay, so at app.post, and within this we have to mention endpoint. So endpoint is like what is the ending of your URL. So here mention forward slash, and let's say this is diabetes prediction. So you can give any name here, but you have to use the same name later what you're giving here. So here I'll use this diabetes underscore prediction. Now we have to create a function. So def, which means define diabetes pred. Again, you can give any name here. So input parameters, give a colon, and here we have to mention what we have mentioned here, the class that we have created. So I'll paste this here, model input. Okay, so this means like this input parameters is the one which the user will be sending to this API. So after this we can say this input data is equal to input parameters dot json. Okay, so I'll explain you what we are doing here, and finally we have this input dictionary. So this input dictionary is equal to json.loads. So this is not load, this is loads. So we should have that yes there. And here let's say input data. Okay, so let's try to understand what we are doing in this case. Okay, so this should be equal to. Okay, so we have mentioned the format in which our API need the data. So this is the data that will be posted to our API with the endpoint diabetes underscore prediction. Okay, so this is called as the endpoint. and we are creating a function and mentioning the input parameters, the values that the user will give, or the format model underscore input, which is this pregnancy is glucose all the way up to age. Okay, now this data will be posted to our API in the form of JSON. Okay, and we have to convert this JSON to a dictionary. So that is what we are doing here. So we will finally get a URL while we deploy this API, and to this API they will post these values. The user will post these values, which will be in the form of JSON. So once you receive this JSON, you have to convert this to a dictionary. So that's what we are doing here. So input data is equal to input parameter.json, and when we say this JSON dot loads, this will be converted to a dictionary, which will be stored in this input underscore dictionary. Okay, so this is the final dictionary that we are creating, which will contain all these values that we have to predict. Say for example, let's say these are all the values that the person is giving. So 5 represents the pregnancies, and you have the glucose number and so on. So these are all the 8 input parameters that we need. So this 25.8 is my BMI, and 0.587 is my diabetes pedigree function. So all these values will be posted to our API, and we are converting all these values, which is in the form of JSON, into a dictionary. Okay, now we have to convert this dictionary into a list or tuple like this. So let's see how we can convert this dictionary to a list. So I'll create a variable called as PREG, which stands for pregnancies, and I'll mention input dictionary. So input dictionary, and within this we have to say pregnancies. So let me just copy all these things first. So first we have this pregnancy. So the next thing is glucose, as you can see here. So let's do this the 8 times, as we have like 8 input features. 6, 7, and 8. So the second parameter is glucose. So let me name this as GLU, which stands for glucose. And third one is blood pressure. So let me put this as BP. And then we have the skin thickness. Let's call this as skin. And next one is insulin. So I'll name this to insulin itself. And then we have this BMI. So I'll type BMI with lowercase letters. Again, you can use any variable names here. And let's call this diabetes pedigree function as DPF. And finally we have age. So let me call this as age. Now within the quotes we have to mention all these things. First is pregnancy. Later we have this glucose, and the next one is blood pressure, and then skin thickness, the next one is insulin, last before is diabetes pedigree function, and here we have this BMI, and finally we have this age. So what you mention here within this code should be the same thing as what we have mentioned here. Okay, so this is very important. And for this, you can create any variable names in this place. So we have this pregnancies, glucose, BP, all the things here. So what we are trying to do is, so we are like extracting all these values individually. So this is the dictionary that we have created. And when I said input dictionary of pregnancy, so all these things act as my key. And I want to like store all the values for these keys in this variables. So this may sound a bit complicated, but this is the simple concept of dictionary. So we know that dictionary is a key value pair, right? So all these things, pregnancies, glucose, and blood pressure values represents our keys, and these are our values. So we will like pass these values later on, but this is what we call as values. So when we implement this part of the code, this will load all these values. Let's say this 5, 166, all these things to these variables. Now we have to pass these values to our model for prediction. Let's see how we can do that. So this should be inside this diabetes spread function. Okay, so I'll press tab. Now let's create this input list. So this is the final data that we will be passing to our model. So input data is equal to preg. So we just have to mention all these variables. So preg, which stands for pregnancies, and then we have this glucose, BP, skin thickness, insulin, BMI, DPF, which is diabetes pedigree function, and finally age. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so totally there are like 8 input features which we have here. So once we extract all this information from this dictionary, we are storing all these values to individual variables, and later we are combining all these values to a list. Now we can pass this list to our model that we have loaded here, to this diabetes underscore model, and we can make this prediction. Okay. So now let me say prediction is equal to diabetes model dot predict input list. Okay, and later let's say if this prediction, so the final result will be either 1 or 0. So if the value is 1, that means the person is diabetic. If the value is 0, that means the person is not diabetic. So I think, yeah, so here we have mentioned, so 0 means non diabetic, 1 means diabetic, so we have to mention this here. If this final prediction, the final prediction of 0 is equal to 0, in that case we have to say return. So this is a function, so we have to return something. The person is not diabetic because the value is 0 here. Okay, is not diabetic. Whereas else condition, else means the value will be 1, else we have to return. So here we are returning string values. The person is diabetic. Okay, so this is all. So now once we run this, our API will be ready. So let's try to understand what we are doing here. So this is the same as we done in this like prediction code. So we have built this predictive system, right? So we are like doing the same thing but in a different format. So we are like taking the input data, reshaping this, and finally we are like using this predict function and passing this input data, right? And checking if this value is 0, we say the person is not diabetic. If the value is 1, we have to say diabetic. So this prediction will be a form of list, and in order to capture the first value, we are mentioning this index as 0. So this is not like that much complex. So I hope you understand this part. So if not, please watch that diabetes prediction video where I explain this detailing. So if this final prediction is 0, we have to say person is diabetic. If not, we have to say the person is diabetic. That means in this case the label is 1. So here the main thing that you have to note here is this is a list, and while predicting we have to enclose this list within a list. So that's why I've used a square bracket here. See, so there is a opening square bracket here and ending square bracket here. Yeah, so this is the one. So this list should be enclosed within a list. So the reason is, if we don't do that, we have to reshape this using this numpy library, using this 1 comma minus 1 and so on. So this is for the model to tell that I'm trying to predict for only one data point. So that's the purpose for this. Okay, so instead of doing this reshape and all those things, we can just put this list within a list. So that is like a shorter way of doing this. So let's try to understand what we have done in this entire part of the code. So first we are like importing these four libraries. Fast API is used for creating these API apps, and pydantic, from this pydantic we are importing base model, and the purpose of this base model is to set up the format in which the data will be posted to our API. And then we have this pickle for we know that to load the saved model. And then we have JSON. So I have explained you why this JSON is used. It is used to convert this JSON object into a dictionary in Python. Okay, so then we are creating a class called as model input, where we are mentioning the format in which the data will be given to our model. And then we are loading the model using this pickle.load. And later we are creating a function called as diabetes spread. And before that we are like creating this post method with the endpoint diabetes underscore prediction. Okay, and we are telling that the input parameters will be in the format of model input, which is given here. Okay, so this is my input values, and now I have to convert this input values, which is in the form of JSON, into a dictionary, which we are doing here. Okay, later we are like extracting all the values from this dictionary and converting it to a list in this step. And later we are using this model.predict function in order to predict whether the label is 0 or 1. So I'll save this file. Now you cannot run it here. So if you run this here, your API won't work. So for this, what we have to do is, so go to your Anaconda navigator and go to your environment. Okay, so machine learning is the environment where I will like opened my spider, and I have installed the library and so on. So I have to go to this play symbol and open my terminal. And here, once this terminal has been opened, so you can see the environment name, which is machine learning. Okay, and we have this the path of my users and my name. Now we have to say cd space double quotes. Okay, so one sec. Now within this double quotes, we have to mention the path of the file in which my Python file is stored. So this is the file, right? This YAML underscore API. So this file is located in this path. So I'll open this folder. If I click here, I will get the path. So I'll copy this path, paste it here. So the command should be cd space double quotes, and within this you can paste the path and again close it with double quotes. Now this will direct you to that particular directory. Okay, so this is now in desktop and ML model as API in Python code, which is my directory. Now we can deploy our API. So I have to say uvcon, and here we have to mention the name of the Python file that we have created, which is ml underscore API, right? So you can also see this in spider. Okay, so after this uvcon command, I should say ml underscore API. So this this uvcon command won't work if you don't install this uvcon library, and I have showed you you can install this uvcon using pip install uvcon. So make sure that you have installed all this library before running all these steps. So I am in this folder. So I'm mentioning ml underscore API, mention a colon and mention app. Okay, so it should be uvcon, name of the Python file that you have created, colon and app. So this app is nothing but what we have created here. So we have loaded our fast API instance to this variable called as app, right? So that is what I am mentioning here. Okay, so uvcon, name of the Python file, which is ml underscore app, sorry, ml underscore API colon app. So after this, press enter. So now this will give you your localhost URL in which your fast API is being deployed. Okay, so I'll press enter. So it might take like 3 or 4 seconds in order to give us the details. Just wait for a few seconds. Yeah, so this is the port or the localhost URL in which my API is running. Okay, now we can test our API. So like you can give this localhost URL to this a UI that you are building in, let's say, in React.js. So once you give this to this localhost URL and post the values, you will get the prediction of whether the person is diabetic or not. So for now, let's not go to that UI part. Let's test whether this API is working or not. So for this, we can also check this API. So we can also test this API in Python itself. So I'll come to my spider and I'll create a new file. And now in this new file, let's see whether this API is working well or not. So here I'll import the library JSON, and I'll also import a library called as requests. So this request is used to get or post values to our API. And now I'll say URL. So URL is equal to, so within this we have to paste this localhost URL which we have got here, which is HTTP 127 in the port 8000. So I'll copy this, paste it here, and we should also mention the endpoint. So put a forward slash here and copy the endpoint that we have created, which is diabetes underscore prediction. Okay, so diabetes underscore prediction. Now so let's pass the input values. So I'll create a dictionary as input data for model. Okay, so this is a dictionary which we can create using curly brackets. So let's give the values. So the values should be, so these should be the same names as we have here: pregnancies, glucose, blood pressure, all these values. So I'll copy all these things, paste it here, and now we can remove all this int and all those things. So this is where we have to give the real values. So I'll remove all this int. So this is basically a dictionary that we are creating. Float, diabetes pedigree function, finally age. Now all these values should be enclosed in quotes, either single quotes or double quotes. So I'll enclose this within single quotes. So this will be the key for my dictionary. So blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age. Okay, so now we can pass the values. So I'll save this file as API implementation. So API underscore implementation. Okay, so the idea is I have to post all these values. So I have to post all these values to this URL, and it will tell me whether the person is diabetic or not. Okay, so this is the final result that we are interested in. Okay, so now let's give some values to this. So I'll open my diabetes.csv file. So let's test for a person with diabetes and person without diabetes. Okay, so let's check this first data point, which is 6148 and so on, and the second data point. Once we give all these values, the outcome should be 1. That means it should say the person is diabetic, right? So let's paste all these values. So for pregnancies, the value is 6, and for glucose, we can see the value is 148. So just see this first line and we can like put all the values here. So glucose is 148, and blood pressure is 72, skin thickness is 35, insulin the value is given as 0, and BMI is given as 33.6, and pedigree function, so diabetes pedigree function is given as 0.627, and finally we have this age. So age value should be 50 as given here. Okay, so this is the data that I'm passing, and it's showing a error here because all these should be separated by comma. Okay, 72 comma 35 0 33.6, and finally 0.627. So this is the dictionary that we have created. Now we have to post this dictionary to this URL. Okay, so these are my keys which are enclosed here, and the values for this key is this the value for this key pregnancies is 6, and the value for the key glucose is 148, and so on. So this is what we are extracting in this particular step. Okay, so I'm mentioning this input dictionary, which is nothing but this input data from for model. So I'll change this p to model. Okay, so we are like extracting all these values individually in this particular step, and then we are like using it to predict it. Okay, so let me go here. Right now, as I've told you earlier, this is in the form of a dictionary. Now the next step that we have to do is convert this dictionary in the form of JSON. So that's why we have imported this JSON library here, and for this I can say input JSON. So this is the JSON object that we will passing or posting to our API. So input JSON is equal to JSON.dumps. Again, this is not dump, this is dumps. So here we have to mention input data for model. Okay, and finally we can say this the response is equal to request dot post, and within this we have to mention this URL comma data is equal to input JSON. So this final response will be stored in this variable called as response, and we can print this response dot text. So it will only print the value if you give this as text, because finally we are giving or we are returning the values in the form of a string, which is text. Okay, so I'll save this one. Now we know that this data point refers to a person who has diabetes. The outcome is 1. So the final result we should get once we run this cell is the person is diabetic, right? So we have to get this particular string. So let's see whether this API is working. So this is the API that we have created, and this is the endpoint for the API that we have created in this particular file. Okay, so here what we are doing is first importing JSON and request. So JSON is used to convert this dictionary into a JSON object, which we are doing here, and later we are using this request in order to mention this URL and post this data to our URL. Okay, so this should be the same as we have mentioned here, because this is the format, right? So we have to pass the values in the same format. So I'll save this and let's run this one. Okay, now it says the person is diabetic because it is the outcome is 1. Now what we are doing is this API is running, so it is running in this particular port. So you can say so 200. Okay, so 200 means in HTTP request 200 means the input value is working, and everything is working properly. So you may also get like internal server error and other things. So if there are some errors in your code, let's say that there is some error that you have made in this particular API file, so those errors will be mentioned in this terminal. Okay, so you won't see it here, but it will be mentioned here. So that is other thing that you can remember. And now we have created this and deployed this API in localhost, and we have mentioned this endpoint. Now it can predict whether a person is diabetic or not. So you don't have to train your model each time, and like once you can save your model and you can deploy this in the form of API. Now let's check for a person without diabetes as well. Here let's check the second values. So here I'll change this to 1, and now let's change this to 85, which is given here. So the glucose value should be 85, and then we have the blood pressure value as 66. Skin thickness value should be 29. Insulin values again 0. BMI is 26.6. Yeah, 26.6. And diabetes pedigree function is 0.351. And finally the age is 31. Okay, so here the outcome is 0 as it's mentioned here. Now the model should say that the person is not diabetic. Okay, so I'll save this and run this one. Okay, so it says the person is not diabetic. So instead of telling this in string, you can also like return this 0 or 1 in this case. So in this case, you can return 0, or in this case, you can return 1. So how all these things comes together is, so once we deploy this in a URL, so we will paste this URL in our UI, and from there the UI person will post this data, which is probably entered by the user, and this data will be posted back to our UI, where in the backend we can like post this to our API and tell whether the person is diabetic or not. So this is how all these things comes into play. So this is just for testing purpose, but this is what we are interested in. So this is the file that we are interested in. So instead of checking this in this Python file itself, so this will be integrated in a UI. So in this case, this is a local host URL, and this will run only in your system. Okay, so this is not a public URL yet. And in the next video, I'll show you how you can deploy this API as a public URL. Public URL or public API is the one where if you like deploy this API, anyone can access it. Anyone can check its result. So that is what I mean when I say public. I'll show you how we can do that on Collaboratory, Google Collaboratory, and in the upcoming video, I'll also show you how we can deploy this API on Heroku, where it will be a permanent link. Okay, so those will be the topics that we'll be covering in the upcoming videos. And before like ending this, I'll just give you a quick recap of what are the things that we have done here. So this may seem a bit confusing to you, as you might not have experienced working with this API and fast API and things like that. But like once you start practicing it, it is like much easier. Okay, and APIs are not only used for deploying this machine learning model. So there are like a lot of other applications for this API as well, and it is like a great skill to have to build APIs. Okay, so I'll just give you a quick recap as told. So first we are like saving this diabetes model, which we have trained using this diabetes.csv, and we have saved this using this pickle library. So we have like dumped all the parameters to this diabetes underscore model.sav, which we have downloaded from here, right? And later I have created a folder called as the ML model as API in my desktop. And there I've created a folder called as Python code. And this is where I'm like saving my Python file and my model. So this should be in the same directory. This diabetes model.sav and ML API, my Python file should be in the same directory. And before writing all those codes, you have to mention, like you have to install all these libraries, and this is the command for it. Okay. So pip install fast API, ubcon pickle pydantic scikit-learn request and pypi json. So this is for installing the JSON library. So make sure you run or you install all these libraries from the command prompt or terminal, which I have shown you. So after that we can come to our spider, where we are importing all the required libraries, loading the fast API instance to this variable called as app. Later we are mentioning what is the input parameter. So we have this pregnancy, glucose, all the 8 parameters, as we have seen in this collaboratory file itself. Okay, so to save this file, just I'll give you the link. Go to this runtime. So go to this runtime, and we have to click run all, and before that you have to upload this dataset file. So after uploading this dataset file only, you have to run all these cells. Okay, so then we are like loading the saved model, which should be in the same directory as this ml underscore API file. And then we are creating this post method for our API with this endpoint. Okay, and then we are like extracting all this data. So first we are converting this JSON file in or JSON object into a dictionary, and later we are like passing all these values to our model for prediction. And when the label is 0, it should say the person is not diabetic. When the label is 1, it should say the person is diabetic. So that's what we have done in this if condition. And we have tested this API in Python itself by mentioning this URL, which is my localhost port that we are getting from this terminal. Okay, and later like we are converting this dictionary into a JSON object, which we are posting here, and we can like print this response.text, which will give you the final result as whether the person is diabetic or not. As I've told you in the next video, let's try to understand how we can create this public API, and in the video after that we will also be understanding the deployment in Heroku or other platforms. Okay, so I hope you have understood all the things covered in this video. And if you wanted to stop this deployment in this localhost, come to this terminal, press Ctrl C. So if it's not working the first time, just press Control C again, and it will shut down your system. Now your API won't be working. Now if I run the cell, it won't be giving. It probably will give me an error because this API is not running, as you can see. So the connection error is there. Now if I go here, open this terminal again, I can say this. If you remember, we have to mention the directory of this Python file, and later we have to say uvcon and ml underscore API and colon app. Now press enter. Again, this will run. And now you can run this file to check its implementation. So this port won't change when you run in localhost. So you will get the value for this, the label for this particular values, which is the person is not diabetic. Okay. So I'll close this deployment now by pressing Ctrl plus C. So it will shut down the system. Okay. So this is how all these things work. I hope you have understood all the things covered. So like if you skipped a few parts of the video, you might miss few things and you might get an error. So please watch the video completely, practice this by yourself and see how all these things comes together. Okay. And I promise you this will be very helpful for you in several cases as an API. And in that case, we have deployed our API in localhost, so we can only access it. And in this video I want to show you how you can deploy your machine learning model as a public API. So public API in the sense anyone on the internet can access your API through URL, and they can like use it for their purpose. So in the previous video we have deployed our diabetes prediction model, which can tell whether a person is diabetic or not based on few input features. So the end result we get is once we deploy this model as this public API, so we get a URL, and anyone can post this input feature to this API in order to find whether a person is diabetic or not. So this is how all these things work, and we are going to do this completely on Google Collaboratory. Okay. And for deploying this, we are going to use this Ngrok. Okay. So this Ngrok module is used in order to create proxy URLs for us. Okay. And for creating APIs, we will be using fast API library. And if you haven't watched the previous video, please watch that one. I'm going to use the same code that we have used there. Okay. Where we have created this API using fast API, which is as the endpoint diabetes underscore prediction. So we will be using the same code. So if you don't watch that particular video, you might not understand what we are doing here. Okay. So I'll give the link for that video in this video description and in the cards as well. So please go through that video first. Okay. So the requirements for this video is you need the model file. Okay. So the model that we are working on is diabetes prediction model. Okay. And if you run this collab file, you will get that diabetes model. So I have this file here which says diabetes underscore model dot sav. Okay. So I've explained in the previous video as well. So I have given the same collab file. So you just have to upload this diabetes.csv dataset file. Okay. So you can see this file. So I'll also share the link of this dataset file. So all you have to do is go to this files. Once your system is connected here, upload this dataset file, which is diabetes.csv. So let me show you how this works. So upload it from here. So I'll go to my desktop and upload this diabetes.csv. Okay. So once this file is uploaded, so now we have to run all the cells. Come to runtime and run all. So this will generate this diabetes model.sav. So this is where we are saving the file. So we are using this pickle library and saving this diabetes model.sav. So we have seen this in the previous video, as I have told you. So this is the model file that we need. So go to this option and download this. And this is the file that we have to upload in this particular collaboratory. Okay. So I have this diabetes underscore model.sav file. So I'll open the second collab file where I'm going to build my API. So I'll connect my system and I'll upload the saved model. Okay. So let's wait for it to connect. Okay. Now I'll upload this diabetes model.sav file, which is my trained machine learning model for diabetes prediction. Okay. And these are all the libraries that you need. I'll also give the link for this collaboratory file as well, so you can just run the cells. So we have the libraries like fast API, which is used for creating this APIs, and uvcon acts as the server and so on, and pickle is for loading the saved model. Pydantic, we use it in order to structure the format in which we are going to need the data. Okay, so these are all the parameters that we need. And then we have this scikit-learn, which is used for this modeling thing, and we have this request, okay, which is like for posting the URLs and so on. And then we have this JSON. So the reason we are using this JSON library is this data will be posted to us in the form of a JSON object. Okay, so we have to convert this back to dictionary, which we are doing here. So for that we are using this JSON library, and then we have this Ngrok and MNIST async IO. So I'll explain you why we need all these things. So once you run the cells, all these libraries will be installed. So it will take a few minutes, okay. And then we are like importing all these libraries here, and one of the things that we are importing is this CORS middleware. So this is also very important, okay. So as I've told you in the previous video, the main idea of deploying a machine learning model as an API is we have to integrate this with UI. So we can build our UI with tools like React JS and other UI tools. So we have to integrate this API with those UI tools. And the reason we are like using this course middleware is, so if we don't perform a procedure, so this is what we do, and if you don't run this particular cell, it will give you a course error. So this will happen only when you're integrating this with the UI. So CORS means cross origin resource sharing. Okay, so this is to allow the domain to use our API. So when I say this asterisk symbol, it will allow all the domains. I can also specify like only specified domains, so only they can access it. So these are like a bit advanced, but you need this when you are integrating this with the UI. Okay, so you can just use this same code, but in this case it is not necessary, but it is good to know this. Okay, so now I have installed all the libraries that I need. Now I'll run this cell in order to import the libraries that we need. And now we are creating an instance of this fast API and saving this in this app. Okay, so I'll run this cell as well, and this is for us to give this permission for this course, and I'll run this as well. So this order should be the same, and then this is the format in which we will be passing the data. So I'll change this P to capital P. So in this format, the API will be requiring the data. So I'll run this cell as well. So we are importing this base model from this pydantic library. Again, I have explained this in the previous video as well. And in this cell, we are loading the saved model, which is our diabetes underscore model dot sav. Okay, so I'll run this one, and we are saving this model in the variable called as diabetes underscore model. And we can also load this model within this API. So this is the API that we have created. We can also load this model within this API, but the problem with that is each time our API is running, or each time our API is being called, it will like load the model, which is unnecessary. Okay, so hence we are like loading the model before creating this API. Okay, and this is the app that we have created, which is app.post. App is equal to fast API, and we are mentioning the method post. Post means we have to post a few values to our API. So these values are nothing but these things. Okay, so the input parameters that the model need for prediction, and out of these, BMI and diabetes pedigree function are floating point values. Okay, so if you open your dataset file, which is diabetes.csv, you can see that this BMI and diabetes pedigree function. So these two are in the form of decimal points or floating points. Hence, we mention this as float. Okay, so BMI and diabetes pedigree function is float, and the remaining things will be integer values. Okay, and first we are like loading this dictionary. So sorry, so the data that we receive will be in the form of JSON, and in these two lines we are converting this JSON data into a dictionary. Okay, and then we are like extracting all these details from this dictionary, and storing it in a list. Okay, so we have this pregnancy, glucose, BP, and so on. So these are nothing but the values that we have here. So except this outcome, so this outcome is what we are trying to predict. Okay, so we have from pregnancies all the way up to age. So these are all the variables for it. So once we extract all these details from this dictionary, we have to pass it to our machine learning model in order to make our prediction. This is what happens here. Okay, and if the label is 0, we have to say the person is not diabetic, and if the label is 1, we have to say the person is diabetic. So that's why we use this if else condition. Okay, and if you go to this file where we have like generated this model, we have this 0 and 1, where 0 is non-diabetic and 1 is diabetic. So that's why we have created a if statement like this. Okay, and this is the input parameter. So this is what the API will receive as the data, and this is nothing but model input. So what we are doing here is we are mentioning what is the format in which we will get the data. So that is the purpose for mentioning this. So the final result that you get will be a URL. Okay, and with that URL, we have to mention this endpoint. So that will be our final API. Okay, so I'll run this cell as well. And this is the code snippet in order to create our public URL. So we have seen that we have did the same thing previously in Spider, where we have deployed this fast API in our local host. So when you do that in localhost, others cannot access it, right? So only you can say it. In order to rectify that, we have like using this Ngrok, but this is more of a temporary solution. Okay, uh, in order to deploy this as a permanent URL or link, we have to go with options like Heroku or other hosting platforms, but we will discuss about that in the next video. But for now, let's try to understand how this can be done in Google Collaboratory itself. Okay, so after running all these cells, so run this last cell. So this will give you your public URL. So this is the port in which your API will be hosted in local, and that is what we have seen in the previous video itself. Now let's try to get our public URL. Yeah, so this is running in this particular port in localhost, and this is the public URL. Okay, so I'll copy this link. So this is nothing but a proxy URL for our local host. So you can run this in your own machine itself, but I prefer doing that on Google Colab. So you can also try this on Google Colab. Now I've like copied this link. Now we can test our API. So we have seen in this previous video as well, where we have implemented this API. So this is the local host in which we were building it on the previous video, and this is the endpoint for it, and we are like passing these values. So these are the values for a person who is not diabetic. So if I open this diabetes.csv file, this is the data that we have passed. For this values, the outcome should be 1, and it would say that that person is not diabetic. So we are going to do the same thing, but in this case we are going to use a proxy URL that Ngrok has generated for us. And the last thing we have to include here is the endpoint. So the endpoint is nothing but what we have mentioned here. So this should be in quotes, and there should be a forward slash here. So this is very important. So I'll copy this and paste it here. Okay, yeah, now let's try to understand what we are doing here. So I'm importing this JSON and request library. So I'm mentioning this URL is equal to this. So this is where our API is being hosted now, or it is being deployed. And I have to post these values to my API. Okay, so these are nothing but the same data format that we have mentioned here. So all the case and all the words should be same. So we have pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, and age. So based on these values, our model should predict whether a person has diabetes or not. So that's what I have mentioned here. The only difference is we have mentioned all these values, and we have also seen that BMI and diabetes pedigree function should be a floating point value. Okay, so we are mentioning this URL and we are posting these values to our URL. So how we are doing this is, now this is in the form of a dictionary, right? And this dictionary should be converted to a JSON object, because our API will receive only JSON object. Okay, so that's what we have done by using this post method. So we have to like post these values to our API, and here I'm converting my dictionary into a JSON object using JSON.dumps, and then I'm creating a variable called as response. So response is equal to request. So this is the request library that we have using, and make sure that you have installed this JSON and request library. I have also shown how you can install these libraries in your machine. And yeah, so request dot post. So there are like two main methods that we have in API. One is get and the another one is post. So here we are using this post method, and the parameters that we have to mention are the URL to which we have to post the data, and the JSON file uh, which we have to post. So JSON or the JSON object which we have to post to this API. Okay, so this will give you the end result for it. So okay, so response dot text. So the final answer that we should get is the person is not diabetic, because that is the data that we have copied here. Okay, so let's try to run this and see. And not only you, anyone can use this URL, and they can like write this code and see whether a person is diabetic or not. Okay, so I'll run this one. Okay, so there is some error. I can like go to this and see what is that particular error is. Okay, pregnancy. Okay, so I'll stop this deployment. Okay, so you can just click this in order to interrupt this. So the reason we are getting this error is, so we have changed this P to capital P, right? So we didn't make that change here, so that's why we get this error. So I'll put this as capital P. Now I'll run this again. and I'll run this deployment code snippet as well. Again, this will generate a new URL for me. Yeah, so this is the public URL that we have. Now I'll copy this. So each time you run this, your like URL will change. So I'll copy this link address and paste it here. Okay, so I'll replace this one. So our endpoint will remain the same. Okay, now let's try to run this one. Okay, again I'm getting an error. So let's see. 404 not found. So there is some error in which we are posting the data. Let me just quickly check it. Okay, so the reason we get this error is I have like used two forward slashes here. So that's the reason. And now let's see whether it is working. So I'll run this one. I'm getting this error again. Okay, so the reason we are getting this error is so this P has not been changed yet. So still I get this key error. So I'll do one thing. I'll stop this implementation and run all the cells from the start so that this change is being reflected. So I'll go to my runtime, disconnect and delete my runtime. So when I do this, so all the files that I have uploaded and all the codes that I run will be resetting. Okay. So now I'll upload my model file again, which is diabetes model.sav. Okay, now let's rerun all these cells. So this is for installing. So you have to install all these libraries again. So that is a mandatory thing, and then we can like run each of these steps. So this is the same thing that we have done in the previous video. So the only difference is like instead of using this local host, we are using this public URL so that like anyone can access it, and you can access this URL only when this last cell is running. So if you stop this like execution of this particular cell, this URL won't work anymore. So this is why I told you that this is a temporary solution, but you can use this method in order to quickly check whether your API is working or not. Okay, so there is a warning, but I think it's not an issue. So I'll run this cell. Run app is equal to fast API and origins model input. We are saving the model and let's see whether now it is working or not. So this is my public URL and I'll copy this link address and let me replace this link. So make sure we are like replacing this forward slash as well. Okay, now let's see whether it is working now. Yeah, now it says the person is not diabetic, right? So it seems it is working well. And here you will see that this response is 200. So 200 means the input has been stored correctly. And this is just a basic warning that we get in sklearn. So the reason we get in sklearn is we are just passing these values, right? So we are having this pregnancies, glucose and so on. So while training we will like mention this feature names as well, whereas while predicting it we will just pass this as a a list. So here you can see, so yeah, so here you can see we are just passing this as a list, so it won't contain this feature name. So that's why we get this error, but this is not like that much important for us. We can also check for a person with diabetic as well. So I'll open the CSV file. Now we are predicted for this, so the outcome is 0, so it says the person does not have diabetes. And now let's check this for this first data point as well. So I'll open this here, and pregnancy is 6. So I'll replace all these values with this first data point, 6, 148 and so on. So glucose value is given as 148 and the blood pressure is given as 72. Skin thickness is 35, insulin value is being 0, and BMI is 33.6. Yeah, 33.6, and diabetes pedigree function is 0.6 to 7. Okay, and finally the age of the person is 50. So here the outcome should be 1. That means our API should return the result as the person is diabetic. Okay, so let's see what is the result for this. So I'll run this file again. Yeah, so it says the person is diabetic. Now this is a public like API URL, so anyone can like post this data to this and they can get this result as we are getting. Okay, but this Ngrok should run, so this cell should run, so then only it can
it can work. Okay, so the moment you stop this execution, so this particular URL for our API won't work. So for overcoming this only, we will like deploy our API in Heroku, but that is a bit of a work that has to go there. So this will be a temporary solution that we can use in order to deploy our API in Google Collaboratory itself using this Ngrok. Okay, so I'll just give you a quick recap of what are all the things that we have done here. So first we have installed all the libraries that we need, and before that we need to get the model from this particular collab file, which is our diabetes underscore model.sav. Okay, so we have seen in the previous video as well. And after importing all these libraries, we are creating this fast API instance. And as I've told you, this API will work. So this API that we have used will work even if we don't include this origin. Okay, so but when you are putting this URL in some UI codes and all those things, in that case you might not you might get a coarse error. Okay, so that is why we are including this all origins, which is mentioned by this asterisk symbol, and we are mentioning the format in which the data should be passed, and then we are loading the saved model, and then we are creating the API in this step, and finally we are deploying this using this mgrok, which gives us a proxy URL that can use for the moment. Okay, and here we have tested this API. So like instead of having this Python file, we will like put this URL in some UI tool like React or other UI platforms, and then we will like post this data from here. So in real time, how this will be is, so there will be some input fields in a web browser, and the user can give these values. And once they give this value, so this data will be posted to our URL, and in the backend we can predict whether a person is having diabetes or not using this API. So this is how the entire thing works. But for this time being, we are checking or we are testing this API in this Python file itself. Okay, so I hope you have understood all the things covered in this video. So all the things that you have to do is save the file from this collaboratory, and run all these cells in this second collab file, and copy this link. So this link will be changed, and you have to replace the link that I have given here. Okay, so that is very important. So this link won't work when you are running it, because I will close this collab file now. So make sure you are replacing this link with the link that you get when you run this particular ngrok cell. Okay, and once you do that, so this will probably work, okay, in the form of API. And while working on this, we have deployed these APIs on our local host, and we have used like Ngrok in order to make this as a public URL and so on. So deploying your API in Ngrok is a temporary solution. So it won't be like you won't be getting a permanent link for this. And the solution for this will be deploying these APIs on Heroku. So this is what we are going to discuss in this particular video, where we already have this machine learning model ready, which is this diabetes prediction model. And in the previous videos, we have seen how we can create this APIs using fast API libraries in Python. So we are going to use the same code, and we are going to deploy this API on Heroku, and that will be the agenda for today's session. And let's get started. So if you haven't watched the previous video, I strongly suggest you to watch those, because in that case you can understand these things better. And I'll give the link for those videos in this video description. Okay. So this is where we are going to create our new app. So new app in the sense we are going to create this in the form of an API. Okay. So we are going to use Heroku and GitHub for this. So we will put all our required files in a GitHub repository, and then we will connect this GitHub repository to our Heroku ID. Okay. So this is how it's going to work. And first of all, let me show you what are all the files required. So I have a folder created in my desktop called ML API in Heroku. Okay, so these are all the files that we have. So first file is diabetes underscore model.sav. So this is the saved model file, and in the previous video I have shown you how you can create this. Okay, so that is a Google Colab notebook where we have written this code, where this is the diabetes prediction data set diabetes.csv, and using this data we will train our diabetes model. Okay, so all you have to do is go to this Google Colab link. I'll try to give the link for this Colab file as well. So here you can go to this files and upload this diabetes.csv file. Okay, so I'll also give the link for this dataset file. So from here I'm going to upload this. So this is also present in my desktop, which is diabetes.csv. So I'll upload this one. So this is uploaded. My system is also connected. Now just go to this runtime and run all the cells. So at the bottom we have done some coding in order to save this as a pickle file. So here you can see we are using this pickle library in order to save this as diabetes model.scv. So if you go here, you can see this file, and from this option you can download this file. Okay, so this diabetes model.sav file. Okay, so you can download this. So once you have downloaded this, just create a folder like this and put this model file in this particular directory, and then we have this main.py. So this is where our Python code is for creating our API. So I have already opened this file. So this is main.py. Okay. And in the first part, we are importing all the required libraries. So we have like done this in the previous video itself. So we are importing fast API, and then like Pydantic. From this Pydantic model, we are importing base model, and then pickle for loading our saved model, and JSON. So I'll tell you why we are using this JSON base model and this CORS middleware. So we are creating this app is equal to fast API. So the only difference in this code is we wouldn't have mentioned this particular part. Okay, so origin is equal to, so we have this asterisk symbol. So the main idea of deploying our machine learning model in the form of API is that it will be easier for us to connect our UI. Okay, so the final result that you get from this API is a URL, and let's say that there is a beautiful UI that you have created using some UI tools like Node.js or React or something like that, and in that you have like input fields where the user can give in the values like the pregnancy value, glucose value, blood pressure things, and so on. Okay, and these values should be posted to our API in the form of a JSON file, and if you don't mention this, that particular UI domain won't be having access for our API. So that's the reason. So CORS means cross origin resource sharing. Okay, and when you mention this asterisk, like it is permitted for everyone, but in real time, in this case, you will mention the domain on which this UI is built, so that those particular people can only access your API. So that's the idea. So if you don't mention this, so you will get a CORS error in your UI. So that's the reason. And once we are like done with this, so here we are creating this instance of this fast API in the name of app, and then we are creating this like base model class. So in the name of this class is model input. So the reason for this is we are like telling the API, or we are telling the UI person that these are all the details that I want. So this is the format in which I need the data. Okay, so you can see this is in the form of a dictionary. So it's like mentioning what is the format of the dictionary that I need. Okay, so in real time how this works is we will get this data, the pregnancy number, glucose value, blood pressure, all these things in the form of a JSON file. Okay, or a JSON object. So this will be posted to our API, and in the next step we are loading our saved model, which is diabetes underscore model.sav, and make sure that all these files are in the same directory. So here I have this diabetes model, and then I have this main.py file, and so on. So here I am loading this saved model and loading this to a variable called as diabetes model. So this is a trained model that we saved from here. Okay, so from this particular collab file which we have downloaded, and in the next step, this is the post method that we are using for this API, and this is the endpoint. Okay, so along with the URL that will be generated for you, you have to include this endpoint, and after that we have to post this data. So once this data has been posted, so this data will be converted into a dictionary in these steps. Okay, so once this has been converted, we are like extracting all the values individually. So this pregnancy value, so this is a dictionary now, and from this dictionary we are getting this pregnancy value, glucose value, and so on, and storing these variables. Later, we are putting all these things in a list, and then we are using these values in order to predict whether that person has diabetes or not using this model.predict function. Okay, and if the prediction is 0, it says the person is not diabetic. If the prediction is 1, we have to say the person is diabetic, because that's how we have like labeled these data. So if you go to this collab file, you can see this here. So 0 has been labeled as non-diabetic, and 1 has been labeled as diabetic person. So this is how this API works. So we have like discussed this in the previous videos as well. So I hope that you have watched that one as well. Now we have to upload this file along with like few other files to our GitHub. So I'll show you. The next file that we have is proc file. So I'll explain you what this proc file later. So first is the diabetes model, which is the saved model file, and then we have the Python file for creating this API. Basically the fast API that we have used, and then requirements.txt. So this is a simple file which contains all the libraries that we have used. Okay, so we have this fast API UVCon, Pydantic. So from Pydantic only we are like importing this base model, and then we have pickle 5 for loading our saved model, and then scikit-learn and numpy. So I just wanted to include these basic libraries as well. So I'll save this file. So if you want, you can also mention the versions of this files. So let's say if you wanted to install the fast API version of 1.3 point or something like that, so you just have to mention 2 equal to sign and put something like 1.2.3. So this particular fast API will be installed. So in this case, I'm not going to put any versions. So I'll save this. So this is the next file that we need, which is requirements.txt. Make sure you are naming this as the same thing. And finally, we have this runtime.txt file. So it basically contains the version of your Python. Okay. So this version of your Python will be installed on your Heroku deployment session. So that's why we are mentioning this. So this should also be same Python hyphen. So you can mention any version that you want. Okay. So this is the other thing. So I'll put all these files in a Google Drive, and I'll share you the link of that particular Google Drive folder. Okay, so you can download these files. I'll also put these things in a GitHub repository. I'll share the repository link as well. So these are all the things that we need. And finally, we have this proc file. So this is very, very important for Heroku. So here I have created a file called as procfile.txt, which is a simple like a text file, a notepad file. So I'll open this. So this should be the same. So this like won't change. So we have this web uvcon main app. So main is the Python file that we have created, and app is what we have mentioned here. So it is the instance of this fast API. So this won't change. Okay, so you have to create the same proc file in a text, in a txt file, and we have to save this. So web is nothing but we are mentioning that this is kind of a web app, and so this is Procfile is a special file that we have in like Unix OS and things like that, where it tells the system that what kind of process and system that I'm trying to create or work on. So here we are trying to create some kind of a web app, as a API. So that's why like we are mentioning this. So you don't have to worry much about it. So just copy this same thing, and you can just put it in a txt file. And once you have like created this txt file, go to this file and give save as. And in this save as, I'll go to my desktop and just remove this extension. So there shouldn't be any extension. Okay, so it should be just proc file. So now I can save this. So it will give me a warning as like it already exists. Do you want to replace it? So this is the file that it is like mentioning. So I'll just replace this. I'll close this one. Okay, so let me just do one thing. I'll copy this and delete this file. So again, the name of this file should also be the same. So I'll create a new text file from here. So text document, I'm going to name this as proc file. And here I'll paste what I copied. So now I'll save this as txt. Again, I think it will give me an error. Okay, or let me just rename this. Um, Let me put this as text file and copy the content in it. And I'll save another copy as proc file. So without any extension. So P should be caps. See? Okay, so this has created this as procfile.txt. Okay, so the problem is we again have this extension. So I'll just remove this from this rename option. So I'll go to this rename, and I'll remove this .txt. Okay, so this will create a proc file. So I'll give yes here. So you cannot open this now. So this is the file that we need, and this is the file that is currently present in this particular folder. So which is this proc file. Okay, so we have this diabetes underscore model.sav, which is the saved model, and the Python file for creating this API. Proc file, which is like needed for Heroku to know that this is some kind of a API that we are creating, and requirements.txt for mentioning all the libraries that we need, and finally runtime, which basically contains your Python version. So these 5 files are the things that we need for deploying this API, and the deployment is like very much easier in Heroku. So I'll go to my GitHub, first create a repository. So in your home page, you can see this new option. So I'll give this new, and I'll name this repository as
API for ML Heroku. So let this be the name. So you can give any name, and I'll give a description as deploying ML model API in Heroku. Now, so you can have this as public or private, so anything you want. And later, I'm not going to create README files and all those things. I'll just create this repository. So once this repository is created, we can add the file. So here you can see create a new file or uploading an existing file. So I'm going to upload existing files. So here from I'll go to this desktop and this ML API in Heroku. So these are all the files that I need, right? So I'll choose all these files and upload all these files here. So these files should be uploaded here. So if you can also like use a different model, the procedure kind of remains the same. Okay, so for any use cases that you are working on, so you have to build your model separately and save that model, create this API file, proc file requirement.txt and runtime.txt. Okay, so after that we can commit this changes. Now all these files will be uploaded to our repository. Okay, so yeah, so this is the repository that we have. Now I'll go to my Heroku. So the main thing that you have to note here is the account or email ID that you have used for creating this GitHub account should be the same which you are using for this Heroku. So then only you can like connect these two GitHub account and the Heroku. So then only this Heroku session can access your files from your directory. So don't use like two different mail IDs for creating accounts in GitHub and Heroku. So that's very important. So once you have created this account, so you have this home page from where you can give this create a new app. Okay, so if you couldn't access this, just go to this dashboard.heroku.com/apps after signing in. Okay, so I'll give this create new app. So I'm not going in detail about how to sign up and sign in. Okay, so all those things. So here we have to name our applications. So I'll name this as YAML API Heroku. So you can just you cannot like use underscore and all those things. So you can just use a hyphen. Okay. So I'll put this as ML API Heroku. So it is not available. So like this should be a unique name. Okay. So let's try different names, or I'll give this as ML model as API Heroku. Yeah, so this is available. So ML hyphen model hyphen API Heroku. So here you have like two options. So you can just go with United States and you can create this app. Now here you have like these three options. So you can either connect all these things using like Heroku CLI, this command line interface, or you can use GitHub accounts, or you can use this. So the easiest way is to put all the files in a GitHub repository as we have did, and connect our repository to this Heroku. So that's the most easier way. So I'm going to give this connect to GitHub. Okay, so this will get connected, and this is the account. So this is nothing but the account that I have in GitHub. So if not, you just have to connect to it. And repository name. So here mention the repository that we have created, which is API for ML. So you don't have to give this complete name. So I can just say API for and give this search. So it will give you all related repository in your account. So it gives me Siddharthan 23 slash API for ML Heroku. So this is the repository that we have created. Now I can give this connect. Okay, so this is to access all the files in that repository. So you can mention the branch. So I don't have any other branches here, so I just have this main branch. So if you wanted to keep all these things, all these files separately and create a new branch, just go here and create a new branch. So you can just name this branch as anything, and you can mention that specific branch here. So I'll just go with the main branch itself. So once this is connected, you can give this enable automatic deploys, and after that give this deploy branch. So this is where the deployment starts. Okay, so here all the libraries that you have mentioned in your requirement.txt gets installed, and we have this runtime.txt, right? So the Python version that you mentioned will get installed. So you can see, so here it says installing Python 3.96. So here you can see, so using Python version specified in runtime.txt. So this is what, so this is why we have created this runtime file, and all the libraries will be installed. So we have like pickle 5, Pydantic, fast API, and so on. So all this libraries will get installed. We just have to wait like for a few minutes. So if you have like several libraries and large libraries, this will probably take some time. In this case, it will probably take a minute or two, so not more than that.
and finally we will get our URL, and we can use this URL and we can post data to this URL and understand whether that person is having diabetes or not. So this is how all these things is going to work. Okay. Yeah, so this is the URL for this. So you can copy it here. There is also another way, so I'll show that to you. So we will get a notification once this process is completed. And so for creating account, just go to Google, search Heroku. So this is the link. So www.heroku.com. So Heroku Cloud Application Platform. Yes, so now our API has been deployed. Now I can give this view. So this will take me to the URL that is generated. Here it says detail not found because it won't work all alone. So we have to post some data to this API. So I copy this URL. So ML model API Heroku, which is the name of the app that we have created. So I'll close this now. After copying the link, now I'll go to this file API implementation. So this is also something that we have done in the previous videos. So this is the local host URL that is generated for us for creating this API. So I'll paste this here. So this is the public URL that we have now. Okay. So this is the endpoint that we have. So this is the file that we have discussed, right? So here we have created the endpoint as diabetes underscore prediction. So you can also have different endpoint names, but you have, like, you should mention the same endpoint name here as well. Now how this works is, this is the URL for this API, and this is the data that I'm posting to this API. So pregnancy value is 1, glucose value is 85, 66, and so on. So this is what we call as post API. And how we are posting this is, this is in the form of a dictionary now, but API accepts the data in the form of a JSON. So we have to convert this dictionary into a JSON object, and this is what we are doing here using this JSON.dumps. Okay, so we are taking this input data for model, and then we are converting into a JSON object using this JSON library. Okay, and here also we will be using this JSON library, so we are importing it, but we don't have to mention this in our requirements.txt because this is a basic library in Python, so it will already be installed. So we don't have to mention that. And we are using this request module, request library. We are going to post this data, which is input JSON, to this URL. So this URL is nothing but the Heroku URL that we have got. So this is for the person who doesn't have diabetes. So I'll open this diabetes.csv file, and you can see, so 185. So this is the data point that we have. The outcome is 0. That means it should say that this person is not diabetic, right? So this is the data that we have, and let's see. So I'll run this, and here we will get the result as whether the person is diabetic or not. So here you can see, so it just gives me the result in a couple of seconds. So now you can change this to another data point. So let me open this again. So if you put these values, so it will tell that person is diabetic, because we can see the outcome is 1. So this is a trained model, and we are using it now. This URL, anyone can access it. Okay, so once you have deployed this URL, you probably give this to a person who is building UI for you, and that person will like integrate this URL in their UI, and they will post the data to you. So your role is to work on this API. Okay, and you will get these values from the UI part. So let's say there are like multiple input fields, and the person is giving all these values. So once they click the submit, this data should come to you, and based on the model that we have trained here, we will like predict whether the person is diabetic or not. So this is how the whole thing works. So this is how we can create this public URL using Heroku. Okay, and there are some errors. You can see those errors in this more. So if there are some errors, like if you give this view, so it will tell you that there are some errors, and for understanding what that particular error is, you have to go to this more and give this view logs. And here it stores all the logs. So it tells like we have created this API and so on. So all these things comes. Okay, so for now I'll just go to this overview itself. So this is how all these things work. So I just wanted to mention a couple of things. So in like in a production environment or real time, so we won't be using this kind of a cost. So when we say asterisk, as I've told you, this is for telling that anyone can access your API. So here we will mention specific domains, or the other way to protect your API is we will generate some keys for your API. So the person who has the key for your API only can access it. So this is more secured way, right? So for now we don't have to worry about this, as this is just for exploring this APIs and stuff like that. Okay, so that's it from my side. I'll just give you a quick recap of what we have done in an overview. Okay, so in this file we are creating this API using this fast API module, and we are mentioning the format in which we need the data. Okay, so here you can see we are sending the data in the same format. So this Python file is to just emulate what we are going to do in the UI screen, so where we are going to pass all these values. So instead of creating the UI screen, I'm doing this in the Python itself. Okay, so we are creating this post API with the input diabetes understood prediction, and we are loading this saved diabetes model. So once we get this data, we are processing it so that we can feed this data to a trained model, and it can predict whether the label is 0 or 1. Once the label is 0, it says the person is not diabetic. If the label is 1, it says the person is diabetic. So the files that we need are this saved model file, Python file for creating API, proc file which says this web, and this like specifications and things like that, and we have this requirement.txt mentioning all the libraries that we need, and finally runtime.txt, which contains the Python version that needs to be installed on Heroku. So we just have to create a repository in GitHub, put all these files here, and in Heroku connect your GitHub account. So give a name for your API, give the region as either UK or US, and connect your GitHub account, and finally you can just give this automatic deploy. So you have to enable that and deploy the branch, and within few minutes your API will be deployed, and you can use that particular link either in your UI, or you can just create a different Python file like this and you can work on it. Okay, so I hope you have understood all the things covered in this video. So I'll also give the link for this particular Python file itself, and you will have access to all the files that we have worked on. So please try to build a API of your own. So just watching the videos probably might not help, so I suggest you to take a different model. So here we have used a diabetes model, right? So similarly take a different model and try to replicate the same thing and try to create this API on Aero. Okay, so yeah, so that's it from my side.
Projects, and in this playlist I will be uploading videos on deep learning use cases and projects where we will use neural networks, and I'll post videos on the machine learning course which we are working on already. So those videos will be posted regularly, and once in a while I'll try to make some videos on the deep learning project, so that it is not monotonous for the viewers to watch, and you can also learn deep learning on the go. Okay, so that's the idea. And the first project that we are working on in this deep learning playlist is breast cancer classification with neural network. Okay, so if you're following my channel, you would have seen the project video in which we have worked on this breast cancer classification dataset, which is basically a numerical dataset, and in which we have used the logistic regression model in order to classify the data points as benign or malignant. So it is the same dataset that we will be working on. So if you haven't watched that video, you can just check this one out. And in this we will be using the neural network as I have told you. Okay, so this will be a very simple neural network that we are going to build. And if you have never worked on deep learning, if you have if you don't have any idea on how to create this neural network, so this video will be very simple for you to understand, and you can also implement this for other numerical data set as well. So this is the idea that I wanted to make this video on, so that it is easier for the viewers to make their own neural networks for different projects. And so as I've told you, we'll be working on this breast cancer data set. So all this codes, I've just made some simple data processing techniques that we already done in the previous video of breast cancer classification. I'll explain you what are all the things that we are doing here. So but we won't be including any data analysis stuff and feature engineering stuffs and all that. So we will be including only the basic things, so that we can focus mainly on building the neural network. And so if you want to get a clear understanding about this data, and if you want to know how to perform data analysis and all those things, so you can refer these videos. So the first video is basically, as I've told you, this is where we have used the machine learning model, which is basically the logistic regression model, where we use that model in order to classify the cancer. And the second video will be on the exploratory data analysis on this breast cancer data set. So I have provided the link in this collab file. And then how you can do some data visualization on this particular data set. So I have given all these three links. I'll also give the link for each of the three videos in the description of this video as well, so you can check that out. Okay, so I'll just quickly explain what are all the data processing part that we are doing, before moving on to the neural network part. So first is, we know we are just importing the dependencies that we need. Dependencies in the sense the libraries and the functions that we will need. First, we are importing the numpy library. So numpy is very important because we may need to create some numpy arrays, we may need to perform some math on those numpy arrays and so on, and for that we are importing the numpy arrays. And then we are importing the pandas library. So the use of this pandas library is to create a data frame. So you can see, so this is how our data set basically looks like. In order to to get a better view of this data, to perform some analysis and processing, it is better to load this data to a pandas data frame. So data frames are nothing but more structured tables in which we can get a clear idea about our data set. So for that we are importing our pandas library, and then we are importing the matplotlib.pyplot. So once we train our neural network, so we will visualize how this training has been going on. So for that purpose, I'm importing this matplotlib library, and we are importing this sklearn.dataset. So this is the module. So sklearn has a module called as datasets, and this particular datasets module has some basic datasets like this breast cancer dataset, house price dataset, etc. And then we are importing the train test split function from sklearn.model selection, so that we can split our data into training data and test data. So these are all the basic libraries that we need. And once we are creating a neural network, so in that case we will be importing the TensorFlow and Keras, so that we will deal with in the later part of this video. Okay, so usually we use neural networks on image data and audio data, but there are not much tutorials available on how you can use neural networks for numerical data. So that's why I wanted to create this tutorial, and after this I'll post videos on how you can use this similar neural network for text data as well as image data as well. So that will be the upcoming videos. For now, let's focus on the numerical data set. So the first step is loading the breast cancer data from sklearn.datasets. So you can see here, so sklearn.datasets is what we are importing, and from that I'm giving this function called as load breast cancer, and I'm storing this dataset in a variable called as breast cancer data. So this is basically in the form of a library, it is in the form of a dictionary. So I'm printing this breast cancer dataset. If you see this dictionary, there is a key called as data, and this particular data contains all the feature values, and there is another element pair, which is basically the target, which is 0 or 1, where one target represents benign and the other target represents malignant. So the idea of this data set is, so if we give all these features, the model will tell us whether the particular tumor is benign or malignant. So benign tumors are localized, so these tumors doesn't travel to other parts of the body. Whereas if the tumor is malignant, so then only we call it as cancerous, because these tumors have the ability to move to the other parts of the body, and the problem gets serious. So this is what we are working on in this particular data set, where we have to predict whether a particular patient has benign tumor or malignant tumor. So that's the idea. And again, if you wanted to get a clear understanding and detailed understanding of this particular data set, please watch these three videos so that you understand this completely. And after that, so you can see the feature name. So these are all so this is the target name, which is malignant or benign, so 1 and 0, and we have the feature names. So if I just scroll here, so it will be given as this. Yeah, so you can see the feature names. So feature names are nothing but the names of the columns. You can see mean radius, mean texture, and so on. So these are all the values. So the data or the values that is present in this key called as data, or the values for the corresponding feature names. So we will understand how this comes and all that. And yeah, so now we are going to load this data, which we have loaded to this breast cancer data set, into a pandas data frame. And for that, I'm creating a variable called as data frame. So this will be the name of the data frame that we are creating. And here I'm using the pandas library, and I'm using the function data frame and breast cancer dot data. So when I run this, it will take all these values. So we know that this is the data set that we are working on. And when I mention breast cancer data set dot data, so all these values will be loaded from this to this. Okay, so all these values will be loaded. And after that, I'm setting columns. So columns is nothing but the feature names that we have seen. So when I give this feature name, so we get all these column names from this particular sklearn data set. So next, I'm just printing the first 5 rows of the data frame, so that we can get the sample on how this data set looks like. So we can see the columns like mean radius, mean texture, mean perimeter, and so on. So you can see the column names. And if you so if you want to check the number of columns. So you can see here, so 30 columns, 5 rows and 30 columns are there. So it basically gives us the first 5 rows, so that's why it is giving this as 5, and the total number of columns that we have is 30. So that means we have 30 features. And now we are going to add the target column to our data set. Okay, so target column is nothing but 0 and 1, which represents malignant and benign. So for that, I'm just creating a new column called as label. So you can also name this column as class, or you can name this as target, or anything you want. So in this, we are loading this target. So this target is this one. So when I run this value should be added to my data frame. So now what I'm doing is I'm just printing the last 5 rows of the data frame. So if I scroll to the last, now I can see a new column called as label, whereas previously it doesn't contain that particular column. So we are just basically adding a new column. So the idea here is, so if you give all these features, so if you give all these features to your neural network or to your machine learning model, it should predict what is the label. So all these things becomes your X, and this final column becomes your Y. So this is the output that we are going to predict, and all the other 30 columns will be our input. Okay, so if you want to determine, or if you want to check how many rows and columns are there in your data set, you can run the function called as shape, data frame dot shape. So data frame is the name of the data frame that I've created. So you can name this as anything you want. So when I run the shape, I get that there are 569 rows and 31 columns. So 569 rows means there are 569 patients. So all these patients, the tumors of these patients will be classified as either benign or malignant, and 31 columns are there. Next, so data frame dot info. So this will basically tell you how many null values are there, and what is the data type of the columns that you have. So null value means missing values, non-null values means those values are present, right? So totally we have 569 entries, that means 569 rows. So each of this represents the column names. So 569 non-null values means 569 values are present in the mean radius column. So again, 569 values are present in the mean texture column. So all the values are present in this data set. So there are no missing values in this. So if we have some missing values, we need to process that. And all the data types are in the form of float, except the label, which is in the form of integer, which is 0 and 1. And next, you can also run this in order to check how many number of missing values are there in each column. So this one is similar to, so this particular value is similar to this one. The only difference is that, so this will tell you how many non-null values are there. That means how many values are present. And when you run this dataframe.snl.sum, it will tell you how many missing values are there. Okay, so 0 means there are 0 missing values in the mean radius and so on. So we can see all the values are 0. That means no values are missing in any column. So that's the idea. And then we are checking some statistical measures. So this is useful for us when we are doing some more data analysis on our data set. So describe will give me the descriptive statistical measures like count. So count is nothing but how many values are there in each column. So mean will give me the average value of each column. So STD is the standard deviation, minimum is the minimum value of each column. So this is my 25th percentile, 50th percentile, 75th percentile. So 25th percentile means 25% of the values are less than 11.7 in this mean radius column. So again, it is similar to 50th and 75th percentile, and this is the maximum value for each column. And 50th percentile is my median value. So I hope everyone is clear about these things, because like we have worked on this isnal, describe and info on several of our projects. So I hope everyone is clear. So I'm just quickly going through all the codes. So if you don't understand this, again, you can just go to this exploratory data analysis video and breast cancer classification with logistic regression video, where I've made a very clear and detailed explanation on all these things. So the next thing will be, yeah. So next we are counting how many values are there for benign case and malignant case. For that, I'm using this value count. So this is basically to check the distribution of the target variable. So we know that there are two target variables, which is either 0 or 1. Which is the sklearn datasets target. Okay, so we are checking how many data points have the label as 0 and how many data points has the label as 1. So we can see there are 357 data points with a label 1 and 212 values with the label 0. So the reason we are checking this is, if there is a huge imbalance in this distribution, we have to process this data. So let's say that there are 500 data points for this label 1 and only 100 data points are there for the label 0. So in that case, there is a huge imbalance. So in that case, we will perform methods like upsampling or downsampling so that the distribution is even. So this is very important when it comes to machine learning. So because like if there is imbalance, the model don't learn well or it won't be trained well. So in this case, it is not a problem because like the imbalance is not that much high. So we can just ignore this particular thing. So 1 means benign and 0 means malignant in this case. So this is if you wanted to know how we arrive at this particular information, so you can go to the documentation of sklearn.datasets. So this sklearn.datasets, where in that you can go through this load breast cancer. So in that the details will be given, or you can go to the UCI machine learning repository of this breast cancer dataset where these details will be given. So understand that 1 means benign and 0 means malignant, and this is what we wanted to classify. And then we have another function called as group by. So what this group by function does is it will group the data points into these labels, and it will give me what is the mean value for each of the labels. So just look at this one if you don't understand this. So I have label 0 and then I have label 1. For all the data points that has the label 0, the mean value for this mean radius is 17.4, and the mean or average value for all the data points with label 0 as an average value of mean texture as 21.6, and so on. So this is the mean value for the label 1. So we are grouping all the data points with label 0, and we are grouping all the data points with label 1, and when we are finding what is the average for each of the columns. So the important inference that we can get is, so we know that 0 means malignant, which is the most dangerous state, and benign is not that much dangerous. So the value are kind of more for the label 0, which is malignant. So malignant, as for malignant, most of the column values are greater when you compare it to the benign value. So you can see, so it is 17.4 here, this is like 12 something, so this is 21, this is 17, and so on. So the values are kind of more for malignant cases. So there is a clear distinction. So like this is very important for us because it clearly tells us for malignant cases the values are kind of higher. So these features are nothing but the values that are taken from a test called as fine needle aspiration, which is basically a biopsy of the tumor, where they will collect the sample of this tumor cells from the patient, and they will run some test on some microscopes. I'm not exactly sure what is the process, but it is taken from this test, and these are all the cytological values. Cytological in the sense the measurements of the cells that they are taking for the sampling thing. So after that, so if we are doing some more data exploratory part, so we will probably use some plots and other things in order to get some more information on the data set again. So this is not a data analysis video, so this is implementing neural networks. So let's not go deeper into it. So just a second. Okay, so now what we are doing here is we have to split this data into features and target. So I'm creating two variables. So one variable is x and the other variable is y. So x will contain all the columns except the label column, and this label column will go to the variable called as y. Okay, so here what I'm doing is, so I'm taking the data frame and I'm going to drop a column, and that column is label. So axis is equal to 1. So this means like whenever you want to drop a column, you will mention axis is equal to 1, and whenever you want to drop a row, you will mention axis is equal to 0. And I'm storing all the label into the variable called as y. So after running this, if I print x and y, so you can see that so this x doesn't contain the last column, which is label. So it will contain the columns from this mean radius all the way up to worst fractal dimension. So it basically contains 30 columns. So you can also see here, so these are all the 30 columns that we add initially, worst fractal dimension. So we again, so we have this label column, so that won't be present in this x. So this y will contain the label column, which is basically my target. So the reason we are doing here is, whenever we are training our machine learning model or neural network, we need to give the features and the target separately. So features are nothing but the input that we are giving to the model, and based on that input, it will predict my target. So that's the idea. And after this, we are splitting our data set into training data and test data. For that, we will use the function train test split. So we have initially imported this function from sklearn.model selection, and here we are creating 4 arrays: x train, x test, y train, and y test. And I'm splitting x and y. So these are all the attributes for this train test split function. So I'm going to split this x and y into xtrain, xtest, ytrain, and ytest. So xtrain is nothing but training data of all these features, and the corresponding labels will be stored in ytrain. And xtest is the test data features, and all the labels for this test data will be stored in ytest. Okay, so xtrain is the features of training data, the corresponding labels in ytrain. Xtest is the test features, and ytest is the labels for those test features, and so on. And the test size is equal to 0.2. That means I want 20% of the data to be my test data, and random state is equal to 2. So the reason we are using this random state is, if you are using a different random state value, your data will be splitted in a different way. So if you want your data to be splitted in the same way as my data is getting splitted, then we both have to use the same random state. So that's the idea of random state, and the only purpose is to get some reproducible results. So it is not like that much important. So it is just to get some same results whenever we run our code. So we are checking how many data points are there for the training data and test data. So x is my original data set, which contain 569 data points, and 80% of the data, which is 455, goes to my x train, and 20% of data, which is 114, goes to my x test. Okay, so we have worked on these up to these things before, and what we are going to see after this is what is new for you. Okay, so if you haven't worked on deep learning, so this is the part where we will be creating a simple neural network in order to train this neural network with this breast cancer data. Okay, so now we know that a neural network will contain several layers. So the first layer is my input layer, where I will give my features, and the final layer is my output layer, where the model will actually predict whether the target is either 0 or 1. In between, there can be multiple hidden layers. Okay, so there can be one hidden layer, there can be 10 or even 100 hidden layers in a neural network. So we need to develop this particular structure. So we need to create some layers for our input, a single layer for our output, and several layers for hidden. So input and output will be one layer, and hidden can be multiple layers. So this is what we are going to work on, and this is the most important part of this video. So for creating this neural network, we are going to use two libraries. One is TensorFlow, and the another one is Keras. Okay, so let me just make these text as bold, and now let's import the required libraries. So this will be importing TensorFlow and Keras. Okay, so I'm going to import TensorFlow as TF. So TensorFlow library is already installed in Google Colab, so I'm not installing it. So if you are working on Spider or PyCharm, you probably have to install this TensorFlow library. So using pip install or Anaconda installation, so you can use any one of those. So in Colab it is already installed, so we don't need to worry about it. So next thing that I'm going to do is I'm going to set a seed. So tf dot random dot set seed, I'll give a value as 3. So I'll explain you why we are doing this. And then we are importing Keras. So from TensorFlow, import Keras. So let's try to understand this TensorFlow and Keras. So TensorFlow is the deep learning library developed by Google. Okay, so there are several functions, and like we can create neural networks easily by using this library called as TensorFlow. And again, there are several other libraries like PyTorch and Microsoft CNTK, which is basically cognition toolkit. So these libraries are used for creating deep neural networks and so on. And the widely used libraries for deep learning are TensorFlow and PyTorch. So if you think about this Keras is not a standalone library, so it is just a wrapper of this TensorFlow and Keras. So like when TensorFlow was released initially, it was hard to make neural networks from TensorFlow, because like the coding part is bit hard. What Keras did is it used TensorFlow as its backend, and after that, the building the neural networks became easy, because they have created several APIs and functions so that we can easily build our neural network. So that is the use of this Keras. So you can set your backend to TensorFlow or PyTorch in Keras. So here we will be using TensorFlow. So after a while, TensorFlow included Keras in their library itself. So that's why we are importing Keras from TensorFlow. So you can also import TensorFlow separately, and you can specify the backend as Keras, but this is more easier. Now coming to this random seed. Okay, so I have set this set seed to 3. So whenever you are training a neural network in Keras, so there are several weights and parameters that will be initialized. So each time you train your neural network, so as it is a random way of generating the values, some of the values may be different. So the final outcome is that your accuracy value may change each time you run your neural network. So in order to avoid that, we set a random seed. So if you set this random seed, no matter how many times you run your code, you will get the same accuracy score. So that's the idea of this, setting this random seed. So this is just like, this random state to just get, reproducible results. So the main thing is we are importing TensorFlow and we are setting some random seed, and then we are importing this keras from this TensorFlow. So you should set this random seed as soon as you are importing this TensorFlow, then only it will work. Okay. So these are all the two libraries that we need, TensorFlow and keras. So I'll run this one, and now we are going to build our neural network. So cannot import keras from TensorFlow. Okay, so there is some error. So this should be a small letter, so it should not be in caps. So that's the thing. Okay, so I'm importing TensorFlow and keras. Now I'm going to build this layers: input layer, hidden layer, and output layer. So I'll create a command here as setting up the layers of my neural network. Okay, so for this I'll just create a variable called as model. So in this model only I will create my neural network layers, and for this I'm going to use keras.sequential. So you probably would have heard about this sequential. So this is where we will stack the layers of our neural network. So this is a very useful function that is present in this keras. So keras.sequential, I'll just create a list here. Okay, so what we are basically doing here is, so now we will be setting up the layers for our neural network. So keras dot layers. Okay, so keras dot layers dot flatten, and in this I'll mention my input shape. Okay, so or else I'll just mention the layers first. After that we can mention the number of neurons and the parameters for it. Next is keras dot layers dot dense, and finally keras dot layers dot dense. Okay, so this keras dot layers dot flatten is my first layer of network, and second I have an hidden layer which is this keras dot layers dot dense. Okay, so this D should be in caps, and keras dot layers. So the third one is my output layer. Okay, so we are creating one input layer, one hidden layer, and one output layer. Okay, so dense means all the neurons in that particular net layer is connected to all the neurons in the previous layer. So if you see this, so if you see this neuron alone, so we are getting the data from all the other neurons in the input layer. So we have three neurons in the input layer. So this neuron gives its output to this first one, and this second one also gives its input. This third neuron also gives input to the this particular neuron. So this will be carried on for all the other neurons as well. So if you think about this four neurons, all the four neurons will get the input from all the three neurons in the previous layer. So that's what dense means. And flatten. So there is an interesting thing about this flatten. So whenever we are training our machine learning model, we will feed this X train and Y train directly to our model, right? So if you think about this X train, it is in the form of a matrix, right? So this matrix contains 569 rows and 30 columns. But whenever you are training a neural network, we have to flatten this. Flatten in the sense we have to convert this into a single dimensional array. So this is very important. Okay. So each feature will go to one neuron. So if you think about this particular data set, so we have 30 features. So each feature for each feature we will give one neuron in the input layer. So there is not much function or not much work that has been done in the input layer. So this is just used to pass the value to the next hidden layer. So the number of the number of neurons in your input layer is equal to the number of features that you have in your data set. So this is like specific for numerical data set alone. For image data, this is like slightly kind of different. So we will deal that with deal that at a later time. But again, I hope that you understand the purpose of this flatten is to convert the data into a single dimensional array. And here I need to mention the input shape. So in this input shape, mention the number of columns that are there in your data. Okay, so 30 comma, so this is how you need to mention. So if there are 10 columns or 10 features in your data, then you have to mention 30. And the important thing is that this doesn't contain the output, which is my target. So this is the number of features alone. So input shape is equal to 30. So this particular flatten layer will flatten our data and it will convert it into a single dimensional array. And the next one is my hidden layer. So in this hidden layer, let's say I want 20 neurons. Okay. And the next important thing that we need to mention is the activation function. So activation is equal to ReLU. So ReLU stands for rectified linear units. And finally, my output layer. So in my output layer, I'm going to have two neurons. And here the activation function is equal to sigmoid. So sigmoid is just like the logistic regression function that we have. Okay. So in this hidden layer, I have mentioned 20 neurons. So in this image, we have 4 neurons in the hidden layer. So we have one hidden layer, we have 4 neurons. So in this case, I am mentioning 20 neurons. So you can give different number of neurons and you can check how the model is working. So in this case, I'm just giving 20 neurons and the activation function is reduced. Whereas in the output layer, I am giving the number of neurons as 2. So this is like very specific. You should not give any other values. The reason is the number of neurons that you are giving in this output layer is equal to the number of classes that you have. So if you just go through this data, we have two classes. One class is 0 and the other class is 1, right? So the number of I'm just repeating this again. So the number of neurons in the output layer is equal to the number of classes that you have. If you have three different classes, in that case you will be creating, this number will be changed to 3. Sorry, so this will be changed to 3. If you have 10 classes, in that case we have to convert this to 10 and so on. So in this case there are two classes, hence we are creating this two. So this is like very important for us. So what happens is, let's say that this is the two neurons that we are creating. So let's say that when the output is 0, this will give us the signal as 1. So when the output is 1, this will give us the 1. So like a specific neuron will fire for each label. Okay, so I'll just take an example. So let's say that the output that our model is predicting is 0. So 0 basically means malignant, right? So if I go there, okay, so 0 means malignant. So this particular neuron will give me the output. So this will be blank. When my output is 1, that means benign, right? Then this neuron will give me the output. So that is the idea. So this is what we call as firing of neurons. And when one neuron is firing, the other neuron won't be active. So like firing in the sense the output will be 1. So that is the idea. So that's why we are creating two neurons in the output layer, which is equal to the number of classes that we have. So we are creating this flatten array, or this flatten layer, in order to convert our data into a single dimensional array. And then we are creating a hidden layer with 20 neurons. And finally we are creating the output layer with two neurons, as we have two classes. So this is my model, and I'm stacking all these layers using the sequential function from Keras. So I'll run this. The next step is we have to compile this array. Okay, so I have to put a comma here. So I missed this one. Okay, so let's run this. So this will create the structure for this neural network. Now we have to compile this neural network with some factors. Okay, so this is a very simple neural network, as I've told you. So this is a very simple data set. So this particular network will work fine. So if your data set is complex, and in that case we probably have to add several neurons and several layers to our neural network. So if you want to add another layer, so what you will basically do is you will again add keras.layers.dense, and so I'll just copy this one. So you will just put this one. So keras.layers.dense, 20 neurons ReLU, right? So I will just add this here, and I can just change this neurons to maybe 30 or 40 or whatever it is, and I can just change this ReLU to sigmoid. So now this particular neural network has two hidden layers. So this is how you can add a new layers to your neural network. And again, there are several activation functions like sigmoid, rectify linear units, which is my ReLU, and there is other activation functions called as leaky ReLU and so on. So we will discuss the theoretical part and how these things work on all those things in the deep learning course. So this video is purely for implementation part. So understand that for each layer and for each neuron, we have to mention the activation ReLU. So it is not that we have activation function for the entire layer. So it is not that. So each neuron will have an activation function. Okay. So when I mention ReLU, all the 20 neurons in the hidden layer will have the activation function as ReLU. And when I mention sigmoid, all the neurons in the output layer will have the activation function as sigmoid. So that's the idea. So after this, we have to compile our neural network with factors like optimizers, loss, etc. Okay. So this part will be compiling the neural network. Okay. So for this, I'm going to use model.compile. Model.compile. And this model is nothing but the keras.sequential that we have built. So in this, I'm going to mention my optimizers. So first one is my optimizer. So here I'm going to use my Adam optimizer, and the loss that I'm mentioning here is sparse categorical cross entropy. Sparse categorical cross entropy. Okay, so this is the loss. And finally, I'm going to use the metrics as accuracy. Okay. So this is my accuracy. Okay, so this is compiling part. So we are setting the optimizer to Adam optimizer, loss function as sparse categorical cross entropy, and metrics as accuracy. So again, there are several optimizers and several loss functions that we have. So you can again do some research on what is meant by this Adam, what is meant by this sparse categorical cross entropy, and so on. So I'll explain all these things while we are working on our deep learning course. So please do some research on this part. I'll just give you one idea. So whenever you're using the target variable as 0, 1, 2, 3, and so on, in that case we have to use sparse categorical cross entropy. And when you have one not encoded labels, in that case we will use categorical cross entropy, so we won't use sparse. So one not encoding in the sense, let's say that there are three objects. Okay, so let's say that we want to build a neural network that will predict whether an image represents dog or a cat or a horse. So let's say that we are labeling this dog to 0, and we are labeling cat to 1, and we are labeling horse to 3. Sorry, 2. So these are all the three labels that we have: 0, 1, and 2. So whenever you are using the target variable as this kind of integer labels, so in that case you will use the sparse categorical cross entropy as your loss function. Whereas if you use one not encoding, so how one not encoding will look like is, so just create a text cell here. Okay, so if it is a dog, I will mention it as 1, 0, 0. If it is a cat, I will mention it as 0, 1, and 0. If it is a horse, I will mention it as 0, 0, and 1. So this is what is called as one not encoding. Okay, so you can see if it is dog, the first value should be 1. If it is cat, the second value should be 1, and the other value should be 0. If it is horse, the third value should be 1. So this is what we call as one not encoding of labels. So if we have multiple labels, when there are 10 labels or 20 labels, in that case we probably will go with one not encoding. Whereas in this case we just have two labels, right? So benign and malignant, so we can just go with this numerical kind of encoding called as label encoding. So whenever you are going with this normal label encoding with the 0, 1, and 2 as your label, we will be using sparse categorical cross entropy. And when we are using this one not encoded labels, in that case we will just use this sparse categorical cross entropy. So this is like two kinds of loss functions. Similarly, there are other loss functions as well. So you can just go to the Keras documentation of this loss function, and you can do the research on it, so you will get some idea. So this is the compiling part of this model. So I'll just run this one. So we are creating input layer, output layer, and one hidden layer, and we are using the Adam optimizer and sparse categorical cross entropy as the loss function, and the metrics used is accuracy. Now we need to train our model. So this part is training the neural network. Okay, so it is just similar to machine learning. So in machine learning, we use this model.fit, right? So similarly, we will use this model. So model is my neural network that I'm building. So model.fit, xtrain, and ytrain. And I'll set my validation split to 0.1, and epochs is equal to 10. Okay, so we are feeding my we're feeding this x train, y train, validation split, and epoch. So validation is just like the train test split we are doing on. So while the model is training, it will do the testing on this validation itself. So it is just like train test split. So we have x train, y train, validation split as 10 percentage of the data. Epochs is equal to 10. Epochs is like how many times your model has to go through the data. So that is the epochs. So x train is my features, and y train is my labels. Okay, so which we have splitted from this x train, this train test split function, and so on. So when I run this will train my neural network, and I will see what is the loss at each epoch and what is the accuracy at each epoch. And before doing this, I'm going to create another variable called as history is equal to model.fit. The reason is, so we will be plotting the loss value and accuracy value while the training has been going on, and for that we generally use this variable name called as history. So this is just like the convention that we use while training the neural network. So I'll run this. So this model will be run for 10 times, which is the 10 epoch. So there is some error that I'm getting here. So let me just go through it. User code, unknown loss functions. Okay, so I just made a spelling mistake here. So it's sparse. Okay, so I'll set my model.sequential again. I'll compile this and let's train our model. Again, I'm getting an error. So unknown metric function called as accuracy. Okay, so I'm just making several mistakes today. So accuracy. I hope everything is fine now. Let's see. Yeah, now our model is training. So when the model is running for the first time, the loss function that we are getting is 23, which is a very huge loss function. And the accuracy on training data is 0.22. And the validation loss function is 20, and this is the validation accuracy. So we have training data loss, training data accuracy, and this is the validation loss, validation accuracy. So if you see this, we have 10 epochs, and at each epoch, the loss function is decreasing and the accuracy score is increasing, right? So we have started from 22.7 percentage accuracy to 78.73 percentage accuracy. Now when we use a logistic regression model for this particular data set, the accuracy is kind of more than 90 percentage, whereas in this case we are getting 78 percentage accuracy only, and the validation accuracy is 86.9. So this is like pretty less for neural network model, right? The reason is we haven't standardized our data. Okay, so if you see this, the data will be in different ranges. We don't apply, we didn't apply the standard scalar function, and that is the reason why we are getting this low accuracy. And now I'm going to apply the standard scalar function to my data. Okay, so that should be done after splitting our data to training data and test data. Okay, so this is very important. So we should not do this before splitting into training data and test data. So like I've seen like few people have asked me that even if I standardize the data and even if I don't standardize the data, the accuracy is kind of similar in some machine learning models. So I've mentioned that in some cases this will be a huge difference. So in this case, now we will see that first time that if we apply this standard scalar function, the value will increase, the accuracy value will increase. So this part of the code will be to standardize the data. So we have done this before actually. Okay, so standardize the data, and for this we'll be using the function standard scalar, which is in sklearn dot pre-processing. I'm going to import standard scalar. Okay, standard scalar. Now I'm going to create a variable called a scalar, and this is where I will load the instant of the standard scalar function. And I'm creating a variable called as xtrain standard, which is equal to scalar dot fit transform. So this is very important. So I'll just explain you after doing this. So fit underscore transform xtrain, and after this we will create a new variable called as xtest standard. So this is the standardized training data, and this is the standardized test data, is equal to scalar dot transform xtest. Okay, so let's try to understand what we are doing here. So we are loading the standard scalar function. Now we have to fit our data, which is our training data, to this xtrain, and then we have to transform it. Okay, so instead of like doing this, I'll just do this in this form. Okay, so it is actually the same, but you will understand this better. So xtrain standard. Okay, let me just put it together as well. So fit transform. Okay, so what basically we are doing here is, once we load the standard scalar function, we have to fit this model to the standard scalar, which is named the scalar, and then we have to transform our data. So we are fitting the data to our xtrain, and then we are transforming this data, and we are storing this in xtrain. And we are, based on this scaling, we have to transform our xtest data. So the main thing that you need to remember here is, you should not fit your data to your test data. So that is wrong. You have to fit it to your training data alone. Okay, so we are fitting and transforming the data of the training data, and then we are using the same scalar to transform our x data. So this is how it works. Now I'll run this one. Now you can print this train standard if you want to, and you can just see how this data is looking like. So I'm just printing train standard. Okay, so there is no reason, like there is no requirement to transform train and test, because it is already in the form of 0 and 1. So we don't have to do that on that one, because it is a categorical variable. So I'll just print this train standard. Now all the values will be in the form of similar ranges, so which is what we need. So I'll just remove this one. Now in while training our model, instead of giving this xtrain and ytrain, we will give this xtrain standardized data. So that will give us better results. So I'll run this model is equal to keras.sequential again. So my model will be set up, and I'm compiling my model. And while fitting, instead of using this xtrain, I'm going to use this xtrain standard. Let's see whether there is any change in the accuracy score. So you can see the accuracy starts from 0.22, which is 22 percentage, all the way up to 78 percentage. Now we are training it with the standardized data. Now, so previously the starting accuracy was 22 percentage. Now we are getting the starting accuracy as 44 percentage, and the accuracy increases up to 95.8 percentage. So you can, if you want, you can just increase this epochs, or you can increase the number of neurons, and you can also add another layer to your neural net. So you can just basically play with. So I've just created a simple neural network with one internal layer. So you can basically increase the neurons and increase the layers, but just make sure the model doesn't overfit. So that is a problem which we will discuss later. But yeah, so you can also set this epochs to 20, where the model will go through the data 20 different times. So here again you can see the loss function starts from 0.76, whereas previously it starts from 20. So loss function is basically what is the difference between your true value and your predicted value. So this difference should be minimum. So while training any machine learning model or deep learning model, our goal is to reduce the loss value and increase the accuracy value. So if loss value increases, the accuracy value will decrease. If the loss value decreases, accuracy value will increase. So they are like inversely proportional. So you can see the loss value kind of decreases at each epoch, and the accuracy value increases at each epoch. So this is the validation loss and the validation accuracy. So this is how you can train your neural network model. And the other standard thing that we usually do is visualize how this loss function changes, loss function value changes, and the accuracy value changes. So for that, we will just create some basic plots. So I'll create a text here as visualizing accuracy and loss. Okay, So plt, which is my matplotlib library that we have imported in the first cell. So plt dot plot history dot history. Here I have to mention accuracy. Okay, so my accuracy, and then plt dot history. Let me just copy this. So we will visualize this loss and accuracy, loss accuracy and validation loss and validation accuracy. So I'll put this one. So here I'll just change this to validation accuracy. So I'll just explain you after completing this part of the code, and then we are giving a title to our plot. So let's name this plot as plt.title. Let's name this as model accuracy. Model here is the neural network accuracy. Okay, so model accuracy will be the name of the plot, and plt.y label. So the name of the y-axis will be, again, so let's call this as accuracy, and plt.x label, it will be epochs. Okay, and we are going to set legend for this plot. So plt.legend, and this legend will be train val. So val basically stands for validation, and where do you want this location is lower right. So I'll put this as training data, and this as validation data. Okay, so I hope everything is fine. So history is nothing but, so this is where we have stored all the checkpoints of the model. So history accuracy. So let's run this. You will understand what we are doing here. So what it basically do is, it will take this model's accuracy. So this is the accuracy on the training data. This is the accuracy on the test data. So it will take each of these values and it will try to plot it. Okay, so here we have the epochs number. So this is when the model runs for the first epoch, second epoch, third epoch, fourth epoch, and so on. So totally we had 10 epochs. So like in the first epoch, if you see, the loss value is 0.7. So if you see, sorry, we have to look at the accuracy. So accuracy is 44, almost it's 45% or something like that. For first epochs, it is somewhere here. The accuracy is, accuracy is, I think we have to look here. Okay, so let me just check it for this second one. Okay, second one, the accuracy is 0.78, so it's 78 percentage. 78. So I think it's kind of different. So training and validation. So let me just recheck it. Epochs history. Okay, so the thing is, the first epoch has been numbered as 0, second epoch has been numbered as 1, so 2 and 3. So you will have epochs from 0 to 9, which counts for 10 epochs. Okay, so for the first epoch, so this is represented, this particular epoch is represented as 0, and for this the accuracy is 0.44 percentage, which is 44 percentage. So if you see here, we have the value at this point, which is 44 percentage, and this is basically the third epoch, because like 0, 1 and 2. So for this we have to look at the third epoch is about 89 percentage. So if you see here, the training data accuracy is almost here, which is equal to 89 percentage. So epochs are from 0, 1, 2, 3 and so on. So this is the basic numbering in Python. So just, yeah. Okay, so that is the thing. So blue color line, this blue color curve tells me how my training data accuracy changes. So it changes from 44 percentage to 95 percentage, and this orange colored line tell me what is how is my validation accuracy changes, 0.71, 0.95 and so on. So this is just basically how my accuracy changes. So it starts from very low accuracy of 44 percentage, and it kind of getting, and after a point it kind of reaches a plateau, because like it reaches 91 percentage and 93 percentage in the fifth epoch itself. So in the next 10 epochs it goes to 95 percentage. So the maximum accuracy we have is about 100 percentage, which will be in the form of 1.0. Now this is what we are creating. So when I mentioned this history accuracy, So this value will be taken, and when I mention validation accuracy, this one will be taken. And we are just naming the plot, which is model accuracy, and we are creating the y label as accuracy, x label as epoch. So we are just plotting for epochs and accuracy and legend. So I just wanted to mention that this blue colored curve represents the training done on the training data, and orange color is this validation data, and location. So if you change this location to upper right or upper left, this location will be changed here or here based on your value. So this is the plot we are doing, and we also used to do this for the loss value as well. So I'll just copy this code, so it will remain the same. We just need to change this to loss, and this will be validation loss, and let's name this as yeah, so model loss, and this is loss value. Okay, so training data, test data. So here let me put it on upper right corner, so you will see the change in the location. Yeah, so if you see the first epoch, which is 0, the loss function value is 0.76, right? So if you see here 0, the training data loss function is 0.7, and so on. It kind of decreases, so on. So the accuracy starts from a low point and it increases, and the accuracy kind of decreases, which we are more interested in. Okay, so the final accuracy that we are getting is for training data it's 0.15, and for validation data is 0.12, so which is at this point. Okay, so this is how we will visualize how the loss function and loss function value and accuracy value changes. So this is how we can visualize this, and now we can also do some certain things. So the next, we just have two more works to do. One is to test our neural network on the test data that we have created. So we have done all these things on the training data, but then we have to do this for this test data that we have created, which is this x test, which we have standardized to x test standard. Okay, so after that we'll be building a predictive system. So let me do those as well. So this part of the code will be to get the accuracy value, accuracy of the model on test data. Okay, for this I'm going to create two variables called as loss and accuracy. So there is a function in this keras sequential, this keras model, which is called as evaluate. So model, which is my neural network dot evaluate. Here I have to give my x test data and the corresponding labels. X test standardized. So this is just like predicting the accuracy score of the model, which we used to do for machine learning case. Okay, so what happens here is, so we will feed this x test standardized. So the neural network will predict the label for all this test data, and it will compare it with this y test, which is my true data. Okay, so this is just like the calculating accuracy score. So we don't have to do all those things. We can just use this evaluate function. The model does it by itself. So I just repeat this. So the model will take the standardized x test data, which is my testing data. It will predict the labels, and those labels will be compared with my true labels called as y test, and it will give me two values. One is the loss value, and the another one is the accuracy value. And let me print the accuracy value alone. Print accuracy. Okay. Okay, again I'm making a mistake. Okay, so accuracy. Let's see. So here the loss function value is about 0.16, and the accuracy is 0.938, which basically is 93.8. So we are almost getting a test data accuracy of 94%, which is very high. So if you increase the epochs or if you increase the layers, we probably get some increased accuracy. So you can check that out, but it is not like that much important for us. Now what we are going to do is the most interesting part, which is to build a predictive system based on this neural network. So this is just like, this is slightly different from how we used to do for machine learning model. So there is like few steps that we need to include. So here what I'll do is I'll just print x test standard dot shape, and I'll print the first value of this x test standard. Print x test standard. When I mention 0, this is the first data point in this test data. Okay, so there are 114 test data points, and then we know that there are 30 columns, right? We have printed this here. So 20% of the original data 114 goes to the test data and 30 values. The difference is that this data has been standardized here. So we have 114 data points. and 30 columns, and this is my first data. So see, like this, there are 114 data points are there. Now when I use a predict function in this model, so we are just basically working on classification, right? So I'll create a variable called as ypred, and in this ypred I'm going to use model.predict, model.predict x test standard. So when I run this in machine learning, it will give me either 0 or 1, right? It will predict the class, whether it is, if it is benign, it will give me 1. If it is malignant, it will give me the 0. So I will get those classes alone as 0 or 1. But in this case, it is slightly different. Let's see what we are getting. So I'm going to print ypred shape dot shape. So this will basically calculate, or this will find the label for all the data points. So ypred dot shape and print ypred 0. Okay, so let's see what happens here now. So what we expect is similar to machine learning. If I run this, it will give me either 0 or 1, but it is kind of different here. So it is giving me two values for one data point. Okay, so this is the prediction. For prediction of this x test, sorry, this x test standardized 0 for the first data point, I'm not getting the label value as 0 and 1, but I'm getting some value like this. Let's try to understand what is this. So when you run this predict function, it will give me what is the probability that the label is 0, and this value represents what is the probability that the value is 1. Okay, so in other words, this is the probability of that this particular data point being 0, which is like 0.24, and this is the probability of this data point being 1. So in other terms, we can say that the model is 24% sure that this data point represents malignant data, and but it is 53% sure that this particular data point is benign data. Okay, so the first value represents the probability of label 0, and the second data point represents the label 1. So this is very very important. So it won't give you as either 0 or 1, but it will give you the probability. So we will basically choose, like if the first value is maximum, then that label will be 0. If the second label, like the second value is maximum, we will choose this one as 1. Okay, so let me just print this ypred shape, ypred shape. Or okay, so I'll just print all these things. So print ypred. Okay, so here we will print the x test standard. Okay, so this is the test data, and this is the values predicted by my model, which is stored here. So model.predict x test. So this, I'm just printing my test data, which contain 114 data points. So there are like 114 data points here, and then I am printing my ypred. Let's try to understand this. So this will basically contain 114 different values, and for each value you will have two things. Okay, so we just have to compare the first one and second value. So this is for the first data point, this is for the second data point, and this is for the third data point, and so on. So similarly, we have the two values for each of the data point. So if the first value is maximum, we will tell the label as 0. If the second value is maximum, we will tell the label as 1. So for this one, if you compare, the label value is maximum for this one, so we will tell this is the maximum one. For this is the maximum one, and so on. So this is, instead of giving us labels, it will give us what is the probability that this data point can be 0, and what is the probability that this label can be 1, and so on. Okay, so this is how it works, and we need to convert this to labels. So we don't want this probability value, but we want label values, and for that we will be using np.argmax. So there is a function in numpy library called as argmax, so we'll be using that. So I'll just put this thing here as model.predict gives me, so it gives the prediction probability of each class for that data point. Okay, so if I consider the first data point, for this so this is my first data point, and model tells that this for this four data points there is like 2.4, like 0.24 probability that it will be 0, and 0.53 probability that it will be 1. So it will choose the maximum one. So if the second value is maximum, it will choose as 1. In this case, second value as maximum, so we'll get the label as 1. And another important thing that you need to note here is, it is not that if you add these two things you will get the value as 100. So it is not like that. Okay, so it is not like if you add these two you will get 1. So it is not like that. It is just some, you can think this about some confidence value of the model. So which value is higher, we will take that particular label. So we have to determine this. Okay, so I'll just create a text here as converting the prediction probability to class labels. Okay, so to either 0 or 1, which is like more we can understand that better, right? So I'll create a text here as ypred labels. So we are just converting these values to labels, is equal to np.argmax. So we are going to use a for loop. So np.argmax of I for I in ypred. So let's try to understand how this argmax works. So I'll just create a, so let me just put it here. Okay, so argmax function. So let's try to understand this first and then move on to that part. So I'll create a list as my list. So this list contains the values as 10, 20 and 30. Okay, and I'm going to say, let's say that I want to find the index of the maximum label. So index of maximum value, index of max value is equal to np.argmax of my list, and I'm going to print my list as well as, and I'm going to print the index of maximum value. Now let's see what is the output that we are getting. 2. So we know that the index of 10 is 0, index of 20 is 1, index of 30 is 2, right? So np.argmax will try to find what is the index of the maximum value. So in this, the maximum value is 30, and the index of this maximum value is 2, right? So that's why we have the 0, 1, 2. The maximum value is present in 30. If we say that I have 30 here, 10 year and 20 year, now the argmax value should give me the value as 0, right? Let's see. So it is giving me the value as 0. So this is how this works. So if I say that in my list the values are 0.56 and there is another value as 0.25, so it should give me this particular value as 0, right? Let's run this. So it has given me the value as 0. So let me just reach, just put this here. So yeah, okay, I'll put this here. Now you can see. So this is how this basically works. So we will take each of these list and we will try to find whether the first value is maximum or the second value is maximum. If the first value is maximum, I want to give the label as 0. If the second value is maximum, I want to give the label as 1. So this is just very simple, very basic. So that is what we are doing here. So I'm creating this ypred list. So here we have just done this for one single list, whereas in this we are going to create a for loop where this for loop will iterate over all these lists. Okay, so each of this represents one test data point. So totally we have 114 data points. So all these values will be converted into 0 or 1 depending on which value is maximum. So that's why we have this for I in ypred. So when this for loop runs for the first time, it will take the first value and it will apply this argmax to determine which value is maximum. For the second time the for loop runs, it will take this value and the argmax will be run and so on. So this is what is done, and all these labels will be stored in this list called as ypred labels, because you can see we are creating this square brackets which basically represents my list, and after this I'll print my ypred labels. Ypred labels is what we are creating here. Okay, so let's run this. So this is the value we are getting. So if you just print this, so if you just compare this ypred and ypred labels for the first value, the for this first data point, the second value is maximum, right? So the label should be 1. You can check this one. So label is 1. Again, so 1 means second value is maximum, second value maximum, 0 means first value is maximum, and so on. So this is how we can convert this probability, prediction probability, to class labels. And in machine learning, our model directly give this kind of values, because we have classification from model separately. But in neural networks we can do this one in order to convert our labels. So this is why the prediction, building the predictive system changes, because we have to incorporate this as well. So this part will be building the predictive system. Okay, building the predictive system. And for this we have to create the input data. Input data is equal to some tuple. So in this we need to give the feature values. So these 30 values, if you give this 30 values, we will get some result. And next thing is we have to change this to numpy array, so that we can reshape this array and so on. So input data, so I have to include an underscore here. Input data. Next step is change the input data, which is form of the tuple. So you can also create this as a list, so that is not a problem. So we have to change the input data to a numpy array. Okay, and input data as numpy array is equal to np.asArray. np.asArray. Okay, so as array input data. Okay, so this will change this tuple, which is in this brackets, to a numpy array. And after this we have to reshape the array. So reshape the numpy array as we are predicting for one data point. Okay, so the reason is, while training our model we have fed it with almost 500 data points, but we have to tell that model I'm just predicting the label for only one data point. So that's why we have to reshape this data point. So it will be given as input data. So let's create this name as input data reshaped is equal to, mention this array which we have converted, dot reshape function. So reshape, we have to mention 1 comma minus 1. Okay, so this is the reshape that we do in order to tell the model that I'm predicting the label for only one data point. And after that we have to standardize the data. So don't forget that here we have, before training the model, before training our neural network, we have standardized the data using the standard scalar function, right? So using the same scalar which we have fitted with our xtrain, we have to transform this data. Okay, so once we transform this data, input data reshaped, input data reshape, and standardizing the data, standardizing the input data. So I'll call this as input data. So if you do this without standardizing the data, it won't work. Okay, so this is like very important, and this order is also important. First you have to convert it to numpy array. After that you have to reshape it. After that only you have to standardize it. So if you apply the standard scalar before this reshaping, it won't work. So scalar dot transform, here you should not fit it, you have to transform it, because like we have to fit it only with the training data. So scalar dot transform input data standard, scalar dot transform input data reshape. Okay, and finally prediction. Prediction is equal to model dot predict. So please remember that this predict will give us a prediction probability and not classes as either 0 or 1. So model dot predict input data standard. So I'm putting it here, and then Let's also print this one to see print prediction, and finally prediction label. So this is in the form of a probability value. So we have to again apply this np.argmax in order to convert this probability value into class as either 0 or 1. So I'll create this as a list called np.argmax, argmax of prediction. Okay, so it is the same step that we are doing. So in this case we have done this for all the data points, but we are just doing this for only one data point. So that's why we are not including this for loop. And I'll print this as well. So let's print this prediction label as well. Okay, so that is done. So that is all we need, and then we can just include a simple if loop that we used to do. So if this prediction label, so if prediction label 0, which means the first element, so it will be basically in the form of list. So if this element is equal to 0, in that case we have to say that the breast cancer is, we can say that the tumor is malignant, whereas else means the label will be 1. So we know that 1 means it is it is benign, right? So print the tumor is benign. Okay, so we are using the trained neural network in order to, we are doing this if you want to predict the value for a new data point. Okay, so if the label is 0, then it will say that that particular tumor is malignant. If the label is 1, it will tell that it is benign. So there is like nothing to worry and so on. Okay, so now we have to put some value to this input data, and we have to predict whether it is benign or malignant. So I just take one data. Okay, so let me go to the CSV file that I have. So this is the data that is downloaded from the Kaggle. So it is the same breast cancer data set. I'll open this with Notepad. Okay, so you can see, so M means it is a malignant data point, and you can see B. So B means a benign data point. So I'm going to copy one malignant value. So if I put this, the model should say that it is a malignant tumor. So I'll copy this. Let's put that there. So this should be pasted in input data. So it should tell that it is a malignant tumor. Okay. So let's run this and see whether our model is predicting correctly. Okay, so it is saying that the tumor is malignant. So now you can see, so this prediction, so this is nothing but the prediction that we have printed here. So it is saying that it has two values, which is 0.67 and another one is 0.16. So if the first value is maximum, we have to say that the label is 0, right? So hence why it is given 0. So this 0 is derived from this np.argmax. Okay, and as the label is 0, it will say that it is malignant. And now let's do the same for benign cases. So I'll go and randomly copy some value. So this is a benign case. You can see the B here. So I'll copy this data point, which is the 30 values. And let me put, now it has to say that the label is 1. The second value is maximum. It should say the tumor is benign, right? So I'll put this here. And let's run this. Now you can see the second value is maximum 98 and the first value is minimum, which is 42, and we are getting the label as 1 and the tumor is benign. So this is how you can build a predictive system using this neural network. So the only difference is that you have to use this np.argmax and you have to scale this before scale this after reshaping. So I hope everything is clear now. I'll just give you a quick recap of what we have done so that you just get the whole idea. So we are just importing the necessary dependencies that we need. So the libraries like NumPy, Pandas, sklearn, etc. So matplotlib for plotting the loss function, the accuracy function, and we are loading the data from this sklearn.datasets. So after that, we are creating a data frame where we are adding all the data from this dictionary, which like in this dictionary called as breast cancer dataset, and in that we are getting this data alone, which is the feature values. After that, we are adding the target column and we are naming the target column as label. Okay, so now if you see the last, there is a last column added called as label, which is my target column, and you can print the shape, which is 569 rows and 31 columns, and then we are checking the info as whether there are any missing values, there are any null values, and so on. And after that, we are just printing this description. So these are just data analysis part. We are checking the distribution of the classes, how many 1 values are there, how many 0 values are there. and then we are grouping the data points based on their labels. Next is separating the data into features and target to this X and Y. After that, we have splitted our data into training data and test data using this train test split. So 80% of the data, which is 455, goes to my X train, and 20% 114 goes to my X test. After that, we are using the standard scaler. So this is like very, very important in deep learning. So we have seen that if you don't standardize your data, you will get less accuracy, and if you standardize your data, you will get better and higher accuracy. So that's the idea. And here we are building a very simple neural network. So there is like a lot of things that we have to explore, and I will do that in, while taking the deep learning course. You can also do some research on this. So we are importing this tensor flow, and we are setting the seed so that we get constant results every time we train our neural network. So model, we are using this keras.sequential, where we are stacking all the layers. So we have flattened layer in order to convert all the data, which is in the form of a matrix, to a single dimensional array. And after that, we are creating an intent layer and output layer with two neurons. You can try this with different, so you can just give the activation as sigmoid for both the things, or you can give activation as reduce, so you can just interchange. You can do some explorations on that part, and also check what are all the different activation functions are there. So you will find all these details in keras documentation. Just search as keras activation function or keras optimizer loss and so on. So we have Adam optimizer. Since we have the labels as 0 and 1, we have used a sparse categorical cross entropy. If we have one not encoded labels, in that case we have to use categorical cross entropy. And the metrics, so as we are choosing the metrics here, we are getting the accuracy. So we are getting the accuracy here. So if you choose different metrics, you will get different accuracy here and so on. So here we are creating a variable called as history, so that it saves all the checkpoints of the training. So we are using this fit function to train our standardized training data with, along with the labels, and we are setting up the validation split. So how many validation data points are there, and setting the epochs, how many times the data has to the model has to go through the data. And you can see, so at each epoch the loss is decreasing and the accuracy is increasing, which is what we need. And then we are visualizing how the accuracy and loss changes. So we have epoch 0 to 9. So 0 means the first epoch, 9 means the 10th epoch, and so on. Again, we are seeing the loss function value. So the accuracy starts from a low point and it reaches a higher value, and loss function starts from a larger value and reaches a small value. And then we are finding the accuracy on the test data as 90, almost 94%. And the main thing is, we can see that when we use this predict function, instead of giving us the labels, it will give us the prediction probability, and we have to use this np dot argmax in order to find which is the maximum value, and we are just converting it to list. And after that, the important thing is building this predictive system, where we have to take the value, we have to reshape it. After that, so first is taking the input data, converting it to numpy array, and after that reshaping this numpy array, then we have to standardize this data, and then predicting whether that particular uh, the predict value, which is my probability. And in that, we have to use the np.argmax function and find the label. Here we are getting the label as 1, and finally we can say that if this label is 0, we have to print it as malignant. If the label is 1, we have to print as malignant. So that is what we have done. So this is a very, very simple neural network. So there is a lot of things that we can do with this. So what you can do is, so try adding the layers. And you can also see there is a chance that this model will overfit. Overfit is the thing when your training data accuracy is high, like 95%, but your test data accuracy will be low, like 50% or 60%, and that is what is called as overfitting. So if you add more number of layers, there is a chance that your neural network may overfit. So you can explore that part, and you can also explore what are all the different optimizers and loss functions that you have. So these are all the two things that you can explore. I just wanted you to explore, and in the upcoming videos, I'll post a video on how image processing works in deep learning. So how we are converting this image to numerical value. So that I'll create a separate video, and after that we will work on few image data sets, so image recognition problems using deep learning. And after that, I'll just continue with the machine learning videos. The machine learning course videos are there, and once in a while I'll upload deep learning projects like this. I hope you have understand this particular video. So like, watching this video is not enough. Please try to write all these code by yourself. At least just keep this code aside, just try to write all this code by yourself. So then only you will get a clear idea, and you can just use this as a template, and you can work on different numerical projects. And so in our channel itself, I have worked on several classification problems with numerical data. So for those data sets, you can apply this neural network and see what is the result you are getting. So that will be a good exercise. So please practice all the codes. So just watching the video won't help. Okay. So I hope everyone is happy with this video, and that's help of neural networks. And in that video, we have seen how we can train our neural networks with numerical data. And in the upcoming videos, we will discuss how we can work on image recognition tasks with neural networks, where we will train our neural networks with image data. So in image recognition, we cannot feed this image data directly to our neural network. So there are a lot of processing that we have to do on these images. So processing, in the sense, what we will do is we will convert these images into numerical values. So the neural networks and machine learning models cannot understand images. So we have to convert them into meaningful values and meaningful numbers. So that is what happens in image processing part. And this is a complete conceptual video where I will explain you what is the thing that is happening in this image processing. So once we understand these concepts, the next video will be on how we can implement all these things in Python. So once we get a clear understanding of these two things, the conceptual understanding and the hands-on part, we can move on to a few deep learning projects where we can train our neural networks with image data. Okay, so in today's video, let's focus mainly on how this image processing takes place. Okay, so let's get started. And the first thing that we have to understand is the image dimensions. Let's say that there is this image. So we have a dog image, and we can represent this dimension of this particular image as width and height. Okay, so this particular image has some particular width and some height. So this will be my image dimension, and I can represent this image dimension as width into height. Okay, so let's say that this image has a dimension of 200 into 200. So you can just check some images that you have in your laptop or your phone. Just go to the properties and see. So you will find this thing as 200 into 200 or 300 into 300. So this depends on what is the size of your image and what is the dimension of your image. Okay, so this basically means is like your width is 200 and your height is 200. So these values can be anything. Now we have to understand what is, what does this 200 represents. So these 200 into 200 represent the pixels of this image. So you can split these images into different boxes. So this is how you can split this image. So consider that. So let's take this particular first grid. So let's take this first column, and let's take this first row. Okay, so consider this image as a matrix that has different number of cells or different number of squares in rows and columns. Okay, so we have multiple rows and multiple columns are there. So consider that there are 200 boxes in the first row and 200 boxes in the first column. So in that case, you can represent this image as 200 into 200 image. So in this case, if you count, that will be like 15 or 13 images, but assume that there are like 200 boxes. So this is how you can represent the dimension of a image. So 200 means like, so the first 200 represents the width. So that means like you can split this image into 200 different boxes in the horizontal axis, and the second value means you can split it again into 200 boxes in the vertical axis, and each box represents my pixels. Okay, so if we want to find how many total boxes are there, so that will be the count of the total number of pixels that we have. So in this case, the total number of pixels is 40,000. So this is nothing but 200 into 200. So when you multiply these two numbers, you will get 40,000, because like this first 200 represents only the first row, and the second number represents the number of boxes in the first column. So this is for only this particular column and this row. So let me just show you. So consider that there are like 200 small boxes are there, and this is represented by this particular value called as 200. And so this second value represents, so there are like 200 boxes in this vertical column. So if you want to find how many total boxes are there, you need to multiply these two, and when you multiply 200 into 200, you will get this 40,000. So this represents the number of pixels that you have in your image, and this is what like pixel means. So if we talk about a 720p image, so that will contain more number of pixels. So as the number of pixel increases, the resolution of your image increases, and your image will look more clear. So that is the idea behind this image dimension and this pixel. So image dimension is nothing but how we can represent this image in terms of its dimensions, where we will use this width and height. Okay, so now let's try to understand what are all the different resolutions that we have. So like if it is for 480p resolution, so we all would have known this from YouTube. So we select the resolution of the video as either 480p or 720p or 1080p and so on. So 480p means your dimensions will be 720 into 480. As I've told you, 720 is your width, and the second number 480 is your height. Okay, so this is the dimension for this 480p, whereas in the previous case we have seen just a 200 into 200 image, and this is the dimension for a 480 image, 480p image resolution image, and this is the resolution for your 720p and so on. So like this is like corresponds to the TV resolutions that we have. So we may have like a 720p HD monitor, or a TV, or a 1080p HD TV, and 4K and so on. Okay, so the total number of pixels, so if you want to calculate it, you want to multiply these two values. So the first value represents your width, a number of pixels in your width, and second number represents your height. So 720 into 480 gives 3,45,600, and this is for 720p resolution. We have these many pixels, and for 1080p this is the number, and so on. So this is how you can understand the image dimension and image resolution. As you have more and more pixels, the image will be you will get more defined image. The image will be more clear. So the previous case, it was a 200 into 200. So you have the total number of small boxes that you have is 40,000. And if you consider the 720p image, 720p resolution, you will have 921,000 921, like, or I can say this as 9,21,600 small boxes are there, which is basically my total pixels. Okay, now just try to understand this image dimension. Now we are going to understand about another factor when it comes to images. So we have two types of images. One is grayscale image, and the other type is RGB image. Okay, so grayscale images are nothing but black and white images, where you like the two colors that are present in the images are only like black and white. Okay, whereas RGB image means a colored image. So we call this grayscale image as one channel. So these images have only one channel, whereas RGB images have three channels. So these three channels are nothing but red, green, and blue. Okay, so here we have one channel. So one channel represents only white and black, and these three channels that we have are red, green, and blue. Hence we have the name RGB images. So these are all the two types of images that we have. And so this is like very important when we are working with image data. Sometimes we can train our neural network with this grayscale images, or we can train it with RGB images. So when it is RGB image, the size of the image is kind of larger. The data that is stored in this image is larger because we have different colors. But in the case of grayscale images, as the number of colors is only two, we have white and black. So the number of data that we have, or in other words, the size of the image is pretty low for a grayscale image compared to a RGB image. So what we basically do is, in some cases we will convert this RGB image or colored images into grayscale images, so that it is easier for our neural network model to work on, so that the training can happen in a shorter span of time. Whereas if you take a RGB image, as there is like more information in this, like information in the sense like there are several colors, so the size of the image is obviously going to be larger. So we will convert this RGB into grayscale in some cases, and we will train our model. So that is the difference between this grayscale image and RGB image. Now let's try to understand so how this grayscale image will be converted into numerical values, and after that we will understand how this RGB images will be converted into numerical values. Okay, so and again, so why we have these three colors is that, so these three colors are called as the primary colors. Red, green, and blue are primary colors, and all the other colors are the combination of these three colors. So you can get any colors if you combine these three colors in different proportion. So I'll explain you how this comes in the later slides of this particular PPT. But for now, understand that if you combine these three colors, you can get any colors based on different proportions of red or green or blue. Now let's try to understand how we are going to process grayscale images first. So we have an image, and we have this particular image as a dimension of 200 into 200. That means like the total number of pixels we have is 40,000. So we have discussed about this, right? So 40,000 means like we can split this image into 40,000 small boxes. Like in this case, if you count, you won't get 40,000. Of course, I've just shown this as a representation, but assume that you can split this images into 40,000 different boxes, where we have 200 in the x-axis and 200 in the y-axis. Now we can represent each box with some numerical value. Let's say that we are converting this image into some matrix. So we have different values here, and the shape of this matrix is 200 into 200. So the first value here is 0. So this corresponds to the first box. The second value 20 corresponds to the second box, and so on. So we have a matrix which is the same shape as this image. So if this is a 200 into 200 image, you will have a matrix that has 200 rows and 200 columns. So this is the shape of the matrix, where the first value represents the total number of rows you have, and second value represents the total number of columns you have. Okay, so we have these many values are there. So totally we will be having 40,000 values in this particular matrix. Now what this value represents, so all these numbers lie in the range between 0 and 255. Okay, where 0 represents black color, and if the color of that particular box is white, that is represented as 255. Okay, so understand this thing. 0 means black, so 0 means black, and 255 means a complete white. Okay, so like all the different values corresponds to different shades of this black and white. So let's say that the value is 10, that means like the color is black, but it is it's not like that, it's not like completely dark, it is not completely black. And so we have different shades of white and black in this range of 0 and 255, where 0 means it's like completely black, and 250 means it's like completely white. So you can represent all these colors with these values, where this 0 and 255 represents the what is the color intensity of white and black. So if we say the properties of grayscale images, we can say that all pixel value lies between 0 and 255, and 0 means black and 255 means white. So this value represents what is the white color intensity. So 255 is the maximum intensity of white color. So if you have 255 in one particular box, that means like that box has a complete white color in it, and if a box has a black color, that will be represented as 0. So what we are basically doing here is we are splitting each pixel, and we are giving some value to this particular pixel. So this value is nothing but what is the intensity of white color. So if the intensity of the white color is 0, that means it is a black color. If the intensity is 255, that means like it is white in color. So all the values are ranges between 0 and 255. So this is how you can convert this grayscale image into numerical value. So this image now has been converted to a matrix that has only numerical values, and this is the data that we will feed to our new neural network. Okay, so we are not doing anything, we are just finding how many pixels are there, and for each pixel, for pixel means small boxes that we have in our image, and for each box we are giving what is the white color intensity, where 255 means the highest intensity of white, which is basically white color, and 0 is the darkest one, which corresponds to black color. So this is how grayscale images are processed. Now, so there is another interesting thing on how RGB images are processed. Okay, so now we have a colored image. So this represents a colored image of a dog. Let's say that this image also has a dimension of 200 into 200. That means the total number of pixels is 40,000, right? So we have different pixels here. So totally we have 40,000 small boxes here, and in each box we have a specific color. Okay, and the grayscale image has been represented by one matrix that has 200 rows and 200 columns of values. Now how this colored image will be represented is, it will be represented in three matrices. So the first matrix will be what is the red color intensity of each box, and the second matrix will be what is the green color intensity of each box or each pixel, and the third matrix will be what is the blue color intensity. So we get the name RGB image. So as I've told you, any color can be represented using the combination of this red, green, and blue. Okay, so that's why we have this RGB image. So let's look at this first box. So this first box corresponds to the first value in this red matrix, the first value in the green matrix, and the first value in this blue matrix. So it is not like this color corresponds to 000. So I have just randomly come up with this number, but you will get some other different values. So just understand that. So if this is a 200 into 200 image, so all these matrices will have the same shape, because we are just converting this image into numerical values, where we are just stacking different matrices. So this image can be split into three channels. So hence This is the reason we have three channels in the case of RGB, whereas in the case of grayscale we have only one channel, because the main color that we are focusing on white. We are just finding what is the white color intensity. In the case of this RGB image, we have red color intensity and green color intensity and blue color intensity. If the just consider this first box. Okay, so let's say that in this first box red color is predominant. In that case, the red color intensity value will be maximum and green and blue intensity will be low. So the value will be low for this green matrix box and this blue matrix box only for this first value, if the first box is predominantly red in color. Okay, so all the values corresponds to each boxes. So if you take the first box, that value is represented by the first value in this red matrix, first value in the green matrix, and the first value in this blue matrix. If you take this last box or last pixel, this corresponds to the last value that is present in this red matrix, last value in this green, and last value in this blue matrix. So we are combining this red intensity, green intensity, and blue intensity. So when it is a RGB image, instead of having one matrix, we have three matrices, which is opposite to the grayscale image, where previously we have only like one matrix, because this corresponds to what is the white color intensity, and in this case we have three colors, so we have three colored intensity. So this is how RGB images, or in other words colored images, are converted into numerical values. So once we make this conversion, we can feed this data directly to our neural network model, and now we can understand what is that particular image and how this image looks like, and so on. So we will come to the training part later, but try to understand, like, the main thing that we have to understand here is like how we are converting this image to numerical data. So we are taking each pixel and we are finding what is the red, green, and blue intensity separately, and that contributes to my colored image. Okay, so if you see an image, so this is how it will look like. Let's say that we have an image of 4 into 4 pixels, so that is what is represented as 4 units and 4 bits. So this image has been taken from the Stewart's data site. So let's say that it is a 4 into 4 image, which basically, like, contains totally 4 into 4 16 pixels. So if you count this matrix, there will be like 16 matrices. And so if you consider this first box, uh, the first pixel of that image has a red intensity of 35 and green intensity of 9 and blue intensity of 4. If you consider the second box in this image, so so the red intensity is 19, green intensity is 7, and blue intensity is 6, and so on. And another main thing is, here also the values ranges between 0 and 255. Okay, so like if the value is 0 in this red color intensity, that means like there is no shade of red is there. If the value is 255, that particular pixel has only red color, so it is like completely red, and so on. So it is like similar to the intensity that we have in this grayscale. So as we know that here the value ranges from 0 to 255, where 255 being white and 0 being black. Here if the value is 255 for red, that means like that particular pixel is red in color. 0 means that pixel is doesn't have any red shades. So that is the idea, and this is how an image can be converted into three matrices, where each matrix corresponds to the red intensity, green intensity, and blue intensity. So this is why we call these images as three channeled images, where there are three colored channels. So the one channel is red, the other channel is green, and the other channel is blue. So we have this RGB images. And as I've told you, you can get different combinations of colors using these three colors. So we have red, green, and blue, which constitutes our primary colors. And if you combine this red and green, you will get yellow. If you combine this blue and green, you will get this cyan, and so on. If you combine blue and red, you will get magenta. If you combine all these colors in equal proportion, you will get white color. So when it will be white color is like when the red intensity, green intensity, and blue intensity, all the things are 255, you will get white color. Okay, so similarly you will get any colors by just combining different proportion of this red, blue, and green, and so on, where this proportion is represented by the value 0 to 255. So 255 means that particular color is in high proportion. 0 means that no shades of that particular color is there. So you can find some sites in Google where you can give different values for this RGB, and it will show you what is that particular color. So I suggest that you can go through that and see how this thing works. Okay, so this is how we will convert the image data into numerical values, where we are just basically taking the pixels. And in the case of grayscale images, we have only one channel, so which corresponds to the white intensity values, where the values ranges from 0 to 255. Whereas in the case of colored images, what we technically call this as RGB images. We have three matrices or three channels, and each matrix corresponds to each color intensity, where the first channel corresponds to red intensity, second channel corresponds to green intensity, and the third channel is for blue intensity as shown here. Okay, so once we have this numerical data, we can feed this to a neural network model, and it can understand like what are all the similar images, and it can make further predictions. Okay, so the next video will be on Python, where we will try to implement this, where we will try to take an image. We will take both a grayscale image and RGB image, and we will try to see how all these things comes together in Python. Okay, so once we understand that, the next video will be on dog versus cat classification using neural network, where we will train our neural network with several images of dogs and cats, and our neural network can determine, like, if you give a new image, it will tell you whether that image represents a dog or cat. Okay, so this is the next set of videos that we will be discussing, and I hope that you have understood what we have completed in today's video: deep learning applications and how to do this in Python. In the previous video, we have seen that before training a neural network with image data, we have to convert this image data to numerical values. And there are two types of images. One is RGB image, which is a colored image, and there are also grayscale images, which is similar to black and white images, and so on. So we have discussed in detail about this, and we have also seen what is meant by a pixel, and what does a dimension of an image represents, and so on. So based on that understanding of image processing, we will implement all those things in Python. Okay, so this is an hands-on video where we will completely discuss about what are all the different processings that we have to do on an image before feeding it to our neural network. Okay, so the three main important image processing tasks that we will discuss are how to read an image file and how to convert it to a numpy array. So this is the first thing, and then we will discuss how we can resize an image. So this is like very important, because let's say that there are 10,000 images in your data set, and let's say that each image is in different dimensions. So it can be like a 200 into 200 image, or it can be like a 720 into 1900 image, and so on. So you cannot feed those images to your neural network, because a neural network expects all the data to be in the same shape. Okay, so in other words, all the images should be in the same dimensions. So we will discuss how we can carry out this resizing process on an image, and then we will discuss how we can convert this RGB images to grayscale images, and I'll also explain you what is the significance of this, and so on. So if you haven't watched the previous video, I have given the link in this collab file, and you will find the link for the previous video in this video description as well. So please watch that video before going through this one, because in that case only you can understand all these things completely. Okay, so let's get started with the coding part. So first, let's discuss about this RGB images, colored images. Okay, so the first thing, as I've told you, will be how to read an image file and how we can convert it to a numpy array. Okay, so first, what I'm going to do is, so I have searched this puppy images in Google. So I'm going to take this image, and I'm going to process this image. So I will read this image, convert it to numbers. So in other words, I will create an array which is basically a different list of numbers, and so on. So this image will be converted to that particular number array, and then we will try to resize an image, and then we can convert this image to a grayscale image. So these are all the three things that we will discuss. So you can search any images. It's not that you have to search dog image and so on. So you can search any images. So just go to this image and right click it. You will find an option called as copy image address. Okay, so I'm copying this image address, and now I'm going to use the command called as wget. So this wget stands for web get, and you can get any files from the web using this command. Okay, so you have to include an exclamatory mark here. So we have seen this while we are discussing about the basics of Google Collaboratory and so on. So this is a very useful command. So in this code, I have to give the link of the file that I wanted to download. So this will directly download the file to this particular collab environment. So this is the link of that particular file. So let's run this. Okay, so once this is completed, so you can see here this particular image has been downloaded, and this image is stored here. Okay, so you can see, so puppy care guide for new parents. So I'll click this. You can see this dog image. So you can just scroll it to see that particular dog. So this is a pretty large image. So let's just close this, and I'll rename this image to let's name this as dog. Okay, so dog.jpg. So it is a normal image. So now I'll just also mention here that, so we are getting an image using webget command. So this will be useful for you in many cases. So if you have the link and if you have the access for that particular file, you can use this webget command in order to get this particular file. And now let's try to read this image and convert it to a numpy array. And for this image processing, we will come across different libraries in deep learning. Okay, so I'll mention the most important ones. So libraries that can be used for image processing. Okay. So the three libraries that we will be using are, so these are all the widely used ones. So first one is matplotlib dot image. Okay, so we have seen this matplotlib image several times, so we know that matplotlib is used to create graphs and plots and so on. So this matplotlib library has a separate module called as image, and there are like several functions and commands that we can use in order to process this image, read this image, display the image, and so on. And the another important library is pillow. So pillow is another important library which is widely used for this image processing tasks. And the other library is OpenCV. So CV stands for computer vision, and we will often call this with CV2. Okay, so these libraries are already pre-installed in Google Colab. So if you are working in Spider or PyCharm or VS Code, you can install that library using Anaconda or pip install. So you can install these libraries through that method. So in this case, all these libraries are pre-installed in Colab, so we can directly import them and use these libraries. Okay, so I'm going to import this matplotlib.image library. So importing the image module from matplotlib library. Okay, so import matplotlib.image as MP img. Okay, so MP stands for matplotlib and img stands for image. So this is how we can import this. So this is the common convention that we use. So you can use any convention, but this is the most widely used one, so just go with it. And let's also import this matplotlib.pyplot as PLT. Okay, so this we know. So we use this PLT, so which is the pyplot module of this matplotlib library to in order to make plots and graphs and so on. So this is very helpful for us in order to display the image that we have. So I'll run this one. So we are importing these two modules from this matplotlib library, and now I'm going to load this image using this matplotlib library. So this part will be loading an image to matplotlib.image module. Okay, so I'll just mention a comment here. So dot image module. Okay, so let's create a variable called as image, so img, and mention the module name, which is mpimg. So we have imported in a short form here, so mpimg.imread. So this module has a function called as imread, and this is used in order to read the images that we have. Okay, so im basically means image, and we are going to read this, and within this parenthesis you need to mention the path of the file that you are going to read. So in case, again, if you are working in PyCharm or Spider, you have to give the location of where that particular file has been stored in your computer. Okay, so I'm going to go to this doc.jpg that we got using this wget command. I'm going to copy this path and let's put it here. Okay, so now what happens is this image will be read and it will be stored in this variable called as img. Now I'm going to check how this image has been loaded. Okay, so type. So this type is a keyword in Python, and it will tell you what is the data type of that particular variable or particular data and so on. Okay, so type of image. So this img is nothing but the image that we are loading. So let's run this and see. So it is, and so this doc.jpg is an image file, and now it has been loaded and converted to a numpy array, so numpy n dimensional array. And you can also check what is the shape of this image. So image dot shape will give you the image shape, or you can also include print. So print image shape, so it will tell you so the dimension of the image. So this one, so this first value and the second value represents the dimension, and the third value represents the color channel. Okay, so this is basically a colored image. So we have the value as 3. So as I've told you in the previous video, we have discussed that there are like two types of images. One type is a grayscale image where there is like one color channel, and there are RGB images where we have three color channels, so red, green, and blue. So we have seen there, and so this image has a particular dimension. So if you consider any image, so there is a particular height and there is a width to this image, and this can be represented as 200 into 200 or 300 into 500 and so on. So in this case, the image dimension is 1365 into 2048. So this is nothing but this particular image. So this particular dog image can be split into small boxes of this many counts. Okay, so in this case, if you consider a 200 into 200 image, so there will be like 200 boxes here and 200 boxes in this horizontal axis and the vertical axis. So if you wanted to count the total number of boxes that you have, you need to multiply these two values, and that one represents your pixels. Okay, for a 200 into 200 image, you will be having 40,000 small boxes, and this particular box represents your pixel. Okay, so that is what we call as pixel. And if you want to count the total number of pixels that you have in this particular image, you have to multiply these two values, so that would be your total pixel count. So what this means is, like, for a grayscale image, each box represents what is the white color intensity, and the values range from 0 to 255, 255 being complete white color and 0 being like a black color, and the middle values represents different shades of this white and so on. But if we consider a colored image like this, we have three such matrices, whereas in the case of grayscale images, we just have one matrix which gives us the color intensity of white color, whereas in this case we have three matrices, and the first matrix will tell you what is the red color intensity of each of this box and what is the green color intensity, and third matrix is what is the blue color intensity, and so on. So when all these values combine, we get this particular image, because all the colors are originating from these three colors. Okay, so red, green, and blue. So we call these colors as primary colors, and so on. So this we have discussed, and as we have seen that the difference between this grayscale and RGB is that we have three channels, red, green, and blue, and that's why we have this value as 3. So you can consider this particular image or this particular numpy array as three matrices, and each matrices is in the shape of 1365 into 2048. Okay, and now we don't know which is the height and which is the width, right? So we can also display this image from this numpy array. So I'll show you how this numpy array looks like. So we have taken this dog.jpg, which kind of looks like this, and I'll just print this img now. So print img. Okay, so let's see what is the values are looking like. So this is the numpy array that we have, and so you can see all the values are between 0 and 255. As I told you, 0 means black and 255 means white, so all the values are between that range. So this is how the image has been stored and converted to a numpy array, and this particular thing is very important. So once we have this image data, we have to convert this to this particular format. Okay, a numpy array. And there is also another interesting thing that we can do with it. So it's not like you can only convert image to numpy array. You can also convert this numpy array to an image. Okay, so you can get all these numbers and you can see what does all these numbers means. So the importance of this is, like, in some cases the data set that you have will already be processed. So let's say that we have 10,000 dog images, and someone would have already processed this and would have already converted those images to numpy arrays. So now what you can do is you can convert this numpy arrays into an image. So that is a very important task. I'll show you how we can do this reverse step. So we have seen like how we can convert this image JPG file to a numpy array. Now we can see how we can convert this numpy array to an image. Okay, so this step will be, so all these things are very basic, but all this will be like very useful for you in image recognition and computer vision tasks. So please practice all these things, and these are like very simple. So now we are going to display, so displaying the image from numpy array. Okay, so this numpy array has been stored in the variable called as img, right? Now I'm going to create another array called as, or another variable called as image plot. So this plot is equal to plt.show. So we have already seen this plt.show while building this plots and graphs and so on. So it's the same function. Sorry, so we have to use this plt.imshow. So imshow means, so we have to show the image that we have, and within this parenthesis mention img. So img is nothing but the numpy representation of that particular image. And now use plt.show. So this numpy array will be converted into an image and it will be plotted. Now we can see that particular image. Okay, so now we can see this image. So all this numpy arrays has been converted to an image. So it is just a reverse step. Now you can see this y-axis and x-axis. So this won't be present in the original image. So this is just, you can consider this as the x-axis values and the y-axis values. So this is nothing but the pixel numbers and so on. So in this y-axis we have values larger than like 1200. In the x-axis we have like more than 2000. So if you come to this image dot shape, we have that 1365 as value. So this 1365 is nothing but the total number of pixels we have in this y-axis, and the second value is 2048. So 2048 represents this many numbers. Okay, so if you want to count the total number of boxes or total number of pixels, you need to multiply these two images. So we can say that this 2300 or something represents my width, and this value which is like 1350 represents my height. So if I go to this image, so this first value represents the height of the image, and this 2048 represents the width of this image, and this is like very important for us to understand. Okay, so this is how you can take an image and you can convert it to a numpy array, and if you want you can also convert this numpy array to a image back. So this is like a very important thing. And now, so we have seen so we can read this image file and convert it to numpy array. So it's not like you have this matplotlib.image library alone, so it's not like that. So you can also use this pillow library. So there are functions in this pillow library as well as OpenCV library in order to read the images and store it as numpy arrays. Okay, so the next thing that we will be discussing is how we can resize this image. Again, this is like a very important step, because before feeding your data set to your neural network, so let's say that we have 50,000 images. All these images should be in the same shape, so then only our neural network can go through the images correctly and it can understand it. So if the images are in different dimensions, it kind of get confused. So that's the basic idea. So we have to resize all the images in a common dimension. Okay, and the other thing is, here we are just considering one images, right? So we are just taking one image and we are converting to numpy array, and here also we will take this particular, so this same image, and we will resize it. But when we are working in a deep learning project or a deep learning use case, so you will have a folder, and this particular folder will have 10,000 or 20,000 or 30,000 images. So you have to do this processing in all the images. So I am showing this for only one image, but we can do this for like all the images in a particular folder. So we will discuss this while we are working on some deep learning use cases, but for now understand how we can do this for one single file. So this next part of the code will be how to resize the images. So I'll just make a text here as resizing the image using pillow library. So before we have used matplotlib.image, now we are going to use pillow. Okay, so pillow library again. So there are also functions in OpenCV as well as pillow to resize the images. Here I'll show you how you can do that in pillow. So from pill import image. Okay, so this is how okay, one second. So import image. Okay, so this is the name of the pillow library, PIL. So, and all the things will be in caps, and there is a module within this pillow called as image. So this image is the module that we are going to use. This I should be in caps. That is like very important. So I'll run this. We are importing this pillow library and this image module, and I'll create another variable. So I'll just name this as same img, which stands for image, and now we can mention image dot open. Okay, sorry, so this should be a small o, so image dot open. So this image is nothing but the module that we have imported here. Okay, so image dot open, and within this we need to mention the path of the file that we have, this dog.jpg file. So I'll copy this and I'll paste it here. So let's see, and once this image has been opened, so what you can do is image is equal to, or I'll name this as image resized. So image resized is equal to img.resized. So let's say 200 comma 200. Okay, so this parenthesis, so we have this parenthesis, and within this parenthesis we have a tuple. So we know the tuple should be enclosed in this parenthesis and so on, and here I'm mentioning what the dimension of the image should be. So I'm converting the image that has this dimension of 1365 2048 dimension to 200 into 200 image. So we are just basically reducing the dimension of this image. So let's run this. So first we are opening this file and we are storing this in the variable called as image, and now we are taking that particular image, and now we are resizing that to the dimension 200 comma 200. Okay, so let's run this. So this particular line will convert this image. Okay, so JPEG has no attribute resize. Sorry, so this should be resize. So we should remove that D. So let's run this now. Okay, so now this image has been resized. Now what I'll do is I'll check the shape of this image resized. Okay, so let's print this image resized dot shape. So I'm not sure whether it has this shape attribute. Let's see. Okay, so this image object has no attribute shape. Okay, so there is another way to find this image dimension. So let's now what we shall do is so this is in the form of an image. Now let's save this resized image. So we have this original image which is dog.jpg. Now let's save this resized image. So img underscore resized dot save. So we have to use this save function, and within this quotes you have to mention what is the name of the file that you want to save. So let's say that this is dog image resized. Okay, so dog image resized. So this is the name of the file .jpg. Okay, so let's run this. So this will save the file to the current directory you are in. Okay, so in case again if you are working in python or spider or something, so this particular image will be stored where your python file you are working on is stored. So let's say that you are creating a python file in spider and you are naming this to processing image data. So this particular file will be stored in a folder, right? So there this image will be saved, so in the same directory. So now we have this dog image resized .jpg. So you can see now this image has been resized, whereas previously we have seen that this image was like very large, right? So this is like a huge image because the dimension is very large, so we have to scroll it to see the image and so on, whereas now it has been resized. So we can also load this again through this matplotlib library in order to visualize this image. So I'll just copy this code, and so we have to read this image first. So for this reading this image, we have used this particular line, right? So mpimg.imread. So I'll just paste it here. Okay. So the only thing is we have to like remove this one. So this is my original image. Now I have to give this a resized image. So dog image resized, copy path, and let's paste it here. And now let's name this as resized. Okay. So image resized, or I'll just put this as image underscore res because you may be confused with this particular variable. So let's name this as image underscore res, and I'll just put it here, and image resized plot. Okay, so image resized mp image imread, we are reading that file image resized plot plt.show. Okay, so now we can run this one. Let's see whether the image is resized. Okay, now you can see. So previously the image kind of looked like this, and you can see what is the dimension of the image. And now we can see the image has been the dimension of the image has been reduced, and both x-axis and y-axis have the values at 200. So this basically means the dimension of the image that we have. So now this image.res, we are reading this through mpimg, right? So this has been already converted to numpy array. So we have seen that here. So when you read the file or read the image file using this imread, it will be converted into a numpy array, and you can print the shape, right? Now let's try to find the shape of this image. So we know that it will be in the shape of 200 into 200, right? But we can check it once. So I'm going to print the shape of this image underscore res. So image resized dot shape. Okay, so let's see. Okay, so previously we add the image with dimension 1365 and 2048 with 3 colored channel, which is RGB image. So that RGB image has not been affected, only the dimension has been changed. So we have the dimension as 200 into 200 because we have mentioned the dimension as 200 comma 200. So you can give any dimensions that you want, but there is the catch here. So few machine learning models, so we also come across this pre-trained models, And in that case, so those models accept only a particular image dimension, so you have to refer the model that you are going to use, and you have to give that particular dimension while resizing the image again. So when we are working in a use case in deep learning, so instead of doing this one, we will do this for maybe 1000 images or 10,000 images, but the concept is same. So we have done this for one image, right? So we just create a for loop, and we will make the for loop to loop through that particular folder and resize all the images in that particular folder. So this is what we do. And so we have converted the first two things, right? So first we have seen how we can read this image file and how we can convert it to a numpy array, and then we have seen how to resize this image, and finally how we can convert RGB image. RGB image is nothing but the colored image to a grayscale image. So this is the next thing that we are going to discuss. So let's see how that can be done. Okay, so for this, let's take this original image, which is represented as this dog.jpg, and here I'm going to use this OpenCV function. So the reason is I just wanted to introduce you to the different libraries that we have, and for image processing, and this OpenCV is very, very important. So a lot of image recognition and computer vision tasks, we will be using this OpenCV library in the future. So just try to understand what are all the functions and functionalities and different uses of this library. It will be useful for you in the long run. So the next step will be to convert RGB images to grayscale image using OpenCV. Okay, so converting RGB images to grayscale. So let's see. First, we have to import this OpenCV library. So you can just go to Google and do some research on this OpenCV. So we have seen that Pillow has been imported as PIL, right? How OpenCV is imported is import OpenCV. So we don't use OpenCV, we use CV2. So this is how the OpenCV library has to be used. And as I've told you, CV2 stands for computer vision. So here we are. I'll just make a comment as importing OpenCV library, and here also let's name this image as img. So we are creating a variable called as img, and this img is equal to cv2.imread. Okay, so this is the function that we have. So in the case of Pillow, we have opened the image using this image module, and in the case of matplotlib.image module, we have again used this imread. So img.imread, which is this matplotlib.image module. And for this cv2, there is a function called as imread, and within this parenthesis, again you have to mention the path of this file. So I'll copy this dog.jpg file. So let's copy this, and let's run this one. Now let's check this image type again. So type of this img, you can see. So this is also reads the file in the form of numpy array, so a numpy n dimensional array. So mp image dot imread and cv2.imread, both of these functions have the same have the same functionality. So this image has been converted to a numpy array, and after this only we will convert this image to a grayscale image. So now this is in the form of a RGB image, right, a colored image. And now let's see how we can convert this colored image that has 3 channels into a grayscale image that has only 1 channel. And after doing this, I'll explain you what is the significance of this and why we have to do this. Okay, so I'll just mention this img dot shape. Let's again check what is the shape of this image. So we already know the shape. It's 1365 2048. So this is the image dimension, and this one represents the color channels. So the 3 color channels are red, green and blue. And now I'll create another variable as grayscale image, and this is where we are going to convert our image. So grayscale image is equal to cv2. So we are going to use this cv2 library, which is computer vision library dot. There is a function called as cvt color. So we are going to convert the color that we have, and the arguments that you have to give to this function are: first is the image that you are working on. So we have read this image using this imread function, and we have stored that in the variable called as img, and this img is nothing but the numpy array of this particular image, and that is the first argument that you have to pass. And then you have to mention how we are going to convert. So cv2 dot color underscore rgb to gray. Okay, Okay, so this is the conversion. So first is the image that you have already loaded using cv2.imread function, and the second parameter is cv2.color to RGB to gray. So we are just telling that I want to convert this image from this RGB format to a grayscale format. So that's what we are mentioning here using this cvt color function. Okay. Now let's do this. So the main thing is this should not be done on the image file, but this should be done on the numpy array that we have. Now let's see what is the change that has been going on here. So we have run this, and again you can check what is the type of this grayscale image. So it will also be in the form of the same numpy array format. So type grayscale image. Let's run this. So we can see here it is in the form of numpy.md array. Now the interesting thing is, if you print the shape of this grayscale image, so let's copy this grayscale image dot shape. When you print this, the value will be 1365, 2048. Now we don't have this 3, right? So the reason is we know that grayscale images have only one channel, so that's why we don't have the value as 3. So this third value, when you print this image.shape, represents what is the color channel, whether it is 3 channel or one channel. So as we know that grayscale has only one channel, so it is not mentioned here. When no values are there in the third, it is like understood that the value is 1. That means like the color channel is 1, which stands for grayscale images. Now if you want to display the images, what you can do is, so we can just display this grayscale image and see again. So we have used this matplotlib library. So we have used this plot imshow function, and we have did this plt.show, right? So we can also display images using cv2.imshow function. So that function to do this is cv2.imshow. Okay, but the problem is this particular function won't work in Collab. So Collab doesn't allow you to run this function, but it's not an issue because they have an alternate function to this. So the reason I'm mentioning this is, like, again, if you're working on PyCharm or Spider or any IDEs, you can use this one. So you can use this there, so that's not a problem. So I'll show you, I'll just mention it here, like, so cv2.imshow will display the image, but this will not be allowed in Google Colab. Okay, so there is an alternative, right? So the alternative is from Google dot patch, sorry, from Google dot collab dot patch. So from Google dot collab dot patches, import cv2. You have to mention, instead of dot, you have to mention I am show. Okay. Okay, so cv2 I am sure. So this is the function that we are going to use. I'll just make this particular line bold. Okay, so so this is nothing but when I say cv2.imshow, I am loading this function from cv2 library. So instead of having that function, so Google this collab developers has built this particular function where they have stored this in google.collab.patches, and from there we are going to use this cv2.imshow. So first we will import this from Google. So this is very very important because in several cases we have to display the images, and if you are working in Collab, so this cv2.imshow you cannot use. So you have to get practice with this function. So Google collab.patches import cv2 imshow. Okay, so let's run this one, and now we will be using this function. Okay, so this is for displaying. Again, so this is for the same purpose, displaying the image, but what we are going to display here is the grayscale image. So previously we had this colored image, and we have converted this using the cvt color function, and we have mentioned that I wanted to convert this from RGB, which stands for red, green and blue channel, to grayscale image. And now let's see, I'm mentioning the cv2 I am show, and here mention the image which you have processed. Okay, grayscale image. So this is like same thing. So we are converting this numpy array into a image. So let's run this one and see whether the image has been converted. Okay. Now you can see here the previously the image was in in a colored format, but now it has been converted into a grayscale image. So it is like the original dimension, which is like 1365 into 2048. But when you run this in Matplotlib, so Matplotlib library will just shorten it and it will display in this format. But cv2.imshow won't do that. It will just give you the original dimension of the image and so on. So that's why you have this large image where Matplotlib just shrunk that image and display this in a shorter format. So that's the thing. So these are all the things that I wanted to discuss today. So first is how you can load this image file to a numpy array. So for that we have seen that we can use this mp img library, which is matplotlib.image library, and we can use this imread function. We can also use cv2.imread function as well. So we have seen how we can do that, and we have seen that we can print the dimension, which is nothing but the width and height of the image, as well as how many color channels are there, and 3 means RGB image, and if no values are there, that means like grayscale images. And we have also seen how we can resize this images using this image.resize, where this function is present in pillow. Again, you can use the resize function that is present in OpenCV as well. So it is like cv2.resize. And then we have seen how we can convert this colored images into the form of grayscale image. And if you wanted to save this image, there is also another option. So previously we have seen, right? So we have saved an image. So once we have resized this image, we have saved this image, and this is nothing but the function that we have in pillow. There is also another option in cv2 as well, in OpenCV as well. So that is uh, let's save this, saving the grayscale image. So this is a process using this OpenCV, right? So we can write the cv2, which stands for OpenCV dot imwrite. So imwrite means we are writing an image, or in other words, we are saving an image. So im stands for image, and here you have to mention what is the name and the path of this file. I'll just mention this as dog grayscale image. So we have dog resized image. Now this is dog grayscale image dot jpg, and so this is the name of the file. And now you have to mention what you are going to convert. So here I'm mentioning the library name, and here I'm mentioning the function, and here I'm mentioning that what is the name that I wanted to create an image just, but I didn't mention what I'm going to convert, right? So I'm going to copy this grayscale image. So this is where my grayscale image is. So let me put it here. So this will take this grayscale image and save it in the name of dog grayscale image. Okay, so let's run this, and it will be stored here. So once this is run, you can see here that that file has been stored. So this is the resized image that we did using the pillow library, and we have converted this grayscale and we have stored here. So you can download this and you can also see this. So this is how you can convert your colored images to grayscale images. Now the most important thing is, I told you that I'll tell you what is the purpose of doing this, right? So if you see this, one main thing about this conversion of RGB image to a grayscale image is, so like if you consider the same image, this colored image and the grayscale image, if you consider this, both of these images are like the same thing, but in the form of numpy array. This colored image is basically it is a three matrix, right? It is like three matrices where one matrix represents the red intensity, second matrix represents green, third matrix represents the blue intensity. So we have seen here. So when we take two similar images, the same images, and we convert it to an array, numpy array, the colored image will give you three arrays or three matrices, whereas a grayscale image will give you only one image. Now this is a very crucial thing, because so if you convert this RGB image into a grayscale image, you are saving a lot of space. Okay, so instead of having three matrices, you are having only one matrix, which saves a lot of space. And so this can be a small thing when we are working with one image, but when you are working with 10,000 images and 50,000 images, this is a huge change. So like if you have a 50,000 images, so each image will have three images, right? So you have to multiply it with like 50,000 into 3. Whereas if you have grayscale images, so the total number of matrix that you have will be 50,000, right? So this is the main advantage of this. So this will save a lot of space, and this will save a lot of computation power, as well as the time that has been taking for processing your image. So this is one thing. And there is also another important factor. So you cannot do this conversion all the time. So there are use cases or problems where the color of the image is not important, whereas in some cases the color of the image is like very important. Let's say that you are building some neural network in order to determine what is the color of the dog. In that case, you cannot convert it to grayscale, because like when the RGB images are there, it will give you more information on what are all the different colors that you have in an image. Whereas in the case of grayscale, that information is not there, because so we can say that in some cases this color information is very crucial, whereas in some cases we have to determine where are the edges in a particular image, and a few other things where the color won't be important. In that case, instead of having an RGB image, you can use or you can convert those images to an RGB image. Sorry, I'm sorry, like in cases where you don't need the color information, you can convert the RGB images to grayscale images, so that the processing is kind of easier where we don't need that information. Okay, so let's say that you are building a neural network system that can determine like whether an image represents a dog or it represents a simple ball, and something so on. So in that case, the color information is not there. So the main thing that the model checks is like what is the shape of the object that is present there. If it is in the round shape, it will tell that it is a ball. So if a dog image is there, so it just tries to find the difference. So in this case, if you think about it, so the color information is not that important. Whereas if you are working on a project where you have to determine what is the color of the image of a particular dog, in that case this color image is important, right? So it is a trade-off that you have, where when the color information is not necessary, you can instead of having this large matrices, is three times more matrices. So if you have a RGB image, you have three times more matrices. So instead of that, you can convert it to grayscale image, so that you are saving a lot of computation power as well as the resource and time. So this is the advantage of doing this, and we will do this a lot of time in our deep learning use cases. So please try to understand this deeply, practice this with different images, and please go through what are all the different functions that we have. So I have shown you how we can convert this image to grayscale, right? So check whether there is any functions in order to do the same thing. So instead of OpenCV, whether you can use pillow, and as I've told you, there is an function in OpenCV in order to resize this image, whereas in this case we have used pillow. So do some research on that part as well. So here we have used this pill, right? So from this pillow we have imported this image and we have done this. So try to do this with OpenCV library and so on. So this will be like very useful for you when you are working in deep learning applications. So in the next upcoming video, so it will be on handwritten digit classification, which is a deep learning use case. So after that, we will go back to our machine learning topics, and once in a while, I'll try to post deep learning projects and use cases videos, so that it is kind of a mix of both the things. Okay, so that's it from my side. We will be working on the MNIST handwritten digit classification using neural network. This is one of the basic and important use cases in deep learning, and this is an image recognition task, and working on this will give you an idea of how to handle image recognition projects. So let's get started. So first of all, let's try to understand what is the workflow that we have in any image recognition problems, and as well as in this MNIST handwritten classification. So first is about data collection. So first we have to get this data set. So this particular data set is available in Keras itself. So in case you are working on some other image recognition task, you can search for that data set in Kaggle. Or if you are working in a company where you have to build this deep learning system, they probably will tell you an idea of where you can get that particular data. So the first part is collecting the appropriate data for your particular use case, and the next one is to process the image data that you have. Okay, so so we have seen like what are all the different image processing that we have to do in the previous video. So we have seen that what does the dimension of an image means, and we have seen what is meant by this pixels, and we have also seen that there are RGB images and grayscale images and so on. So the steps involved in image processing are, so in case you have images in different dimensions, so the one step would be to resize all the images to a common dimension. So that is one of the steps, and after that in some cases we will try to convert this RGB images to grayscale images. So you can consider this RGB images as colored images, and grayscale images as the images a black and white image which has only one color channel and so on. So these are some of the image processing tasks that we have, and once we have these images, we have to build the labels for these images. So once we have this image data as well as the label, we can split this data into training data and test data, similar to how we do this in any machine learning task. Okay, so we will train our neural network with this training data, and we will evaluate our neural network with the test data that we have. Okay, So once we have trained our neural network, so we will feed this data to this neural network, and this neural network will be trained on the data set that we have. So in this case, our goal is to give an image, and the neural network should tell us what that particular digit is. Okay, so the different digits that we have are from 0 to 9. Okay, so these 10 numbers, 0 1 2 3 all the way up to 9. So this is like a single digit detection neural network, so you can think about like that. Okay, and once this neural network has been trained, if you give an image of a new image, or the image that contains some number, it kind of recognizes what that particular image is. So this is what we are going to do in this MNIST handwritten digit classification problem, where the ultimate goal is, if you feed an handwritten digit, this trained neural network should tell you what that particular digit is. So this is the idea, and so this is the process we will be following. Okay, so once we train this neural network, once we evaluate it with the test data, we will build this predictive system where if you feed the image, it will tell you what that particular digit is. Okay, so let's get started. And so I'll just open my Google Colab now. Okay, so this is the MNIST handwritten classification problem. So the first step will be to import the dependencies that we need. Okay, so dependencies are nothing but the libraries and the functions that we need. So I'll make a text here as importing the dependencies. So if you haven't worked on any deep learning projects, or if you haven't trained any neural network, like this, like you can understand this particular video, because I'm going about all the basics that we have. So don't worry if you haven't worked on any deep learning use cases. So first I'll import the NumPy library. So I'm importing NumPy as NP. And the next thing I'm going to import is the matplotlib library. So import matplotlib dot pyplot as plt. Okay, so this numpy library is very important in deep learning projects, because we have seen in the previous video itself that we will convert the image data into numpy arrays. So we need this numpy library, and then we have this matplotlib library. So once you have this numpy arrays, we can visualize this image so using this matplotlib plots. So once you feed that numpy array to the plots of matplotlib, you can see what that particular image is. Okay, and the third library that I'm going to import is cbound. So this is also useful for certain plots. So I'm going to import cbound as SNS. And the next library will be CV2. So CV2 is nothing but the OpenCV library. Okay, so this OpenCV stands for computer vision, and this is one of the important libraries that we have when it comes to image recognition tasks. Okay, and the next thing that I'm going to import is from google.colab.patches import CV2 I am sure. Okay, so this CV2 I am sure function is just used to show an image, to display an image. So this is actually a function that is present in this OpenCV library, but Google Colab doesn't allow you to use this particular function that is available in the CV2. Okay, so instead of that, so they gave an alternative in this module google.colab.patches. Okay, so from this we can import the CV2 underscore I am sure. So like if you are working on Spider or PyCharm, so you don't have to do this. So you can import this, or you can work on this like cv2 dot I am sure. So you just have to import this OpenCV library alone. As we cannot do this in Google Colab, we are importing this as cv2 underscore I am sure. Okay, and let's import another image processing library, which is Pillow. Okay, so from pill, where pill stands for pillow. So from pill, let's import this image module. So this is helpful for us. And after this, let's import the deep learning libraries that we need. First, I'm going to import TensorFlow. So we will be working on TensorFlow and Keras. So let's import TensorFlow as TF. And now I'm going to set the random seeds. So TF dot random seed. Okay, so sorry. So TF dot set seed. So TF dot random dot set seed, and let's set the seed to 3. So you can give any values for this, and the purpose of this setting the seed is that, so when you're training a neural network, when you're feeding this data to your neural network, and once this neural network is starting to learn from the data that you feed, what happens is there are several values that randomly gets generated. So like let's say that there is some parameter that has to be given for this neural network, and in some cases these values will be generated randomly. So because of this randomness, each time you train your neural network, you will get different results. Okay, so even if you use the same data, so the accuracy values and other values may slightly change. Okay, so there won't be a large change, but they will slightly change. So when you set this random state to a particular number, So this changes won't be there. Okay, so this is the reason for setting this random seed. You can set any numbers you want. So if you give that particular number, you will get the identical result. So this is just like the random state value that we have in train test split function. Okay, and the next thing is, from TensorFlow, let's import Keras. Okay, so Keras is another important deep learning library. So the most important and the famous deep learning libraries that we have are TensorFlow, Keras, and PyTorch. Okay, so PyTorch is developed by Facebook and TensorFlow is developed by Google. So Keras is just like it is a wrapper of these deep learning libraries. So previously it was difficult to build neural networks with this TensorFlow library. So they created this Keras library, which helps us to easily create this neural network. Okay, so we will use this keras, and in the backend there will be this TensorFlow. So after a point, TensorFlow included keras in their own library itself. So we will be working on the APIs that we have in keras. Okay, so we will be working on sequential and other layers and so on. So that is the idea of importing this keras. And then from keras dot datasets, let's import MNIST. Okay, so as I've told you, this MNIST is a famous dataset, and this is useful for someone who is starting to learn about deep learning. And this dataset is available in this Keras library itself. So we might have came across this breast cancer data, diabetes data, and these datasets are present in the sklearn library, right? So similarly, we have a few datasets in this Keras library. So and here we are going to use this MNIST library. So that's the idea here, and we will see how we can load this library. But this is the reason. So we are from this keras.datasets module, we are importing this MNIST, and finally I'm going to import from TensorFlow dot math, import confusion matrix. Okay, so these are all the things that I want. So let's run this. So we have NumPy for NumPy arrays, Matplotlib and Seaborns for the plots and graphs that we want. CV2 is the OpenCV library for image processing task, and then we have the CV2 IMShow for displaying the image. Pillow is also used for image processing task, and then we have the deep learning library TensorFlow, and we are setting some seed for this TensorFlow, and then we are importing Keras, and from Keras the datasets MNIST data, and finally we are importing the confusion matrix. So these are all the dependencies that we need. So the next step is the data collection part. So I'll mention the text here as loading the MNIST data. Okay, so MNIST data. So this is basically image data from keras.datasets. Okay, so how we can import this data set is like this. So we have to give this so MNIST dot load data. Okay, so we have already imported this tf dot keras dot datasets. So instead of doing this, we have imported this keras dot datasets like directly. So first we have imported this keras, and then we have imported this keras dot dataset. So from this we have imported this MNIST and so on, right? So instead of that, from this TensorFlow itself they are loading this. So they are basically the same thing. So we are doing this step by step, and here they have mentioned as one single step. So that's the thing. So we have to mention this MNIST dot load data. Okay, so that's what we need to do. And so once you load this, you will get 4 arrays, and the 4 arrays that you get are xtrain, ytrain, and xtest and ytest. Okay, so the thing here is, this is an already processed data, so you don't have as raw images. So we have seen in the previous video, right? So in the previous video was about how to process the image data for deep learning, and we have taken a single image. So we have taken the single dog image, and we have seen what are all the different processing that we do. So we have seen that we have to convert this image into a NumPy array like this, and so this is an example of a RGB image, right? Because we have 3 here, so 3 represents this 3 channels that we have: red, green, and blue, and these 2 values are the dimensions of the image, the width and height of the image. And the next thing is like so the other processing that we do is we have to resize the images. This is because if you have 10,000 images in your data, if all the images are of different dimension, then it is hard for the neural network to understand this images. So we have to resize the images to a common dimension. So in this case we have used this pillow. So this image module, from that we have used this from this pillow library image module, we have used the resize function, and we have resized to 200 comma 200. So this is another processing, and after that we have to convert this RGB image into grayscale image, so that we can save some storage space and the computation power and so on. Whereas in some case we have to work on the RGB images, but for this digit classification we can work on the grayscale images itself. And all this processing has been already done, and they have been stored in this MNIST data. Okay, so all the processing has been done, and they have also split the data into training data and test data. Okay, so we don't have to worry about that. So if we just go to this workflow, until this part everything is covered, from image processing to the train test bed, all the things has been covered. But it won't be the case in all the things. So in some cases you will have only the images and you have to process them and so on. So we will discuss about that in the upcoming project videos on how we can do that. But in this case we already have the processed images, and the data has been split into training data and test data. Okay, so you have to mention the 4 arrays here: so X train, Y train, X test and Y test. And so let's create them. So X train comma Y train, and then X test Y test. Okay, is equal to MNIST dot load data. So we can see this function here. So we have this MNIST load data, right? So MNIST load data. So we have to mention the parenthesis. Okay, so when you run this MNIST dot load data, you will basically get 4 arrays, and those 4 arrays are nothing but this X train, Y train, X test and Y test. Okay, so that's what they have mentioned here. So this is how you can load this X train, Y train, X test and Y test. The only difference is that I have just used this caps for X and Y. So that's the only thing, but the process is kind of the same. Okay, so let's run this. So this will load this MNIST data to these arrays, and you can also check the data type of this arrays. So we know that we have the keyword type in Python in order to check the data type. So I'll give this as type of X train, and here I can see this is in the form of numpy n dimensional array. Okay, so this is just to understand that the images has already been converted to numpy array. So we don't have to do that again. So we have the numpy array, so images have been converted to them. And now let's try to check the shape of these arrays: X train, Y train and X test and Y test, and then we will try to understand what these 4 arrays means. So shape of the numpy arrays. So this is the basically the data that we have. So I'm going to print. I'll just copy all these things: X train, Y train, X test and Y test. Let's put this here, and I have to mention this as X train dot shape, and Y train dot shape. So I'll remove this parenthesis. Y train dot shape, X test dot shape, and finally Y test dot shape. Okay, let's try to understand what this signifies. Okay, so the value that we have for this X train dot shape is 60,000 and 28 comma 28. So what this basically means is your X train contains 60,000 images, and each image has a dimension of 28 into 28 pixels. Okay, so these are the value of height and width of the image, and these are the pixel values. So we have already seen about this. Okay, so if you consider this dog image, so it has printed like this, right? So what this means is like the height of this image is 200, and the x-axis value, which is the width of the image, is also 200, which is represented here. So here we have this 3. So what this 3 means is it has an RGB image, whereas we don't have that particular number here. So this means like this is a grayscale image. So X train is my 60,000 images, and like each image is so 28 comma 28 is the dimension of each image, and this is a grayscale. All the images are grayscale images, and the label for all these images has been stored in this Y train. Okay, so let's say that this X train has the image as, let's say, 7. Okay, so we can see this particular image. So once we train our neural network, we will feed this image, and we will check whether our neural network can recognize this image. So we have this 3, right? So this image has been converted to numpy array, and it has been stored in this X train. Let's consider that. and the label, so in this case the label is 3, right? So that will be stored in this Y train. So 60,000 represents my training data images, and the label for all these images are stored in this Y train. And then X test represents all my test data images. Y test represents the corresponding labels for all these test images. So that is how this data has been splitted. And if you see the count here, we have 10,000 test images. So the number of training data that you have is 60,000, and a number of test images that you have is 10,000. Okay, so that will be mentioned here as well, so you can see. So yeah, so extrain is unitate numpy array of grayscale images. So this is what I mentioned, because if that is an RGB image, there will be another value as 3 in this case, but we don't have it. This is a grayscale images of 60,000 values, and all the values ranges from 0 to 255. So we know that all this value represents what is the intensity of the white color. In the case of RGB images, we have 3 matrices, and each matrix correspond to red intensity, green intensity, and blue intensity, right? So all the values in an image range from 0 to 255. So we know that, and all the labels are present in this Y train, and the values range between 0 to 9. Okay, 0, 1, 2, 3, all the way up to 9. And then in the test data, we have 10,000 images. They also in the 28 into 28 pixels, and sorry, height and width, and they also have the values between 0 and 255. As 0 means that particular pixel is completely black, 255 means that particular pixel is white in color, and the corresponding labels has been stored in this Y test. Okay, so this is the shape that we have, and you can see here. So this is a data set of 60,000 28 into 28 grayscale images of the 10 digits, along with the test set of 10,000 images. So that's what we have understood here. And so let's just make some text here of what is present in this data set, so that if you look at this at a later time, you can understand this. So let me put this as training data is equal to 60,000 images, and my test data is nothing but 10,000 images. Okay, and each image has a dimension of, so image dimension is 28 into 28. Okay, and grayscale, so these are grayscale images, right? So grayscale image means they have only one color channel. Okay, so unlike RGB images which have 3 color channels. So this is the basic information of the data that we have. So as I've told you earlier, we don't have to convert these images into grayscale images, and we don't have to resize the images and so on, and we don't have to convert this to numpy array. So all these things has been already done, and all this has been split into training data and test data as well. So until this part, everything has been already done in this data set. So we have to just try to see what are all the images that we have to get some basic idea, and after that we can train our neural network. Okay, so what let's do is let's try to print an image from this data that we have. So let's take one particular image. So printing, let's say I'm going to print the 10th image from this X train. So I'll mention this as print X train, and in this I'll say 10. So 10 is the index of this image, so which is basically it is the 11th image, because we know that in Python indexing starts from 0, right? So the image in the 10th index, so these are all the values. So we know that it is in the form of a numpy array, and all the values range between 0 and 255, right? And we have already seen, once you have this in the form of a numpy array, we can convert it back into an image, right? So let's see how we can do that. And I'll also check what is the shape of this image. So xtrain 10, so this is the image that we have worked on, right? So xtrain of 10 dot shape, so this will tell you what is the shape of this image. So it is a 28 into 28 image. So this is the height and width. So totally we have 60,000 images, and all these images have this particular dimension. So this is why I told you that all the images has been resized already, and all these images have the constant dimension. Okay, so this is the single image dimension, and now we are going to display the image. So displaying the image, plt.show, sorry, plt.imshow. So this plt.imshow is used to show an image. So we know that plt means the matplotlib library that we have, and I'm going to show, let's say you can just mention any images that you have. Xtrain, now it is in the form of numpy arrays, and we are going to convert it. Let's say the index is equal to 50. Okay, and plt.show, so this will print my image. Sorry, So extrain 50 and plt dot show. Okay, and now what I'll do is I'll also print the label. So in this extrain I will take the image with the index of 50, and from this white line and I will take the 50th label as well. Okay, so let's see. So plt im show, which stands for image on plt dot show, and here we will print the corresponding label. Okay, so print white train. So white train is my training data label, right, of 50. So let's see. Okay, so this is the 50th image that we have, and this is the label for that image. So you can just give anything here. So let's say that I'm printing the image with index 25 and I'm printing the corresponding label. So both the things will be same. So previously it was in the form of a numpy arrays, and we are just converting back into an image to just check whether the image and the labels are correct. Okay, so this is the image. So this, we know that this is two, the image of the number 2, and we have the label as 2. Okay, so this is nothing but, so this is what we are printing here, white train of 25. So you can change these two values and see the image and the corresponding label. Okay, and then image, so this is actually a grayscale image, but this is the color that we will get in matplotlib show. Okay, so you don't have to think that this is a colored image. This is actually a colored scale image because this is only one color channel. Okay, and so let's try to analyze some of this labels that we have in this for these images. So image labels, so just some basic analysis of what are all the different values that we have and so on. First I'll try to print this white train shape, white train dot shape, and y test dot shape. Okay, so the first value represents how many values are there in X train. So this is nothing but the label for the 60,000 training data images, and this y test represents the 10,000 labels for the test data. Okay, now let's see what are all the unique values that we have in white train and y test. Okay, so unique value, and another important thing, we can use this data set in order to classify only, like, or in order to recognize only one digit. So you cannot have multiple images, the model may not predict it correctly because we are training it with only one digit, right? So that's the reason. So unique values in white train, and I'm going to use this print. For this we can use the function np. So we know that np means numpy, right? So there is a function called as unique in numpy, and within this parenthesis you need to mention white train. So what this function will does is it will take this white train array. So we know that this is a numpy array, right? So it will take this array and it will try to find what are all the unique values that we have in this array. So I'll copy all these things, and I'll also print the unique value in y test as well. Let's see what are all the labels that we have. Okay, y test. So these are all the unique values. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is for all the unique values white train, and this is all the unique values in white test. Okay, so the training data and test data images. So this is what is given here. Okay, so white train is nothing but the digit labels which range from 0 to 9, and all these things are in the form of integers. We can see that here, right? So they are not in the form of floating points. And again, white test also range from 0 to 9. So white train is my training data images and white test is my test data images. Okay, so we can use this label directly. Okay, or you can also perform one-not encoding. So in this case I'll just use this directly. So in some other deep learning use cases I'll show you how you can do this one-not encoding on this labels that we have. Okay, so I'll just mention this here. We can use this labels as such, or we can also apply one-not encoding. Okay, so basically what happens in one-not encoding is if your label is 0, in that case the first value will be 1. Okay, so the first value will be 1 and all the remaining 9 values will be 0. So let's say that there are like 9 zeros here, 0, 0, 0, and so on. If the label is 1, your second value will be 1 and all the remaining values will be 0, and so on. So this is what one-not encoding is. And let's do this in some other cases. Let's have this label as such in for this one. Okay, so now what we are going to do is, so okay, so, and the other thing, as I've told you, we don't have to resize the images as all the images are in the in the dimension 28 command 28. So I'll also mention this here. so that you can remember this. So all the images have the same dimensions in this data set. If not, we have to resize all these images. This all the images to a common dimension. Okay. Right. Okay. So if you have images with different dimensions, you cannot put that together in a single array. So it won't be compatible, right? So you can, create numpy arrays with elements of the same shape. So that's why we have this array. If not, we cannot create this array. So we can say that all these images are in the shape 28, 28, and this is also given in this particular documentation here. So all these are 28 into 28 and grayscale images. So these are not colored images, and these have only one color channel. And now what we are going to do is we are going to scale the data that we are scaling the values. So we know that all the values are in the range of 0 to 255, right? So here also we have, so 0 to 255, which basically tells you the intensity of the colors that we have in this. So instead of having this range from 0 to 255, we can convert this so that we can have the values between 0 to 1. Okay, so I'll show you how we can do this. So this is also called as normalization, so that all the values are in the kind of same range. So this is like very helpful for us, because if the values are large, like 254, 81, 40 and so on, it is hard for the neural network in order to do the calculations, as the number is large, right? So whereas if you convert these numbers into small numbers without changing the information that this data has, all the things becomes easier, and we can also get better prediction. So this is kind of similar to the standard scaling that we have in machine learning, and the normalization that we have to that we used to do. So I'll take this x train. So x train is equal to x train divided by 255. So in most of the cases, if you don't do this, you will probably get a lower accuracy. So in this case, the accuracy may not change, but in most cases that will be the thing. Okay, so it's better to normalize this. So x train by 255 and x test by 255. So what I'm doing here is I'm taking my all the training data and I'm dividing it by 255, and I'm storing it in the same variable called as x train. So you can also give another like name as x train scaled or something like that. Okay, so it's not a thing. So I'm just giving the same name so that there is no confusion and all that. Okay, so I'm taking all this x train, dividing it by 255, and I'm storing it in again this x train, and this x test to this same. So I'm again taking this x test, dividing it by 255 and x test. So let's understand what happens when we do this. So let's say that the number is 0. Okay, so we have like all the values here, right? So each value will be divided by 255. Let's say that there is this value which is 0. So if the value is 0 and I divide it by 255, we know that the answer will be 0, right? And when the value is 255, so we are dividing it by 255 because 255 is the maximum value that can be present in this data. So that's the thing. So there is like nothing more to why we are using this specific thing. So it should be divided by the maximum value that we have. Let's say if the value is 255 and we are dividing it by again 255, now we know that we get the value as 1. So 0 is the minimum value that you have in your training data, and 250 is the maximum value. So the minimum value now you will get is 0, and the maximum value will be 1. So all the other values will be between them. So I'll try to show this to you. So let's say that, sorry. So I'll just open this calculator. And so let's say that we have this value zeros and zeros and all that, right? So we know that if we divide this 0 by 255, so the answer is again 0. So this is my minimum value. So the minimum value that you can have in this is 0. And let's say that if it is 255, we know that when we divide it by 255, this is just very basic math, this is 1. Let's take some other values. Let's say that the value is 40. So if I take 40 and divide it by 255, I will get this value as 0.156 and so on. If I take this value 214, so let's see. So I'm taking this 214 and I'm dividing it by 255. It will be 0.83. So the idea here is all the values will be in the range between 0 and 1. Now it is easier for the neural network to understand the images, to understand the data better. So that's what we are doing here. So let's try to do this. I'll close this one and okay, so I'll remove this and let's run this particular cell. Okay. Okay, now we can print this extrain 10. So we let's print this 10th image itself. So this won't affect our image because like all the values are changed, right? If you change only like few values, in that case the original data has been compromised, but we are changing all the values. We are just changing the range in which these values are present. So previously you add the range between 0 to 255. Now we are having the values between 0 and 1. So that's the idea. Now if you print this particular value, you can see the values are between, so we have the 0 0.0. So and the values have been converted to floating point, we can see here. So previously in the first row we have all the things as 0 and so on. So we have the value as 0.996, and then we have this 0.3368 and so on. So previously we add the values between 0 and 255. So this is how we can do this normalization, or how we can scale the values between 0 and 1. So instead of having the values between 0 and 255. Okay. And now so these are all the processing that we have to do, and after this we can build our neural network. Okay, so I'll create a text here as building the neural network. So here we won't be using convolutional neural network, so we call this as CNN. So we will build a very simple normal neural network. So in convolutional neural network you have this convolutional layers and so on. So there is a lot of concepts that has to be discussed in this. So we will discuss this all these things in the deep learning course, but for now understand that we are not using CNN here. So CNN are like very efficient neural networks that can be used on the image data, and we also have another type of neural networks called as RNN. Okay, so this RNN stands for recurrent neural networks, and this particular neural networks are very helpful when we are working with the text data or audio data and so on. So CNN is widely used for this image recognition, and this RNN for this text recognition and audio recognition things and so on. So here we are not CNN, we are not building CNN, as it may sound a bit complex to you. So we are just building some normal neural network. Okay, so a very basic one. So the first step that we have to do is setting up some layers for our artificial neural network. Okay, so setting up the layers of the neural network, and for this I'll just create a variable as model, and for this model I'm going to use keras.sequential. Okay, so this is why we have imported this keras library. So keras.sequential, so we have to mention the parenthesis and two brackets, square brackets, and within this we have to set up the layers of our neural network. Okay, so keras.sequential. So first thing that I'm going to mention is keras.layers.flatten. So we have seen the use of this flatten in the previous deep learning project itself. So in the previous deep learning, the first deep learning project, we have worked on this breast cancer classification using neural network. So we have seen what is the purpose of this flatten. I'll also explain that to you now. So within this flatten, you have to mention the input shape. So in this case, the input shape is 28, 28. Okay, so what this flatten is, so you cannot feed the data in the form of this matrix. So here we have the data in the form of matrix, right? So 28 into 28. So that means like there are 28 rows and 28 columns are there in this particular image. So each image consists of like 28 rows and 28 images. So you can consider this as a matrix of this shape, 28 into 28. So we cannot feed this data in the form of this matrix or this kind of an array. So we have to feed this in a single dimensional array. Okay, so what happens is like instead of having these rows and columns, all the values will be loaded as a single line. Okay, so that's what we do in flatten, and this is how neural networks kind of get the data as input. So this is the purpose of this flattening, and in this flattening we have to mention the input shape. So input shape is nothing but what is your image dimension, and here this is a grayscale image, so we don't mention any numbers here. If you are working on RGB images, so let's say that you are training your neural network on RGB or colored images itself, in that case you have to just mention another value as 3. Okay, so this means that so this is just to tell the model that I'm flattening all the values and all these images are RGB images. Whereas if you just remove this number, so now the model can understand that okay, these images are grayscale images. Okay, so that's the reason for it. So if you are doing RGB images, just include another 3 years. So first layer is for flattening all the values. So this is just feeding all the values to our neural network. And now we can set some layers for this neural network. Okay, so layers dot dense. So dense is nothing but all the layers in this particular neural network is connected to the neurons in the previous and the next layer. So that is the reason of this particular dense thing. Okay, so we are building this dense neural network, and you can give this value. So I'm setting this value to 50. So 50 is nothing but the number of neurons that we have in this layer. So this is we have this input layer, which is the flattening, and then we have this dense layer with 50 neurons. So you can also change this values. So let's discuss later on, what the number of neurons we should have and how many layers we should have. So all these things we will discuss later, but for now, understand how we can implement the neural network. So let's go into the conceptual part later on. So 50, and we have to mention activation function. So activation is equal to ReLU. So ReLU is one of the widely used activation, and it is a very efficient activation function that we have. So ReLU stands for rectified linear unit. So you can do some research on this part. So this is, few neurons will be activated. So activated in the sense their value will be 1, and few neurons will have the value as 0. So when you use the activation as ReLU, so the activation formula kind of changes. If you use sigmoid activation, so that neurons kind of fires differently. So you have this ReLU, sigmoid, and leaker ReLU, and so on. So we will discuss about all these things later on. So here I'm giving this activation as ReLU, and so you have to mention a comma here. Okay, and I'll also create another layer. I'll just copy this one, and I'll create another layer. So I have this input layer where I'm flattening all the values, and then I have this dense layer with 50 neurons, and I have another layer with again 50 neurons, and finally I have an output layer. Okay, so keras dot layers dot dense. This is just to tell that all these neurons should be connected to the neurons of the previous layer. Okay, so dense 10, and activation is equal to, let's say, sigmoid activation function. Okay, so you can also change this to ReLU and see. So you can change this ReLU to sigmoid, you can change the sigmoid to ReLU. Your accuracy probably will change, so you can try that out. But this is the thing that I'm taking. So for this first two layers, I'm taking this ReLU as activation function, which is my rectified linear units, and for this final thing I'm using the sigmoid. So for this output neuron we shouldn't include this comma. Okay, so you can have any number here. So not any number, like you can take the neurons as 70, 75, or 100 or something. So here also you can take a different number of neurons, but this should be 10 here. So what this 10 means is the number of classes that you have in your labels. So in this case, if you check out the labels that we have the values as 0, 1, 2, 3 all the way up to 9. So the total number of values is 10, right? So we are starting from 0 and up to 9. So totally there are 10 values. So that is why we have the number of neurons in the output layer. So this is my output layer as 10. So in the previous deep learning use case video, the breast cancer classification video, we have add the value as 2 because we just had two classes, right? One is benign and the another one is malignant. So in this case we have 10 classes, and that's why we have 10 neurons here. So this is the layers of my neural network. So first I have this flattening layer, which is try to convert this matrix into kind of a single dimensional array, which as the values you can consider that all the values will be in the single column. And then we have this another layer with 50 neurons with ReLU activation function. There is another layer. And finally we have this output layer with 10 neurons, and in this case we are having the activation function as sigmoid. So you can just interchange it and check how the accuracy is kind of changing. So I'll run this one, and once you have set up this layer, so we are just specifying the specific, basically we are just telling what are all the specifications on neural network. Now we have to compile this. So this part of the code will be compiling the neural network, and for this we have to use this model is nothing but we have loaded this keras.sequential, right? So that's the thing. So model.compile. So there are like few important things that you have to mention. Okay, so you can see, so one is optimizers, and then we have this loss, and then we have this so we have to specify the accuracy, so it will be in the form of metrics. So model.compile loss, the arguments. Okay, so let's see, but the three main important things that you have to mention are this optimizer, loss, and metrics. So here it is. So let's see. So I'm going to mention this optimizers. Again, you have different optimizers are there, and I'm going to choose optimizer is equal to Adam. Okay, so Adam optimizer. Adam optimizer. And now I'm going to mention the loss. So loss is equal to sparse categorical cross entropy. Sparse categorical. So this is nothing but what is the loss function that you want to build your model on. So loss is equal to sparse categorical entropy, and the other argument is metrics. So what is the metrics that you have? So this is a classification problem. So let's say that the metrics should be accuracy. Okay, so let's try to understand this. So first is optimizer. So we have in machine learning, we know that we have this gradient descent optimizer, right? And the purpose of this optimizer is to determine the most optimum, model parameters, right? So if you consider a linear regression, we have the parameters as W and B, and our gradient descent will try to find which is the most optimum parameter. So optimum parameters in the sense, if you choose that value for your parameters, then you will get accurate prediction. Your accuracy values will be more. So similarly, Adam is one kind of optimizer, and then we are specifying this loss function as sparse categorical cross entropy. So here we have seen that we are using this labels as such, right? So this is in the form of kind of integers and simple numbers. Whereas if you convert the labels to one or encoded labels, in that case you have to use the loss function as categorical cross entropy. So this won't work. So this is when you have the labels as simple label encoded values as a 0, 1, 2, 3, and so on. Whereas for one not encoding, you have to remove this sparse underscore. So you have to use categorical cross entropy. And in the metrics, we have this accuracy. So we all know what does this accuracy mean. So it is just the number of correct predictions divided by the total number of data points that you have. And you can do some research on what are all the different optimizers that we have in Keras and what are all the different loss functions that we have. Okay, so try to see and try to change this optimizer and see what are all the what is the change in the accuracy that you are getting. Okay, so I'll leave that to you, so you can do some research on the part and check it out. Okay, and I'll run this one. So we are basically compiling our layers, compiling the neural network that we have built with this Adam optimizer with sparse categorical cross entropy as our loss function and metrics as accuracy. So I'll run this one. And now let's train our neural network. So this part will be training the neural network that we have. Okay. So let's say model.fit. So fit is nothing but we know that we use this to train our model, right? So this is similar to how we train our model in machine learning, right? So here we have to give your training data. So training data is nothing but my X train and Y train. So X train is my training data images, and Y train is the label for that corresponding images. So we have to give both of them. Okay. So model.fit, and I'm going to say X train comma Y train. So I hope you remember that we have normalized all the values. So all the values will be between 0 and 1 instead of between 0 and 255. So X train and Y train, and other parameter you can mention is epoch. So what is the number of epochs that you want? So I'll mention the epochs as 10. So epochs is nothing but how many times your neural network should go through the data. So each time it will try to change its parameter values, and it will try to give you what is the accuracy and so on. Okay. So this is my first epoch, and so these are all the number of steps there in the epochs. Okay, so this particular neural network is training kind of in a fast manner, right? But in most cases the training takes a very long time. So the reason is here the dimensions of the images are like pretty less, 28 comma 28, right? So here you can see each image is 28 comma 28, so it is not a huge workload for the neural network, so it doesn't require that much computation power. But when you have the images in this shape of 200 comma 200, so actually 200 into 200 is actually a small image, but even all the images are in this particular shape, this model will take a very long time, and it will take a very huge computational resources and so on. So this is just a very small images with 28 into 28 dimensions. So the training has been done quickly. Okay, so you can see how many so what's the time that has been taken for this each steps. And so this is the first epoch, and this is the loss function value for the first epoch, and the accuracy is 91%. So we know that loss function is nothing but the distance between your true value and predicted value. If your loss function value is high, that means your model is not working properly, it is not making good predictions, it is making kind of wrong predictions. So our main goal is to minimize this loss function for a model or for a neural network. So you can see the loss function has been constantly reduced here, and we know what is meant by this accuracy. So the accuracy kind of increases. So 91.3. So what does this means is, like, if you predict the unwritten digits for, like, 100 images, you will get correct predictions for 91 images. So that is what this accuracy means. Like, we can see that loss function decreases, which is what we want, and the accuracy increases in each epoch, and we get the maximum accuracy as 0.989. So which is just equal to 98.9. It's almost 99% accurate, right? So that means out of 100 images, it will give you correct predictions for 99 images. So that's the idea. So this is basically the accuracy on training data. So that is very, very important. So we have to check it for the test data as well to see whether our neural network has overfitted. So what happens in overfitting is that you will get high accuracy like this for training data, but for test data you will get low accuracy like 50% or 60%. So I'll mention here that the training data accuracy is 98.9%. 98.9%. Okay. And now we are going to evaluate our neural network, right? So this will be accuracy on test data. So this is what we are going to do now. So I'll just make this bold. So this part is nothing but model evaluation. We are going to evaluate our neural network. So I'll mention two values: loss, comma, accuracy is equal to. So within this model, so model is nothing but we have built this neural network with this keras dot sequential, right? So we have this function dot model dot evaluate, and within this you have to give this x test and y test. Okay, so what happens is, so your model will take this x test alone and it will give its prediction. Okay, and those predictions will be compared with the true label. So this is my true label, which is y test, or you can also call this as ground truth, the original values that we have. So the model will make predictions and y test is made true value. So it will compare both of these things and it will give you what is the accuracy on the test data. Okay, so the test data is something that the model has not seen before, whereas the training data it has already seen. So we cannot take this accuracy as the final one. So it's important that we have to find the accuracy for test data, right? So let's do this. So when you run this model dot evaluate, you will get two values. The first value you get is loss, and the second value you get is accuracy. So that's why we have two variables here. And now I'll print my accuracy value, and let's see what is my accuracy. Yeah. Okay. So the loss value is 0.104 and something, and the accuracy value is 0.971, which is like my model is 97% accurate. Okay. So this is the training data accuracy, and I can say that my test data accuracy. I'll just make another text here as my test data accuracy is equal to 97.1%. So 97.1, that means like this is the important accuracy metric that we need. So out of 100 images, your trained neural network can make correct predictions for 97 images. Okay, so we can say that our neural network doesn't overfit. If it is overfitted, in that case your test data accuracy will be very low. So we know that, right? So we have discussed about this several times in our machine learning use cases and course and so on. Okay, and now what I'm just going to do is I'm going to print the shape of this x test. So print x test dot shape. Okay, so we know that the test dataset contains 10,000 images and each image is of the dimension 28 into 28, right? So I'm going to display the first image. So first data point in the test data. So first data point in x test, which is my test data. Let's say plt dot I am show x test of 0. So 0 means the index 0. So index 0 means the first image or the first entry or data point. So plt dot show. So I'm going to display that image. plt dot I am show x test of 0. So the first image that we have in this x test is this 7. So we can see that this image is 7, right? Now I'm going to print what is the true label for this. Print. So y label is my true values, true labels, y label of 0. So it will be 7. So we know that. Okay, so y label, sorry, it's not y label, it's y test. Sorry. So y test. So 0 is nothing but the first data point. So the first image that I have in this X test is 7, and the corresponding label is, we know that it is stored in this Y test. So it is 7, right? Now what we are going to do is we are going to give this X test to our model, and we are going to see what is the prediction made by our model. So it is just this evaluate. So for this evaluate, we have checked the overall accuracy, but I'm going to see the individual predictions made by the model. Okay. So let's create a variable called as ypred. So y test is my true labels, and I'm storing all the predictions made by the model in this variable called as ypred, where ypred stands for y prediction. So we have to mention model.predict. Okay, model.predict x test. Okay, so this will predict the labels for all the 10,000 images, and all the 10,000 labels will be stored in this ypred, which is my prediction value. Now you can see this ypred shape, ypred.shape. So we know that this also kind of contain 10,000 values, right? Because there are 10,000 images. Okay. Now you can see there is an interesting thing. The value is 10. So we have to understand what does this 10 means. So I'll print the first value in this ypred. So ypred of 0. So this ypred is nothing but, so we are feeding all this x test to our model, and all the 10,000 labels, predictions made by the label, has been stored in this ypred. And when I run this, this will basically give the prediction made for this particular image, this first image, because this is 0, this is 0 as well. So this is the one, the true label or the ground truth, and this will tell the predictions made by my model for this particular image. So you can see the value like this. So we totally have 10 values here, so that's why we have the second value as 10. So we have 10,000 labels. I'm just printing in this for only one label. So we have seen what is the significance of this in the breast cancer classification using neural network itself, the first deep learning project itself. The thing is, for machine learning model, when you use this predict, it will return the label value. So whether the label is a 0 or it is 1 or 2 or 3 or so on. Whereas when you use this predict function with this neural network from this Keras neural network, it kind of works differently. It will tell you what is the probability that the value is this one. So if you see this, so 3.51 into e power minus 03. So e power minus 03, you can just think what would be, without this exponent, you can think about it. So this value is what is the probability that the label is 0. And if you check the second value, this is what is the probability that the value will be 1, and so on. So this is the idea for it. And in order to convert this, so each represents the probability of each label. So first one for 0, second one for 1, third one for 2, and so on. And we have seen that we can convert these values to the labels that we want using np.argmax, right? So we have seen in the previous video. So let's try to do the same thing here. So I'll also mention this, that model.predict. So this is very, very important. So model.predict gives the prediction probability of each class. So each class is nothing but 0 to 9 in this case. So totally we have 10 classes. So you have 10 values here for that particular data point. Okay. So instead of giving that label or the label, it will give this prediction probability. Now we are going to convert this. So this part will be converting the prediction probabilities to class labels. Okay, so it is nothing like for which class or which label the value is maximum. So that is the final answer. So out of this, we have to find which value is the maximum value. Okay, so if you see here, the maximum value will be for this one, right? So because like all the things have the values as e power minus 03, minus 01, and so on. So this is the highest value that we have among all the things. So it is nothing but the one for 7. So this is for 7, this is for 8, and this is for 9. So this is the maximum value that we have. But now we don't have to do this manually, because we cannot do this manually for this 10,000 images, right? So instead of that, we can use this argmax. Okay, so you can just tell that let's say that label for first image, so we are creating this variable, and I'm going to use np.argmax. So this is actually in the form of a numpy array, and when I say this np.argmax, it will tell what is the index of the value that is maximum. So np.argmax, we have to mention this ypred of 0. Okay, so ypred of 0 is nothing but, so this is my ypred 0 values, right? So out of this np.argmax will tell you which value is maximum. Let's run this, and let's also print this one. So print label for first image, so label for first test image. So this test image is nothing but this 7. Okay, so let's see our model has predicted this correctly. So print this one, 7. So this is the value predicted by our model, because we are taking this from ypred. So we are using our model to predict the value of this X test, and we are taking the first image alone. So this is the prediction probability that we got, and we got the value as 7. So what this 7 means is that, so the value in the index 7 is the maximum. So if you count, this is the index 0, this is 1, 2, 3, 4, this is for 5, 6, and 7. So this is my 7th index value. So we start from 0, this is my 7th value. So this is for 8 and 9. So what this 7 tells is the value in the index 7 is the maximum one. So that is your label. So this is how we can convert this prediction probability into the classes that we have using this argmax. So the role of this argmax is just to tell you the index of the maximum number in your array. So this is a numpy array, and it will tell you the index of the number which is the maximum compared to other values. So here we have done this for this ypred 0 alone, right? Now we are going to do this for all the 10,000 values that we have, so that you get instead of having this probability, you will get the label values. So converting, so it is the same thing. Okay, converting the prediction probability. Okay, so converting the prediction probability to class label for all test data points. Okay, right. So I'm going to create a variable as ypred labels. So ypred will basically contain the probability values, and ypred labels, we are converting them to this labels that we want, the format that we want. So ypred label is equal to np.argmax of I for I in ypred. So this is a simple way of creating a for loop. I'll tell you what this for loop does. Print ypred labels. Okay, right. So what we are doing here is, so we are creating a variable called as ypred labels, and np argmax of I for I in, sorry, so this should be I for I in ypred. So when the for loop runs for the first time, it will take the first value in this ypred. First value in this ypred is nothing but ypred of 0. So this is the first value. So this is the first value that I have in this ypred. So this will be my I. So my I will be ypred of 0. So that will be given to this I, which is my np.argmax. So basically this step happens each time the for loop runs. So when the for loop runs for the first time, the first image, the argmax will be applied. The second time, for the second image predictions, the argmax will be applied, and so on. So all this prediction probability will be converted into the labels. So let's run this one and see. Okay, so instead of having all this as labels, we have all the values here. So you can also compare how the values are there previously. Okay, so I'll show you. So print ypred. So this is how the values were before. So this is the prediction probability for my first image. This is the prediction probability for my second image, and so on. So this value, this numpy array, has been converted to the value 7. So it is just to tell the digit in that particular image is 7. So the second value, so this is my second entry, and so this happens when the for loop runs for the second time, and the np.argmax value is 2. That means the digit is recognized as 2, and so on. So we are just converting all this probability into classes like this, so that it is easier for us to understand. So I'll just delete this one. So this is our final predictions made by our model, whereas the true labels are my y test. So this y test, where is my y test? Okay, so this is my true values, true labels that is given in the data set, and this ypred labels are the ones predicted by my model. Okay, so I'll just mention that here. So y test is my true labels, or you can call this as ground truth. So all the things means the same. Okay, so true labels, and this ypred labels. Okay, so ypred labels represent my predicted labels. Okay, the values predicted by my neural network. Okay, so this is the test data prediction. So that is what this YPred labels is. Now we have already done this evaluation, right? So we have done this evaluation and we have seen that the accuracy score is 97.1%. There is another interesting evaluation that we can do, which is building the confusion matrix. Let's see how we can build this and how we can infer this confusion matrix. Okay, so I'll create a variable as confusion matrix. So let's just mention this like this. So if you remember, we have already imported this confusion matrix, right? So from tensorflow.math, so tensorflow has this math module, and within that we have this confusion matrix. So this is the function that we are going to use. I'll copy this and paste it here. So I'm going to build the confusion matrix for this predictions. So for this, we have to give the true labels as well as the predicted labels. So we know that true labels are whitest and the predicted labels are whitest, right? So first you have to mention the true labels. So whitest. So you know how you would calculate the accuracy score in ML. So it is just kind of the same thing. Whitest and YPred label. So first, so the first array should be your true values, and the second thing should be your predicted values. So I'll run this one. So this will build my confusion matrix. You can also print and see this. Okay. So print confusion matrix. Okay. So confusion matrix is not defined. So I misspelled it. Let's paste it here. Okay. So this is the confusion matrix that we have. Now it is hard to understand what these values mean in this format. So now what we can do is we can build a heat map. So we know that we have built heat map several times for this correlation matrix, right, in our regression problems and so on for the machine learning use cases. So similarly, you can build a heat map with all these values. Okay, so I'm going to, for this purpose, I will be using this matplotlib, and this is why we have imported the cbonds library. I think we have never used this pill library, right? Pillow library we haven't used, but it's okay. So now we are going to use the cbonds and matplotlib library. So I'm going to say plt.figure. So this is the basic figure, basic plot on which this heat map is going to be constructed. So here you have to mention what is the size you want for your plot. So this is like pretty simple things. So fixed size, which stands for what is the width and height you want for your plot. I'll mention it as 15 and 7. So with 15 and height as 7, and SNS. So SNS stands for the cbond library that we have imported, and cbond has this function called as heat map. So this is used for creating this heat maps. And here you have to mention from which we are going to convert this heat map. So as I've told you, we are going to convert this heat map from the confusion matrix that we have. So we are going to build this based on this values. Confusion matrix. So SNS.heatmap confusion matrix, and annote is nothing but the annotations for this plot. So annotations is equal to true and fmt. Okay, so fmt is equal to d. So d is nothing but I'm telling it that all the values should be in the form of integers. So that is the purpose of this. Like if you mention this fmt is equal to %2, that means like two decimal values will be given and so on. But in this case, all the values are integers, so we have to mention this fmt is equal to d, and cmap is equal to blue. Okay, so you shouldn't give blue, the value should be blue. So it is just to set the color, so you can have any colors that you want. So let's create the heat map in blue color here. And now I'm going to give this y label, plt.y label for my heat map. So let's have this true labels in this y label, true labels. I'll explain you what these things means. Just wait for a second. Let's name this x label as predicted labels. Okay, right. So yeah, so let's run this. I think everything is correct. Okay, let's try to understand what this particular heat map means. So if the value is 0 and if the value is small, it is basically represented in a light color, so a very light blue color. And if the value is large, if it is like 800 or if it is 900,000 and so on, it is represented in dark blue color. So this is why we mentioned the C map as blues. If you change it, it will kind of change. So the color of the heat map will change. So just a second. Okay. Now all the values in this diagonal represents the true predictions made by your model. Okay, so all these labels are my true labels and all these labels are predicted labels, the values predicted by my model. And now let's try to understand what these numbers mean. Okay, so if you see this first box, we have the true label. So you have to see the x-axis, sorry, the y-axis and the x-axis as well. So this is my x-axis where my predicted labels are there. So this is my y-axis where true labels are there. So what this 969 means is like 969 means is like how can I explain you this? So 969 zero images has been correctly predicted to zero. If you see this, the true label, so you have to see the vertical axis here, which is my y-axis, so that will give you the true label. So what this one means is like my true label is zero, but that one particular image, the model has predicted it as one. So you can see what is the value in this x-axis. Okay, and if you see here, so the true label is zero. Actually, the true label in the sense the digit present in that image is a zero, but it has been predicted as two. So that is what it means. Like zero means no images of zero has been predicted as three. So that is what the zero means. And what this three means is like there are three images, and all those three images represented zero, but our model has predicted it as eight. So this is how we can infer this confusion matrix. So it is just to tell you what is the correct predictions made by our model. So 969 means like 969 images of zero has been correctly predicted to zero. And if you see this 1122 images, one images has been correctly predicted to one, and so on. So all this diagonal means the correct predictions, and all other values represent my false predictions or wrong predictions. And if you want to find this, you just have to see the y-axis for the true labels and x-axis for the predicted labels, and so on. So this is very, very important for us in order to understand like which numbers has been predicted like what. So if you see this one, so it is like a large value, right? So what this means is like 24 9 images has been predicted as 4. So if you see this one, so you have to see y-axis. So true label is 3, so 23 images of 3 has been predicted wrongly as 5. So this is how you can infer this confusion matrix. So it is not easy to infer from this one, but we can kind of put this in an heat map and kind of visualize this like this. Okay, so I hope everyone understood until this part. So this is all about model evaluation. I think like this video is pretty large, but you can learn a lot of things here. And the next, so this is the last part of the video, which is to build the predictive system for our model. So using this trained neural network, we have to build a predictive system. Okay, so what this predictive system is, when you give a new image, so in this case we will give this 3 image. Okay, so when you give this image, the model should predict that it is 3. Okay, so you cannot use like different images of typed images or so on. So if you are training with MNIST images, it should, you have to predict with this image. So that is like obvious, right? So machine learning models and neural network models doesn't know what it is not trained on. So they only know about the data that they have seen. So like, so it is just like you cannot train your model on the numbers, and you cannot predict alphabets there, right? So similarly, like we have predicted with this MNIST data, so the image that you are going to predict should also be similar to the data that you have trained on. So that's the idea. So just a second. Okay, so now we are going to build this predictive system. So this is one of the interesting part of this code. So building a predictive system. So let's do this stepwise, and then we will consolidate all the codes of this predictive system. So first is I'm going to mention input image path. Okay, so input image is nothing but the image which you are going to predict. Okay, so input image path, I'll upload the image here. So I'm just going to this file. So this is where I'm going to import the image. If you're working on your PyCharm or Spider, you have to mention where that particular image has been located. So this is that 3 image MNIST digit.png. So this image has been loaded. So I'll copy the path of this image. Okay, and I'll paste it here. So this is the path of this image. So first I have to read this image and convert it to NumPy array. So we are going to do the processing that we have seen here. Okay, so previously the data has been present as already it has been present as a NumPy array, right? So it is 28 into 20 pixels and so on, whereas this image is not in that format. If you see this image, the dimension is 318 into 318. So we have to convert this dimension, and we have to read this to NumPy array, and few processing are there, and we will do this. So this is where we will use the things that we have seen here. And I'll create a variable as input image. So input image is equal to cv2 im read. Okay, so cv2 im read, and the first thing that you have to first argument it takes is input image path. Okay, so I'll just copy this. Okay, so input image path, it's not like you have to put it like this. So instead of creating this variable as input image path, you can also copy this path and you can paste it here. So both of them are the same thing, so I just wanted to do this in this way. Okay, so the thing is this imRead function cv2 dot, okay, so it's not underscore, it's cv2 dot imRead. So this function take this path of the image as the argument or the parameter. Okay, so I'll run this one. Okay, so now you can check the type of this input image. Type of input image. So it will tell it is a numpy array. So this image, this 3 image, so you can see this here. This 3 image has been converted to a numpy array. You can see the values here. So I'm going to print this one. So print input image. So this will how this numpy array will be. Okay, so 0 means black and 250 means white. So with this dots mean like there are several values in between. So I'll just remove this output. Okay, so now you can, again, as I've told you, you can print this image using the cv2 imshow function. So we have this cv2, so this is why we have imported this google collab.patches. If you're working in Spider, you can just use cv2.imshow. You don't have to import this one. So collab doesn't allow cv2.imshow function, as I've told you before, so that's the reason. So cv2 imshow, so this is just to display the image from this numpy array. cv2 underscore imshow input image. So this is the image that we have, right? And let's check what is the shape of this image. So this is an interesting thing. So now you can see that the image shape is 318 comma 318 and there is a 3 here. So this is the interesting aspect and the thing that you have to be clear about. So we can see this image is kind of black and white, but actually this has been read in the form of a RGB image. So this has been considered as a colored image. So this is a kind of a crucial thing here. So instead of reading this as a grayscale image, the cv2.imshow is reading this in the form of RGB image. Now the problem is we have trained the images. You can see if we take a single image, where it is. So I'll just go to the image that we have printed. So here, like if you take this two, the shape is 28 comma 28, whereas in this case the dimension is 318 into 318 and it is 3. So 3 means RGB channel. So we have to convert this image to a grayscale image and after that we have to resize it. Okay, so these things are there while building this predictive system. I'll create a variable as grayscale and now we are going to convert this image. Grayscale is equal to cv2.cvt color. Okay, so cvt color, and the parameters that we have to mention are input image comma cv2 dot color rgb to rgb. Okay, sorry, so see color underscore color rgb to grayscale, where it is. Okay, so this is the one. Okay, so what we are doing here is, so CVT is nothing but I'm going to convert the color. So what I'm going to convert this is this input image, this 3. So I'm going to convert this image from RGB to a grayscale image. So this is just basically color conversion. Okay, so let's run this one and now you can print this input image. Okay, so input image, so we have converted this to grayscale. So we have taken this input image, converted to a grayscale image and stored this in this particular variable. So I'll mention grayscale dot shape. Sorry, so this should be shape. Okay, now this 3 is not there, right? So what this means is like this RGB image is now has been converted to a grayscale image. So that's what we are doing here. And the next step is to resize the image. So this 318 comma 318 should be converted into 28 and 28 dimensional image. Okay, so input image resized, input image resize is equal to cv2 dot resize. Okay, so cv2.resize is the function that we have. So in the previous video we have seen that we can use this pillow library as well. So where it is, So we have imported this image module, and from this we have used this resize function, and this function is from cv2 library. So cv2 also has the same function. So cv2.resize, we have to mention what is the image that you are going to convert. So it is the grayscale image. Okay, so grayscale comma, so here you have to mention what is the dimension that you want to convert. So it's 28 comma 28. Okay, so what I'm doing here is I'm taking this grayscale image and I'm going to convert it to the dimension 28 comma 28, and I'm going to store this in this input image resize. Okay, so let's run this one, and now you can again check the shape of this input image resized one. Okay, so input image resize dot shape. So previously it had 318 comma 318 as your size, and now it has been converted into 28 comma 28, because this is the size that is compatible with the neural network that we have built. So you can see here, so we have mentioned that the input shape is 28 comma 28. So the model expects the image to be in this particular dimension, in this shape. So that's the reason we are doing this particular step. Okay, so you can also show this image. I'll also use the cv2 function again, cv2.imshow. Now let's see how the image is looking like. cv2 underscore imshow, and now I'm going to show this input image resized. Yeah, so previously the dimension of the image is like this, and now it has been like shrunk to this. So this is the dimension before, so 28 comma 20. So this is a 28 comma 28 pixel image. Okay, so next step is like um so next part is the other thing that we did is scale the image. So we have did this normalization part, right, where it is this 25. Yeah, so this 255. So we have converted all the image. So previously the values between 0 and 255, right? Now it has been converted to 0, between values are between 0 and 1. So how we did that is by dividing all the value by 255, right? So we have to do that here as well. So this is like very, very important. So what are all the things that you did for your training data should be done for this as well. So this part will be I'll just take this as input image resize itself. So I'm not changing the name. So input image resize is equal to input image resize divided by 255. Okay, so now all the values will be scaled, and all the values will be between 0 and 1. Okay, and there is another important step. So before predicting, there is only one more step that is pending here, which is to reshape. Okay, so image reshape is equal to np dot reshape input image resized. I'll explain you what is the necessity of this comma. And here I have to mention 1 comma 28 comma 28. Okay, so if you have seen my other videos, my previous machine learning use cases videos, when we are building a predictive system, first we will take all the values and we will kind of reshape it to 1 comma minus 1. So the reason for doing this is to tell the machine learning model that I am predicting the label for only one data point, right? So we have done this np dot reshape 1 comma minus 1. So we call that as input data reshape. Similarly, we have to tell the neural network that I am going to predict the value for only one image. So I'm not giving you 10,000 images or 60,000 images, and I'm giving you only one image, and you have to predict the label for this one image alone. So that is what we do using this reshape. So if you have some doubts, you can copy this input image resize, and you can check this shape, not type. So this type is nothing but numpy array. So this is not in the form of images. So cv2 I am sure will basically convert the numpy array to an image. So this is actually in the form of a numpy array. So you can see this. Now we are taking this numpy array and we are reshaping it. Okay, so it is just similar to that 1 comma minus 1. So we have to understand why we are giving this particular value. So I'm creating a new variable called as image reshape, and I'm using this numpy, np numpy. So we have the same reshape function, and we have to pass the image that we are reshaping. So this is the image that I have after resizing and after scaling down the values. And the second argument that I pass is 1 comma 28 comma 28. So what this means is I am going to predict the value for only one image, and the dimension of this image is 28 comma 28. So that's what we are doing here. So there is like nothing complicated in this. So I'm taking one image 28 comma 28. If if I'm, let's say, predicting for 10 images, I have to mention that 10 comma 28 comma 28. So here I'm taking only one image, which is 3, right? And another thing, if you are working with RGB images completely, so let's say that you are training your neural network with RGB images and you're predicting for RGB images, in this case you have to include a 3 here. So this is a grayscale image, so we don't have to include anything here. So this is a very important step. So if you don't do this, so your prediction will throw error. Okay, so that's the thing. And let's run this one. And again, so here as well, if you're, I think I have mentioned this already, so if you're training your neural network with RGB image, so along with this image dimension you have to mention as 3. So here it is grayscale image, so it is not necessary here. And yeah, so it is this part is for reshaping. So I'll run this one, and now we can use our model to predict. Okay, so I'll create this variable as input prediction. So input prediction is equal to model dot predict uh, image reshape. So this is the final array, the processed image that we are going to feed. And let's also print this prediction. So print input prediction. So we are predicting the value for one image, and we are printing it. Let's see. Okay, so we have successfully printed it. So this is the value. So we know that this is the probability value, right, for each classes. Now let's again use this np.argmax in order to find the label. So I'll name this as input pred label. So it is nothing but input prediction label is equal to np.argmax of input prediction. So I'm taking this input prediction array and I'm going to find which is the highest value. So that's the idea. So let's run this one. And now let's print this input data prediction, sorry, input pred label. So now let's see what is the model is predicting. Yeah, so now the model has predicted correctly that this image represents 3. So we have successfully printed it. So if you see here, this is for 0, this is for 1, 2, 3. So this is the maximum value that we have, right? So the model has predicted correctly. So this is nothing but plus 1. So all the other values are e power minus 3, minus 8, and so on. So the model has correctly predicted that the value is 3. So we are predicting this from model. So this model is nothing but the neural network that we have built. So this is how you can build a predictive system. I'll just combine all this code so that it is in the in a single shell. So the same, so I'll just put a text here. So we are not going to do anything new. So predictive system, so I'm just going to combine all this code for this predictive system. And the first thing is input image path, right? So input image path, so this is the first thing that I want. Yeah, this to itself here. So input image path. And now, so instead of hard coding this, instead of mentioning the path here itself, I'm going to create an input function. So input of path of the image to be predicted. Okay, let's see how this kind of works. Path of the image to be predicted. And then, so once we give this prediction, so what happens is like this will show this particular statement, and the user has to specify the path of the image, and after that that will be loaded. So you can give different paths or different images each time you run. So that's the idea. So input image cv2.imread input image path. And the next thing is, let's also show the image. Okay, so once the user has mentioned the path, let's also show the image that is present there. Put image path, so show the image. And the next step is to convert the images to grayscale image, right? So this is important. Grayscale cv2.cvt color, and then input image resize. So all the things should be done. So this is my resizing thing. Okay, input image resize. And the next thing that I have to do is reshape it. Sorry, so we have to do this as well, right? So we have to scale the values down. So 255. And the next thing will be reshaping. So reshape all the values. So this is for predicting only one image. And this is my input prediction. So we don't have to print this prediction. So we just have to find the label. So I'll just remove this. Finally, my input prediction label. Okay, so input pred label, which is the np.argmax of input prediction. And finally, we can print that the handwritten images. So the handwritten digit is recognized as, we can put this input pred label. Okay, so what we are basically doing here is, so first when this line executes, so it will ask the user for the path of the image file. After that, that image will be read using the cv2.imread function into the variable called as input image, and we will also display the image to the user itself. After that, we will convert the image to a grayscale image, and then we have to resize the image to the default value that we are taking, which is 28,28. And after that, we have to scale the values down so that the values are between 0 and 1 by dividing it by 255. And then we are resizing the image. As I've told you, we have to tell the neural network that I'm not predicting for 10 labels, I'm predicting for one label. And then we are using this model.predict. So this is for predicting the values, and once we have this prediction, we know that it will be in the form of probability. So we have to convert this using this np.rmax, and finally it will print your labels. Let's see how this works. So I'll run this one. So here you have to give the path of the image file which you want to predict. Okay, so I'll go to the files, I copy the path of the image that I want to predict, and I'll paste it here. Let's see how this is working. So once I give the path of the image, you can see here. So I have given the path of this image here. So this code will display the image that has been given, and it will give this statement that the handwritten digit is recognized as 3. So in this path, so when you run this, instead of, you can have multiple images. I mean, like, you cannot give multiple images at once, but you can give different images each time you run this. Okay, so you can take another MNIST image and you can give this value. So it will display the image and show the result. So the process that are happening are, first it should read the image, it should convert it to grayscale, then resize it and divide it by 255, then reshape the image and make the prediction and print the print statement. So that's it for this video. And I know that this is a very long video, but this will be like very useful for you. Moving on to the image recognition projects that we have. I'll just give a quick recap so that you kind of remember all the things that we have done. So first part is just importing all the necessary libraries. So we have NumPy, Matplotlib, Seabounds, and so on. And we have this deep learning libraries, TensorFlow, Keras, and so on. And confusion metrics for building our confusion metrics and displaying it in heat map. So we know that the data is in the form of MNIST. So but the thing is, it won't be in this format every time. So the actual data that we have will be in folders. So you will be given a folder, and that particular folder will contain 10,000 images or 20,000 images. So you have to do all the processing, and then you have to convert it to test image and train image and so on. But we will work on that later. So here we have the dataset in this keras.datasets itself in that module. So we have loaded the dataset, and we have got this training data, and test data separately. And we have seen that there are 60,000 training images and 10,000 test images, and this is the image dimension. And we know that all the images are in the form of grayscale. So we have printed and seen what are all the values, and we have taken like one image and we have printed it, and we have also seen the corresponding label. So all the values are correct. And we have seen that this is the count of the labels we have for training images and test images, and we have seen what are all the unique labels that we have, and we have found that there are 10 labels, right? And then we have scaled the values so that the values are between 0 to 1. So before we had the values between 0 to 250, now we have the values between 0 and 1. So that is the next step. And later we have seen so how the values has been changed and so on. So this is not that much important. So this is the important part, which is building the neural network. So we have built a very simple neural network where you have to create this flatten layer, and you have mentioned the input shape. So input shape is nothing but the dimension of the image. And then we have built some layers for this neural network with 50 neurons, and we have mentioned the activation function as redo, and the final output layer. So this is my output layer with 10 neurons because we have 10 classes 0 to 9. And then we have compiled with Adam optimizer, and the loss function as sparse categorical cross entropy, and metrics as accuracy. So that's why you are getting this accuracy value here. And we have fitted, so this is the training of neural network, and we have trained it with 10 epochs, and we have found that the training data accuracy is 99.9, which is almost 99% accuracy. And then we have calculated the test data accuracy. And the next part is taking the first image of the test data, and we are passing it to our model, and we are asking it to predict, and we are converting this probability into label using this np.rmax. So it is predicted correctly, and we are doing this for all the values that we have, and this is the final labels that we are getting. And using this, we are building the confusion matrix, and we are visualizing this to see how many correct predictions are there and how many wrong predictions are there for each classes. And later, the important part of building a predictive system, where we have done all these things. So when you give the path of the image, so it will first show the image to the user, and it will read the image in the form of NumPy array, convert it to grayscale, resize it, divide it by 255, reshape it, and finally make the predictions using neural network and apply Rmax in order to give the result. So I hope everyone has everyone understood all the things that we have covered in this video. So please practice all the things. So this is a very interesting use case. So try to do all the things. It's okay if you kind of just looking at the code and you're practicing it by yourself, that's not an issue. So you will get better by practicing. So I suggest that you have to practice all the codes that has been done in this particular video. And yeah, so that's it for learning. Transfer learning is a very important concept in deep learning where we use pre-trained models in order to build our use cases. So in this case, we will be using a pre-trained model called as MobileNet V2, where we will train that particular model on images of dogs and cats, and in turn this model can tell you whether an image represents a dog or a cat. Okay, so this is what we are going to discuss in this particular video. So first of all, let's try to understand what this transfer learning is, and later I'll explain you what is the workflow that we are going to follow for this use case, and later on we can move on to the hands-on part where we will build this system using Python. So first of all, let's try to understand what this transfer learning is. So transfer learning is again a deep learning technique where we use a pre-trained model. So this pre-trained model is trained for one task and can be retrained for a similar task when you have a smaller data set. Okay, so this is what transfer learning is. So it is all about using a pre-trained model. So when I say pre-trained model, so this model has been trained already on a particular data set. So it has some weights on it. And later we use this model and we train this with a different data set, but the only difference is that you can also have a smaller data set. So when you train a model from scratch, when you have a smaller data set, you cannot like achieve good accuracies. So this is like other reason why we go for transfer learning as well. So it gives you higher accuracies compared to training model from scratch. Like in most of the cases you can like achieve like good accuracies. And the thing is like it is trained on a data set. Again, it should be used for a similar task. So you cannot take a NLP model and like use it for image recognitions and things like that. So it should be a similar task. Only difference is that you are training it on a bit different data. So say for example, if you have built a model and trained it on some image recognition task, so you can take that model, train it with some different data set, which is again a image recognition. So in this use case and in this video, we will be taking the MobileNet V2 model and we will be training that with images of dogs and cats, as I've told you. Okay, so this is what we are going to do. And again, when we say transfer learning, there are like different and famous transfer learning models like VGG16. So all these are like a few examples of pre-trained models that are available. So we have this VGG16, which is a very famous image recognition model, and then we have this ResNet 50, Inception V3, and so on. So in this video, we will be using this MobileNet V2, which is more of a lightweight model. Okay, and we also have this YOLO, which stands for you only look once. So it is like mainly used for object detection tasks and so on. So similarly, we have like these pre-trained models which we can access. Okay, so this all about transfer learning. And now let's try to understand the workflow that we will be following. So as we know that the first step is to collect the appropriate data. So in this case, we need images of dogs and cats, and for that we'll be using Kaggle API in order to extract the data from Kaggle. So that is the first step. So once you have this data, so we know that the next step is this data processing. So in this, we will be doing some image, processing techniques like we have to reshape these images and we have to like convert them into numpy arrays and so on. So this is like the major step in this use case. So once you do all these image processing tasks, we can then split this data into training data and test data. So the end result is that you have like set of dog images and the respective labels, and then you have cat images and the respective labels for those cat images. And then we will split this data into training data and test data. And we know that we use this training data to train our model and test data in order to evaluate our model. And then you feed this data to a pre-trained MobileNet model. So again, you can use different models as well, but in this case, we'll be using this MobileNet V2 model. So once we train this with a smaller data set that we have, we will be, having a MobileNet model that is like trained on top of this dog versus cat data set. And we will also like evaluate this model with the test data that we have. And later, when you feed a dog image or a cat image, it can tell you what particular thing that is. So it will tell you whether it is a dog or a cat. So this is what we will be doing. Okay, so I hope like everyone is clear until this part. And now let's move on to the hands-on part. So we will be doing all this coding in Google Collaboratory. So I have my Google Collaboratory setup open here. So just go to Google and search like dog versus cat data set. So let me just type it here. So dog versus cat data set Kaggle. So this will take you to this site. So this is the dog versus cat competition. So this is the data set that we'll be using. So here you can go to this data, so you can just go through it in order to understand about this data and like what are all the tasks that you can do. So go to this data, and here you can find this API. So this is the API that we have, and we will use this API in order to extract this data set to our Google Colab environment. So you can see the size of this data set here. So I'll go here. So this pip install Kaggle will install the Kaggle library, but it will already be pre-installed in this Google Colab environment. So next is we have to get this like kaggle.json file. So that you can find in your accounts. So here you can see your account details. So there, go to your account. So there you will see this create new API token. So once you click this, a file will be downloaded, which is nothing but kaggle.json, which contains your account credentials. So then you need to upload that kaggle.json file into your collab environment. So I'll go to this files, and I'll try to upload this file. So it is in my in my desktop. I have a folder called as kaggle json file. So this is the file that I have downloaded. So similarly, download your file and make sure you have like verified your account with your phone number or your email address. So then only like this will work. So then I'll like run this. So this will stay common. So we are just basically configuring the path of this kaggle.json, right? So you can just copy this code snippet and you can like use it. So I'll run this cell, and now we can import this dataset from Kaggle. So I'll just create a text here, and I'll name this as importing the dog versus cat dataset. That's it, from Kaggle. Okay. So here we need to give the Kaggle API to import the data. So that we have seen here, right? So we have to go to this data. Just a second. So there you will find this API. So you can click this copy API command, and now we can paste it here. So before that, we have to include an exclamatory mark and then paste your API command. So now I'll run this. So this will download this dog versus cat dataset into my collab environment, and this is the data that we will be using, which contains several thousand images of dogs and cats. So it will take few seconds, and now we so this will basically download this data set in a zip file. Okay, so all these three files will be in a compressed zip file, and now we have to extract that. Okay, so this has like downloaded this file. So you can see this here. So this is dogs versus cats.zip. So if you wanted to print that files at here, you can just mention ls, which basically list all the files in your directory. So we have this dogs versus cats.zip. So this is the data set that we'll be working on. Now let's extract this file. So I'll mention this as extracting the compressed file, which is basically the data set. Okay, now there is a library called a zip file. So from this zip file library, I'll import this function called as same zip file. So here this Z and F should be in caps. And now we have to give the path of this data set. So data set is equal to, so it's basically the path. So you can either put this docs versus cats.zip, or you can also paste the full path. So both will work, because this will just take the current directory that you're in. So the best thing that you can do is like copy this path always. So I'll just replace this. So again, both of this will work. So I'll paste the entire path, and now I'll say with this zip file, in this bracket I have to say dataset comma r. So we are reading this data set, and let's read this as a zip. So again, this is a variable, you can give any name, and now I am going to say zip dot extract all. So this will extract all the files that is present in this zip file. And now once this is extracted, I'm going to print a statement. So I'm just going to say the data set is extracted. So let's put this in quotes. Okay. So first we need to import this function from zip file, then mention the path. Then we are like opening this file and reading this as a zip, and then we are extracting this. So these are like the basic steps that we do. So this will like do this extraction. And if you look at this data, we have this three files. So one is the sample submission.csv. So this is basically to submit the predictions that is made. So we don't need the sample submission and this test.zip, but we are interested in this train.zip file. So we need to do the same extraction for this train.zip. So I'll go to this files. You can see that here. So we have this test sample submission.csv, test one, and train zip, right? So now I have to do the same thing, this extraction process for this train.zip. So I'll copy this code, and now I'll replace this dogs versus cats.zip with this train.zip. So I'll copy this path and replace it here. Okay, so now let's extract this. So this will basically give you a folder that has images of dogs and cats, which are JPG files or PNG files. So we can like analyze that later. Yeah, so this has extracted the file. So you can see a folder called as train. So you can like expand this, but this will take few minutes because like there are several thousand images, so it will like take few seconds. And now in order to count the files that are there in this directory, you can like do something like this. So I'll import OS library, and now we are going to count the number of files there are. So it's taking sometimes. I'll just like close this. Let's like see this here as well. So counting the number of files in train folder. So this train folder is something that we have imported, right? So from train folder, and now I have to create like two things. So we have to create this path and directories and files. So here I can say next. So these are like the conventional code that we use. So there is like nothing complicated in it. So I'll use this os.walk, and here I have to give the path of this train folder. So I'll copy the path. Let's paste it here, and I'll create another variable called as file count. So this will basically create like this path directories and so on, and this will create this list. So this files is basically the list that contains like all those file names. I'll say file count. The file count is equal to, I'm finding this length of files. So it will tell you like how many files are there in this particular directory. And later we can also print like number of images. The number of images in this train directory, and this is equal to, so we can print this here. So let's say file count. So it says like there are totally 25,000 images. Okay, so again we won't be using all these images because we are using a pre-trained model. So I'll just take a small sample of this, and we can like train our pre-trained model. Okay, and now let's try to print the image, like name of this image files. So I'll create a text and name this as printing the name of images. So I'll create a variable called as file names, which is basically a list, and I'm going to use this OS. So we have imported this OS directory, OS library, right? I'm going to say OS dot list dir. So this will like list all the files in a directory, and it will basically create a Python list. And here I'll paste this path, which is content train, and I'll print this file names. Okay, sorry, so we have to include an underscore here. So these are the name of the files that are present here in this string. Okay, and as you can see, we have dog images as well as cat images. So in some cases you will receive a data set where these two classes are present in separate folder, but in this case we can see both the class of images, that is dog and cat, are present in the same folder. Okay, so we have to like do some processing within that itself. So these are the files that are in this like particular folder. So now let's do this processing. So the next step is, let's try to import all the required libraries that we need. So this will be mm, importing the dependencies. Okay, So first let me import numpy library as np, and I'm going to import from pill. Let's import image. So pillow is a library which is like used a lot in this image processing tasks. So I'll import that as well. And next I'll import matplotlib dot pyplot as plt. So we need this again to do some image processing to display the images that we have and so on. And then from the same matplotlib library, let's import a different module which is matplotlib dot image. So we can import this as mpimg. Again, this is the convention that we use for this module. And then we will import train test split from sklearn dot model selection. From this we are going to import train test split. Okay, so from sklearn.model selection train test bed, and finally I'm going to import from google.collab.patches import cv2 I am show. Okay, so this is basically we have a function called as imshow in cv2 library, which is opencv. So that cv2.imshow won't work in Google Colab environment. So as an alternative, we have this cv2 underscore imshow in this google.colab.patches, which basically do the same thing. So it will like display the image. So that is the purpose. So let's like run this cell to import all the libraries. And apart from this, we need this TensorFlow keras in order to build our model. So that we will import later. So now the next thing that we are going to do is like display the images. Okay, so we have this dog image, cat image, and so on, right? So we are going to display these images. So I'll create a text here and say displaying the images of dog and cats. So we will like take this particular files and we will like display this using this like matplotlib library. So first thing we are going to display dog image. Okay, so here I'll create a variable as img, and now I'm going to say mpimg, which is our matplotlib dot image, so which we have imported here. So mpimg dot imread, so this will read the image file, and the image file that I'm going to read is this some of these files. So I'll go to this files, so you can try opening this. I'll copy the path and paste it here. And after this, so we know that these are all the name of the files that is present in this train, right? So I can just put this name here. So I'll just take this dog 8298 dot jpg. Okay, so this is these files we know that are present in this train folder, right? So I'll paste it here. So this will read this file in this variable called as img, and now we can create another variable called as img plot. So this is to display the images in this like output cell itself. So here I'm going to say plt.show img, and then I can like think we can do this as plt.show itself. Let's see whether it is working. So first we are reading this through this mpimg.imread, and we are like displaying this through this matplotlib.pyplot as plt. So let's run this. Okay, so seems we have to load this to a variable. So I'll just say this as img plot img plt is equal to plt dot show of this image, and then we can say plt dot show. Let's run this. And the truth value of it more is ambiguous, so seems there is an error. So let me just check. So mpimg plt dot okay, so this should be plt dot imshow. So as we can see here, this will display the images of the dog that we have. So similarly, you can take a different file and you can just replace this here. So that will like display the images of the dog or cat that you're working on. And now let's try to do the same thing, but let's try to display the image of a cat. Okay, so So here, let's copy the name of some cat file. So here we have cat.454352. So I'll copy this particular file name and let's paste it here. So this should be a cat image, right? So let's see. Okay, here you can see this. So similarly, we have images of dogs and cats. So I'll just replace this with cat image. Okay. So the main thing that we have to note here is we have 25,000 images that we know, but all these images are of different shapes and size. So this is, you can see, the x-axis size is 450 or 500 or something. So in this case it's like 400 or something. So all the images are of like different size. So this is a very important thing to note, because while you're training your neural network, all the images should be of same size. And for our case, we are going to use the model called as this mobilenet v2, and it kind of needs the images in a specific shape, which is like 224 into 224 pixels. So that means like x-axis length should be 224 pixels and this y-axis length should be 224 pixels. So that is one main thing, and we have to take all these images and resize all these images to the said pixel. So then only the model can like read this data. So that is one thing. And if you want, you can also convert this RGB images. So we have already discussed in a different video on what these RGB images are, basically the colored images. So if you want, you can take this colored image as well. If not, you can convert these images to grayscale images, which are black and white images. So these images will be smaller in size, so your training will take place in a short period of time. So that is like the other processing that we can do, but in this case we will just go with the RGB images itself. So these are some of the data processing or this image processing tasks that we do. Okay, so the main thing is to resize all the images to a common size, so common pixel value. That is the other thing. Okay, so next what we can do is like resize all these images as I've said. So I'll create a text file. So similarly, you can like print and see like different images of this dogs and cats using this particular file name. So now I'll create another thing as resizing mm, all the images. Now, in this case, we can directly resize this images, store it in some NumPy arrays, and then like train your model from it and so on. But in this case, what I'm going to do is create a different directory, resize all these images, and put those images there. Okay, so that is what I'm going to do in this case. So because let's say I want a copy of this original images as well as the resized images. So in this case, you can follow this particular step where we save this resized images. And as I've told you, we are using a transfer learning technique where we use pre-trained models. So I'm going to reduce the number of images that we need. So we totally add like 25,000 images, right? So here you can see. So I'm not going to, so it's probably like there are 12,500 cat images and 12,500 dog images. So you can like see this somewhere here. I think it is mentioned here. So, so let me just go to this overview. Okay, so I think here it is. So the training contains 25,000 images of dogs and cats. Not sure whether some information are there. Okay, so we can also, calculate this by, a simple for loop. Let's do that. So I'll create a code cell here. So now what I'm going to do is, we know that this file names is a list that contain the name of all the images, right? So now I'm going to take this file, iterate through a for loop, and find like how many dog images and how many cat images are there. So we know that all the dog images are like named with this dog dot some number, and cat images are named with this like cat dot some number, right? So here I'll create a for loop. So I'll just create the same list here, so that it's like clear for you, so that it doesn't like confuse like once you're going through this code. So we have this file name. So this is basically a list that contain all the images of these dogs and cats. So I'm going to say for like file, or let me just say this as for image file in file names. So we are iterating this list which contain the image, like the name of the files of dogs and cats. So this image file is nothing but a list. So let's just print this like 5 times. So let's say for in range length of file names. I'm going to say print this file name. Sorry, so it should so file names, which is the list, and we can like mention the index. So this will like print the name. So I'm going to print the first 5 files. So for I in range, okay. So let's not put this as I in range. So let's put this as for I in range of 5. So this for loop will run for like 5 times. So here we can say, I think we can run this. So this will print the first 5 files there are. Now this will like give this, right? So these are basically string values. And now what I'm going to do is like create another variable called as name. So name is equal to file names of file. So each time this for loop runs, this will take the name will take this names. Okay, and now I'm going to print the first 3 letters. So name of 0 to 3. Yeah, so this will give us this dog, cat. So the basically the first 3 letters. Now we can count this using this. So here I'll say this file name. Again, you don't have to like run this every time, this file name, so it will be the same, but I'll just create this list here. Now I'm going to say for image file in file names. So each time this image file will take the name of the file that we have, and now I'm going to create a variable called as name. So name is equal to, so let's say image file of 0 to 3. So the first 3 letters, and if this first 3 letters, so if this name is equal to dog, so I'm going to create a count. So let's create a counter. So I'll call this as dog image count as dog count is equal to 0. So let's initiate it with 0, and let's say cat count is equal to 0. So we are basically doing this to calculate like how many dog images are there and how many cat images are there. So nothing like complicated here. So when the name is dog, so I'm going to say dog count plus is equal to 1. So I'm just incrementing it with 1. So if every time there is the name of the file starts with this dog, so this dog will be incremented by a value of 1. And then we can include a else condition where we know that the name should be like cat. So here I'll say cat count plus equal to 1. Okay, and finally we can just print this. So print number of dog images is equal to dog count. And similarly, we can do this for this cat images as well. So this is number of cat images. Okay, so I'll run this. So see, as we can see, so it basically contains equal number of dog images and equal number of cat images. But we are not going to take all this like 25,000 images. So we are just going to take like 2,000 or 3,000 images. And then like take those images and resize those images alone, because we are not going to use all these images, so it doesn't make sense of like taking all these images and resizing it. So first I'll create a directory. So creating a directory for these resized images. Okay, so here you can just create a new directory as like this new folder or something. So instead you can use this os library. So I'll just say os.mkdir. So this is nothing but make directory. So here I'll say this path, which is this content. Okay, so for like it should be /content. So I'll say /content, and again slash, I'll name this to image resized. Okay, so this is the folder where we are going to store like all the resized images. So I'll run this. So now this will create a directory called as image resized here. right? So this is basically a empty directory now, and now we are going to save all the resized images in this particular directory. So that will be the next step. So I'll create another variable as original directory, or let's name this as original folder, which is the train folder which contains all the images with that original shape. So I'll copy this path of this train, paste it here, and then I'll create another variable as resized folder. So here let's paste the path of this image resized path. So let's copy the path, paste it here. Okay. Now we know that like we have to iterate through this files name list, right? So it is basically a list that contains the name of the files. So similarly, we are just going to iterate only the first 2000 images. So here we have like iterated through the entire thing and found that totally there are like 25,000 images. But I'm not going to do that. So I'm just going to run this for loop for like 2000 times, so that it will extract me only 2000 images. So I'll say for I in range of 2000. So this for loop will run like 2000 times, and each time I have to take a file. Hmm. I'll say file name, just a file name is equal to os dot list directory. So this is, we have already seen this, so this will like list all the files in a folder. So what I'm going to list is this original folder, this content train. So this will like do nothing, just do what we have like done here. So this will create a list that contains like all the names of the image files. So once I create this, I'll give this as image path. So image path is equal to this original folder plus file name. Okay, so and again, so the main thing here is we have to include a forward slash here as well. So let me tell you what this does. So first, this is nothing but the original folder, right? So original folder is the path of the train folder. But what we are interested in is finding the path of the image, which is nothing but this one. So content train and this image name. So here it is like content train doc point 8298, all these things, right? So this is what this image path will do. So first it will take this original folder and concatenate the name of the file. Okay, so that is what we are doing, and so it should be original folder of I, original folder I, because like each time this for loop runs, it will take one file. Okay, so the let's try to understand this. So this for loop is running for the first time, so this file name is equal to os.list directory of 5. That means os list directory of 0. So this will take this image name, which is doc.12067.jpg, and now we will like add these two things. So that will be stored, file name stored here, and this will concatenate these two things, so this path name and this image name. So the second time this for loop runs, so it will take the name of the second file, which is cat.11189.jpg. So that will be stored in this file name, and then we are like concatenating it with original folder plus file name. So we are just doing this in order to give the path of all these individual files. So once you have this path, now we can resize it. So I'll create a variable as image img, and I'm going to use this image.open. So this image.open is nothing but the function that we have in pillows library, so which we have like imported here. So from pill, like we are importing this image, so from this we can like open this image and resize it. So image.open, so I'll copy this image path and paste it here. Okay. So later I'll say image is equal to img dot resize. So again, as I've told you, MobileNet expects the images to be in the size like 224 comma 224, and this is like the like pixel range like that most of the pre-trained model has. Okay, so you have to say image dot resize, open parenthesis, and within another parenthesis mention 224 comma 224. So this is the it's kind of the horizontal number of pixel and vertical pixels that we have, and then I can say image is equal to img dot convert RGB. Okay, and now I'll say new image path. So this new image path is equal to this resized folder. So we have to save this in this new folder that we have created, right? So resized folder plus file name. Okay, later we can say, so we are just saving that with the same file name. So the only difference is that the directory changes, so it will be saved in this image resized. So new image path, and then I'll say img dot save of new image path. So yeah, so that is also, let's try to understand this for loop. So first we are creating two variables with the name of the original folder, which contain like all the original images which are not resized, and then we are creating a directory here which is called as image resize, which will contain all the images that we are going to resize. And now I'm creating a for loop that will run for 2000 times. So each time this for loop runs, this file name variable takes the name of each individual image file. So that is what we have mentioned this. So I is basically the index of this list, which gives you the name of the file. Then we are like creating this variable called this image path, where we are concatenating this path and this file name. So that's what I have mentioned here. So folder, original folder plus file name. So this is basically the individual path that we take. So each time the for loop runs, so image path is the full path of a image. So we take that image, pass that to this image dot open, which will like read this file, and then we are resizing this using this resize. So again, this resize is present within this pillow library. So we are opening this image using this image dot open, then resizing it to size of 224 comma 224. So if you wanted to convert this image to a size of 200 comma 200, you can like mention it here. And then image dot rgb convert, which basically tells you that colored image. So this is again a mandatory thing. And then once you have resized this, we have to save this image, right? So I'm giving this new image path, which is nothing but this resized folder. So make sure you are including this forward slash at this end, otherwise it won't work. And then we are like saving this image. So let's run this. So this will probably take a minute or two, because like as we have like several images, it takes some time. So here we are like resizing 2000 images. So once we resize this image, let's try to like display the images and see whether all the images are of same shape. So like what we have did here, so I'll copy this cell, so let that code run. I'll paste it here. So this is for resized images of dogs and cats. So display dog image, so I'll name this as display resized dog image, and here it should be this path. This image resized path is where our new files will be stored. So I'll copy this and paste it here. Okay, so this cell like completed running. So all the 2000 files will be resized, and it will be stored here in this image resize. So now let's print this. So here you can see, so the size is like almost it's 224, and it is like 224 here. Previously it was like something around 450 and 400 or something, right? So this is how you can like resize this images. And let's try to do the same thing for this cat image as well. So previously we know that these two images are of different shapes or size, so basically the dimensions. And now let's try to do this for the resized cat image. Resized cat image. And now I'll just copy this image resized. So this will also contain the image in the dimension of 224 comma 224. Let's try this. See, so it's like 224 and 224. So both these images are of like same dimensions. So like all the files, all the image files in this image resize will contain the images in their resized formats. Okay, so you can like again display different images, and you can like recheck here. So the next thing that we have to do here is like create labels for this images. So we have this dog image and cat image, right? So I'm going to create like labels for this, and you cannot like randomly create like zeros and ones here. So let's say that we are going to label this cats as a zero and this dogs as zero. So how I'm going to create this labels is go through this image resized and check whether the image starts with dog. If the image file start with dog, so I'll label it as one. If the name starts with cat, I'll label it as zero. So that's what we are going to do. So this is for creating the label. So I'll create a text here and say as uh, creating labels for resized images of dogs and cats. Okay, I'll just put this in bold, and like I'll take all the cat images and label them to 0, and in the case of dog, let's label them to 1. Okay, so you can like change this to vice versa, so you can label cats to 1 and dogs as 0, so that will like work as well. So how we are going to do this is create a for loop that will like iterate through this image resist folder. So if the file name starts with dog, we have to label it as 1. If the file name start with cat, we have to label this as 0. So similarly, like what we have done here, so in this case, so we have uh, like iterated this for loop through this list and check whether the first three letters is dog or a cat, right? So here we have just found the count of dogs and cats. So similarly we are just going to create the labels as well. So I'll just mention a comment as creating a for loop to assign labels for these images. Okay, so I'll create a list called as labels, and this is a empty list, so this is where we will like append all the labels. And here I'll say for I in range 2000, so because we know that we totally have 2000 images, and I'm going to say file name. It's basically the same that we have did here, so file name is equal to names of I. So again I'll create a list like this. Okay, so let's create a list. So the main thing is you shouldn't like mention train, but mention this image resized path. I'll copy this path. Okay, so file names os.list directory labels for I in range 2000, and so file names is file names, so it should be file names. So this is what I have mentioned here. So each time the for loop runs, so this file name will take the names of that individual file, and then I'll create this as label. So label is equal to file name of 0 is to 3, which basically tells you whether it is a dog or cat. So like what we have did here, so we are just checking whether it is a dog or a cat, so we are just slicing the string. Okay, so label is equal to this file name, and then now we can introduce a if condition. So if this label is equal to dog, in that case we can say labels. So labels, this labels is nothing but this list. Okay, so or else I'll just, yeah, so let it be labeled, so I can say labels dot append 1, and now I'll include a else condition and say labels dot append 0. Okay, now let's try to understand like what happening here. First we have like did this like several times. So I'm creating a variable which is basically a list, so it contains a list of all the names of the images of these dogs and cats. So once I have this, uh, I'm creating another empty list called as labels. So this is where I'm going to store like all the labels for I in range 2000. So this for loop runs like 2000 times. So for the first time, I will take the value of 0, then 1, 2, 3, and so on. So this will go on until like 1999, and each time I mention this file names of file. So file name will take the name of a file, so each individual file, and I'm creating a variable called as label. So this label is nothing but the first three letters of that file. Say for example, when we run this for loop for the first time, so we take this file name and then slice this first three letters. Okay, so when it is a dog file name, so this will extract this dog. When it is a cat file, it will like again slice the first three values, which is this cat. Okay, so I'll also try to print this as well. So okay, so let's do one thing. So we are just slicing it. So if that sliced string is dog, we will append 1. If it is not, we will append 0. So this basically tells you whether it is a dog or cat. So let's run this, and now I'll just print the first 5 files here. So file names of 0 to 5, print file names. 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 0 to 5, print file names So we have this dog, cat, and all the things and so on. So if you go here, so 12067, it's probably the same order, or the order may change, but like we are not sure about that. So we have this file names, image resized. Now you can also like check the number of files. Okay, so I'll remove this and say length of file. So totally there would be like 2000 images, right? Now I'll print this labels. So it should be done here. So the only difference is that now we are finding this for labels. So as we can see, if it is a dog, the label is 1. If it is a cat, the label is 0. So this is what we have done here. So we take each file name, slice the first 3 letters. So if those 3 letters is dog, we will append 1 to this label list. If it is not, we will append 0 to this label list. So this is how it works. So the training data for our neural network is all these images of dogs and cats, these 2000 images, and the labels will be this particular list, whether it is a 1 or a 0. So here I've printed only the first 5 elements, so but it totally contains like 2000 elements, as we can see here. Okay, so you can now count how many dog images and how many cat images are there, because we have just took the first 2000 values, like 2000 images or something. So we know that in total it is like distributed as 12,500 dog images and cat images, but we have to check whether the distribution is equal in this case as well. So this is for so within this 2000 images, I'm going to count how many dog images and cat images are there. So for that, so I'll just mention a comment as counting the images of dogs and cats in dogs and cats out of 2000 images. Okay, so for that, you can just say values comma counts is equal to np dot unique. So this np numpy, we know that np is numpy library, and there we have this unique function that will tell you like how many unique values are there. So in this case, unique values are 1 and 0. So here we have to pass the labels list and say return counts is equal to true. Now I'll print this values and also the counts. Okay, so this tells us like 0, which means like cat images are 992 and dog images are like 1008. So total you have this 2000 images. So the distribution is like almost even. So it is like we don't have like 500 cat images and 1500 dog images and so on. So it's like almost equal. So we don't have to worry about this. So if the distribution is uneven, in that case you have to like build a for loop differently here, where there can be like even split of this dogs and cats, but this 992 and 1008 is like we can like work with that, so there is no issues here. Now the next step is to, before training our model, we have to read all these images and convert them to numpy arrays. So that will be the next step. Okay, because we know that our models cannot understand images, but they understand numbers. So we have to take all these images and convert them to arrays. And I have also like explained in the previous videos on how this image processing works, and how to extract this pixel values and convert that to numpy array. So if you have not watched those videos, I'll just give you the link of those videos in this video description. You can just check that out. So here I'll just create another text as converting all the resized images to numpy arrays. Okay, so here I'll import cv2, which is the OpenCV library, and we need another library called as glob. Okay, so these are the two things that we need. And here we just given the directory which contain all these resized images. So we will read all the images here and convert them to numpy arrays. So that's what we are going to do. So I'll create a variable as image directory. So this image directory is nothing but just copy this image resized path, and don't forget to mention this forward slash here, and then mention this image extension. So this is important thing, so it might not be necessary in this case, but you might need it somewhere else. So in some other like data set. So I'll mention PNG and JPG. So in this case, I think like all the files are in this JPG format. Here you can see this list. I think like all the images are of JPG format, but in some data set the images will be in JPG format and PNG format. So in that case, like it's better to mention this extension in this list. Try with these both extensions, so in that case it will work. So if you have PNG and JPEG images, so if you don't include this line, in that case you may get error in your code. So I'll create a list called as files, as empty list, and then I'll say files dot extend uh, globe dot globe. So this is basically to read all the images, and I'll say image directory plus, so we have to mention an asterisk symbol plus dot. So I'll explain you what, like why we are doing this. So let me just complete this quickly, and I have to say for e in image extension. Okay, so after this we can say dog cat images is equal to np dot as array cv2 dot imread file uh, for file in files. Okay, so let's try to understand what we are doing here. So first we are importing this cv2 and the globe library, and then I'm mentioning the image directory, which is nothing but the resized image directory, which contains 2000 resized images, and then I'm mentioning this image extension as well. So let me just run this cell, so it will take some time. So in that meantime I'll explain you what's happening. And then we are like creating this empty list called as files, and I'm mentioning this files dot extend globe dot globe. So it is basically again to locate that file. So image directory plus this asterisk of dot. So as I've told you, in this case you don't have to do this because all the files are in JPG format. So if you have this JPG and PNG format, you can do something like this, which is basically to either check whether the file is PNG or JPG, and then like convert it to a numpy array. So that's why we use this, and we use like a for loop to iterate through this PNG or JPG. So just two things here, and then after that we creating this like a numpy array. So I'm just saying this as np.as array. So cv2.imread for file in file. So now this file, so we are like appending it here. So files.extend is like similar to this extend like appending, where we are like uh, taking each file names, and then we are like reading this file. So reading this file through this cv2.imread, which is using this opencv library. So after that we are converting all these things into numpy array. So this cv2.imread will read an image and convert it to a numpy array. So the reason we have this np.as array is all these images are now in the form of a numpy array, and all these numpy arrays will be in a single numpy array. So that's why we have this. Okay, so this will take each individual image, convert it to numpy array, and this will uh, put all those numpy arrays in a single numpy array. So that's the reason behind this. So I'll just check whether this code is right. So just a minute. So png files dot extend globe of globe image directory e for e in extension and dog cat images mp.as array cv2.imread for file in files. Okay, so let's run this. So this is the final data that we have, which we will like pass it to our mobile net model in order to train it. Now I'll just try to print this dog cat images. So now all these should be converted to numpy array, as you can see here. So these are nothing but the pixel values that we have. So these are like present in a numpy array. So you can also like print the type as well. So type of dog cat images. So this is nothing but the data of all those 2000 images, not like one single image, because we have like we enclosed all these image files. So as I've told you, so each time this for loop runs, so it will take one image and convert it to a numpy array. Later we put all these files in a single numpy array, so it is nothing but this dog cat images. Now let's check this shape. So I'll say print dog cat images dot shape. So this will tell you like there are 2000 images, and each image is of shape 224 comma 224 pixel, and this 3 represents the RGB image. So if this value is 1, that means the images are like grayscale images, or you won't get a number here at all. So that means like the images are converted to grayscale, and when you have RGB images, this 3 will be there. So this 3 is nothing but the red, green and blue intensity values that are there. So we have 2000 images of shape 224 comma 224, and 3 basically represents the RGB images. Okay, so now this is the data that we have. So now we take this 2000 images and we take the labels that we have created here. So labels is present in this labels list, right? So we take this and then we will like apply train test split, and again do the training and all those things. Okay, so I'll just like create two variables of x and y because it is like more convenient. So x and y. So let's take this dog cat images. So I'm just basically renaming the numpy array here, and I'm going to take this labels list which contains this 1 0 and all the things here. Yes, I'm just going to take this labels which is in the form of a list and convert it to a numpy array and then store it in this y. They'll say np dot as array. It should be as array np.array. So here we pass this labels. Okay. Yeah. So this X will now contain the images of dogs and cats, and the corresponding labels will be stored in this Y. And now we can apply our train test split. So all the other things are something that we already know. So train test split. So here the main thing that you can notice, the number of images that we take is 2000, which is very small in terms of deep learning, right? So we often train with like uh, 20,000 images or 100,000 images or so on. So here I'm just taking a small data set, but we will get a good result as we are using a pre-trained model. So like that you can see while we complete our training part. So now we have to apply this train test split. So I'll create four arrays as we often do. So X train, X test, Y train and Y test. So this is equal to train test split. So we have already imported this. So if you remember, we have imported this train test split function from this sklearn.model selection. So we have imported this train test split function. So this is what we are like using now. So here I have to pass this X and Y. So X is my data or my images and Y is my labels. And now I'm going to say test size is equal to 0.2. And then I'll say random state is equal to 2. So again, in random state you can mention any number. So this test size is nothing but the size of your test data. So test size is equal to 0.2 means I want 20 percentage of my images to be test data. The remaining 80 percentage will be my training data. So out of this 2000, 20 percentage will become my test data, and out of 2000, 80 percentage will be my test data. Random state is nothing but I have like explained this several times before. So if you don't know what it is, each time you run this train test split, your data will be splitted in a different manner. So your train data will contain different images and test data will contain different images. So if you want the same split to happen every time, you mention the same number here. So every time you mention random state is equal to 2, your data will be splitted in a similar way. If you mention 3 every time, in that case your data will be splitted in a similar way, and so on. So this is just to replicate that train test split. And once you run this, all the training data images will be stored in this X train, and all the labels, either 0 or 1, will be stored in your Y train. So the corresponding labels for this X train will be stored in this Y train, and your test images will be stored in this X test, and the corresponding labels will be stored in this Y test. So let's run this. Okay, and now let's so this process is complete. Now let's try to check the shape of each thing. So print x dot shape. So this is like the original data set, and now I'll print this x train dot shape and x test dot shape. The X is our original data which contain like 2000 images as we can see. So this is the 2000 images and the corresponding shape. So this 1600 is nothing but the 80 percentage of data which is my training data, and the 20 percentage test data will be is nothing but my 400 data. And again we have this 224 comma 224 as the dimension of the images and 3 as the RGB image. Okay, so here I'll just mention that we have 1600 training images and 400 test images. Okay, yeah. Okay, so we have like splitted this training and test images. Next, before training the neural network, we have to scale this data. Okay, so I'll create a comment as scaling the data. So the scaling is nothing but we have the pixel values like 121, 101, 84, 83, and so on. So the range is like a bit higher, right? So now what I'm going to is do is like scale the data, so all the values are in the range of 0 to 255, sorry, 0 and 1. So again I've explained in that video where I like explained about image processing that your pixel value ranges from 0 and 255, where 0 means it's black color and 255 means it's like complete white color. So all the pixel value will be in this range between 0 and 255. Now if you wanted to scale this data between 0 and 1, so you need to divide all the values by 255. So that's what we are going to do. So let's call this as extreme scaled is equal to extrain or training data, and it's divided by 255, the maximum value. And similarly we have to do this for test data as well. So this is my x test scaled, x test divided by 255. Okay, so I'll run this. So this will take like all these values divided by 255. Let's see what is the end result that we are getting. So I'll run this. Now I'll print this. So this is my training data scale, this is my test data scale. So this x train and x test are nothing but what we have splitted here. So I'll print this x test alone, sorry, x train scaled alone. As you can see, the values will be in the range of 0 and 1. So this is what this scaling does. Now we can build our neural network. Okay, so I'll create a text as building the neural network. As I've told you, here we will be using a pre-trained model called as MobileNet. So here I'm going to import my TensorFlow library. So I'll import TensorFlow as TF, and you can get this MobileNet V2, this pre-trained model from TensorFlow Hub. So I'll import TensorFlow underscore hub as uh, hub itself. So I'll run this. Okay. So this is where this model is. So you have to mention this link. So this tf hub dev this mobilenet v2 feature vector under like /4. So this is the link for it. So I'll create a model name for this. Let's call this as mobilenet model, and here we have to mention that path, this url. Okay, so I'll copy this url and paste it here. So you can just look this url somewhere, save this like somewhere so that you can like use it later. So now I'll call this as pre-trained model, and we have to mention like some parameters. So this pre-trained model is equal to up dot keras. So this k should be caps. So keras layer, and in the parentheses you have to mention the name of the model, which is this MobileNet model. So this will basically like download the models, weights, and so on. The model, and then we have to mention the input shape. So this input shape is nothing but 224 comma 224, which we have like resized, comma 3. So this 3 is nothing but it says the images are like RGB images. Then say trainable is equal to false. Okay. So as you can see, it's just to tell whether the model is like that particular layer is like trainable or not. So I'm taking this mobile net model. So mention this particular URL. So this should not change. And I'll create another variable called as this pre-trained model. So up.keras layer. So this up is nothing but TensorFlow up. So mobile net model is nothing but URL of the model that we are extracting from this TensorFlow up. And the next parameter is this input chip. Finally, we have this trainable. Yeah. Okay. Now we can run this. So the as you can see, so this will like download this mobile net model, and now we can train this. So I'll create a variable called as number of classes. So number of classes is nothing but how many types of images you have. So here we have two types of images, right? So one is dog and the another one is like cats. So here I can say model is equal to tf dot keras dot sequential. So we have like already used this before. So even when you're like building the model from scratch, we use this tf.keras.sequential, and within the sequential create a list. So mention this square brackets, and here I'll say pre-trained model, and this will be my first layer. Then finally I need my tf.keras.layers.dense. So this will be my output layer. So here I'll say number of classes. So number of classes, I mean you can say number of classes, or else you can just mention two here. So this like if you have like three images or three types of images in your data, so it should be like 3 years, so that like won't change. Okay, and finally let's print this model summary, model dot summary. Yeah. Okay, so mobile net model, the URL of this mobile net v2, then pre-trained model is the like variable name, up keras layers, and all these things. So input shape and trainable false, and then we have to mention this tf.keras.sequential. So pre-trained model. So again, so this mobile net model has a specific architecture, so it contains a set number of convolutional layers and all the things and so on. So the only thing that we need to include is this output layer. So in the output layer we have to say how many classes are there in our data set. So mobile.summary. So this will tell you what is the layers that you have. Okay, so Keras layer. So this is for the mobile net model that we are using. So these are the count of those parameters and so on. So you can do some research on this. So you can go to this TensorFlow up. You can go to this mobile net v2, and this is the image. So as I've told you right earlier that in transfer learning the model will be trained previously on a data set, and we can use a similar data set and train in a different use case. So go to this ImageNet ILS VRC and so on. So just search it in Google, so you can see like the data set on which this model has been trained. And if you wanted to learn what is the architecture of this model, you can just go to Google and search it. So it will basically tell you like what are all the different like layers are there in this particular model. So if you want, you can like create this from scratch as well by mentioning like all these things. But again, we know that it will take a very long time to train, as this data set is probably a very larger one. Okay, so you can do some research on this data set as well as this mobile net architecture as well. So probably we will discuss later about in detail about like what these individual layers are and how this model works and so on. But for now you can do some research on this. So this is the thing, and now we can compile this model and train this. So I'll say model dot compile. So here we will like mention what is the loss function we are going to use, what is the optimizer and so on. So I'll say the so let's say model dot compile. So optimizer is like the most widely used one, which is the Adam optimizer. And then loss function is something that we have to mention. So I'll say loss is equal to tf dot keras dot losses sparse categorical cross entropy. So you can like do some again research on what are all the different loss functions there are. So tf dot keras. Okay, so it should be keras dot losses dot sparse categorical cross entropy. Okay, so within that I can see from logits is equal to true, and the matrix is nothing but we can take this accuracy score. So I'll say matrix is equal to, within list we have to say this EACC, which basically tells it's as like the accuracy. Okay, so model.compile, my optimizer is Adam, and loss function is this sparse categorical cross entropy. So this is like a normal label encoder. So we use this sparse categorical cross entropy. So if you use one not encoder labels, in this case we use the simple categorical cross entropy, and we have mentioned this matrix is equal to accuracies. Now let's run this, and finally we can train our model. So I'll say model.fit, and within this we have to pass our training data, which is my xtrain scaled and my labels. Okay, so I'll just go here. So we have to pass this xtrain scaled and this y train, the corresponding labels. Okay, so model dot fit xtrain, so x underscore train scaled, comma y train, and you can mention epoch. So this will probably take some time, but it will give you good results for like 5 epochs alone. So if you want, you can like increase this epochs. Like you can also include some more hidden layers, and see like how your accuracy changes and so on. So if you include more, there is a chance that our model might overfit. So I'll run this. So this will like train our neural network for 5 epochs, and you can see like what is the accuracy that is like taking place here. Okay, so you can, in the meantime, again you can see like what is your loss function value and how your accuracy score is changing. Okay, so this, as I've told you, will take some time, and let's wait until it's trained. So I'll just pass this and resume once this training is done. Okay, so this took a time of 4 minutes in total to train with the set 1600 training images which we have like seen here. So we totally have like 1600 images. So for 5 epochs we took like 4 minutes to train this model, and you can see this loss function value and the accuracy value. So in the first epoch we started with this 91 percentage accuracy, so it kind of increased to 97, 98, and so on. So the final accuracy in the fifth epoch that we got is like 99 percentage, which is a very good accuracy for the very small amount of data set that we have taken. So this is the advantage while we use like transfer learning or the pre-trained models. So we know that this is the training data accuracy. So that this is not all. So we have to do the same thing and find the accuracy for test data as well. So I'll create like two variables called as score and ACC, which is my loss function value and accuracy score for test data. So I'll say model dot evaluate. So this model is the model that we have created. So model dot evaluate, and I'll say x test scaled. So this is my test data, and I'll pass the test data labels as well. So what happens here is like the model will predict the labels for this X test images, and that will be compared with this Y test, like the real labels, and then we will get this accuracy score and basically the loss function value and the accuracy score. And later we can print this as uh, test loss, the loss function value, and score, and the accuracy score value. So this will be my test data accuracy, which is the most important metric. So this test accuracy is equal to ACC. Okay, so this will take few seconds, but not like that much time. You can see the accuracy, it's almost 98 percentage. So we can like take this as 97 percentage. That means like out of 100 images of dogs and cats, our model can correctly predict for 97 images. So we can say, so test accuracy of 0.977 means like 97.7 percentage. Okay, which is a good accuracy. So this is how you can train this transfer learning model, or basically the pre-trained model of MobileNet v2, and you can like build this classification system of dogs and cats. So we just have like one more thing to do, which is to build a predictive system where if you pass a new image of a dog or a cat, our model should say whether it is 0 or 1, basically whether it is a dog or cat. So here I'll create a text as predictive system. So there are like few lines of code that we have to do here. So I'll create a variable as input image path and is equal to, so let's get this from the user itself. So, I mean, in a more detailed use case, so what you can do is build a simple UI in Streamlit or Flash, and keep an upload button or something where you can upload an image, and in the backend your model can predict whether it is a dog or cat, and then you can like deploy that using Streamlit or Heroku. So I'll say path of the image to be predicted. Okay, so path of the image to be predicted, and then I'll say input image is equal to, so let me just put this as image as well. So input image is equal to cv2.imread. So this will basically convert the image. So this will read the jpg image into a numpy array, so cv2.imread, and within this we have to put this input image path. Okay, so input image path. Later I'll also display this image as well. So for this I'm going to use cv2 underscore imshow. So note that this is not cv2 dot imshow, as I've told you previously. So there is an imshow function in OpenCV, that is cv2, but it won't work. So as an alternative, from this google.colab.patches I'm importing the cv2 underscore imshow, which is basically the same function. So cv2 imshow, and within that we have to pass this numpy array of input image. So what happens is, like we mentioned the path of the image for which we need to make the prediction, and then we display that image and finally make the prediction. So the next thing that we have to do is like resize the images like what we have done before. So input image resize is equal to CV2. So previously we used like pillow to resize. Similarly, you can use this OpenCV library as well. So I'll say input image, and in the next parameter you need to mention what is the dimension that you want, which is 224 comma 224, and then this we have to scale this now. So let's call this as input image scaled is equal to this input image resized divided by 255. So what we have already done, now we have to reshape this. So let's call this as image reshaped. So I'll tell you like what is the purpose of this. So let's use np.reshape input image scaled, comma, so in a list I'll mention 1 comma 224 comma 224 comma 3. I'll explain you what this means after completing this. So, and then let's create another variable as input prediction. So this is where our final prediction will be. I'll say model dot predict. So here I'll pass this input image reshape. So image reshaped, mm, input pred label. For this I'm going to use np.argmax of input prediction. Okay, so now let's try to understand what's happening here. So first we need to mention the path of the image. So what we will do is upload a new cat image or a dog image, and once we run this, so this will like ask for the user for the input. So there we will paste the path of this image, and then we will read this image and load it to a numpy array using the cv2.imread. Okay, so after that we will display that image using the cv2 underscore imshow. Later we will resize the image to this. Okay, so this should not be 224 comma 224, so this should be 1 comma, okay, sorry, just Okay, okay, yes, this is correct. So this is the first reshape that we do. So the image can be like 500 into 500 pixel or 1000 pixel or something. So we are reshaping this to 224 comma 224. Then we are like scaling this image because we know that we want the values to be between 0 and 1. Later we are reshaping this numpy array. So the reason is it is to tell the model that I'm making prediction for only one image. So I mentioned 1 year, and 224 is the dimension of the image, 3 is the RGB image. So this one is nothing but I'm making prediction for only one image. So if you are passing like 3 or 4 images, so you will mention that images here, but here we are like interested in only one image, so I'm mentioning 1 year. And finally we can pass this reshaped array to this model.predict, and then we can apply this np.argmax. Okay, so this np.argmax is nothing but just the prediction. So when you use this model.predict, you will get the prediction probability of whether it is a dog or a cat. Okay, so say for example, the final result will be something like this. So let's say it's 0.85 and 0.20 or something. So this is like, let me put this as 0.15. So this can be any value. So this is 0.85 is what is the probability that the label is 0. This is what is the probability of the label being 1. So it is like telling there is a 85% chance that this image is a cat, and only 15% chance that it is a dog. So this is the result that you get when you have this model.predict. Now when you apply this np.argmax, it will see which number is maximum, whether it is first number or second number. So here the first number is maximum, so the final value is 0. If the second value is maximum, the final value is 1. So this is just basically to have that final prediction in terms of labels. So this model.predict will give you only this probability value. So we are applying this np.argmax to find which value is maximum, either the first value or second value. If the first value is maximum, you will get the value as 0, that means it is a cat. If the second value is maximum, that means it is a dog, you will get a 1. So later we can say if this input red label is equal to 0, so I'll say, so I'll basically print the image represents a cat. Okay, because that is the label that we have created, right? And else we will say the image represents a dog. Okay, so this is the simple if condition. So you, all you have to do is like pass in the path of the image, then it will convert it to numpy array, display the image, then all this resizing, scaling and reshaping will happen, and then we finally make this prediction. Okay, so before like doing the prediction, I just wanted to download some dog image and cat image. So I'll just search as dog images. So let me just open this image and download this file. Save images. So I'll just save this in my desktop as dog.jpg, and let's do the same thing for cat as well. So our model should predict this. So cat images, so can just download some image. So as you can see, it can be any dimension because we are anyway reshaping this. So I'll save this as cat.jpg in the desktop itself. So now I'm going to upload these files, dog image and the cat image. So I'll go to this upload, go to my desktop, and I have this, yeah, dog and okay. So let's upload these two things. So once this is completed, so I'll run this. Now first I'll copy the path of a dog, this dog.jpg. So I'll copy the path and paste it here. Okay, let's press enter. So this should display the image and give the prediction. So path of the image should be predicted as this dog, and we are displaying this dog. So this image is displayed using the CV2 I am sure, and this tells the image represents a dog because the prediction that we get is this, 0. So if you want to understand this clearly, I'll also print the prediction as well. Let's print input prediction. Let me print this here, and let's print this input red label. I'll show you how this will be. for the same dog image. So I'll paste this here. So here the second value will be okay. Okay. So I have to pass, like, sorry, paste the path. So yeah, this copy path. Okay. So this dog image is placed, and then you can see. So this is the probability of the image being cat, and this is the probability of the image being dog. As we can see, the value is higher for this second value. That means the label is 1. So it says the image represents a dog. So this is how this prediction system works. So I'll copy this entire thing and I'll test this for cat as well. Okay, so let's run this, and now let's copy and paste the path of this cat image. Okay. So as you can see, now the first value is maximum. That means the label is 0. Using np.argmax, we have found that. And then we say that this image represents a cat. So this is how we can build this predictive system. Okay. So I hope like everyone is clear with how we have did all these things here. So what I would want you to do from here is like build a simple UI in Streamlit or Flask and deploy this model, so that the final thing that you have is just UI where the user can upload an image, so and that will display this image like this and tell you whether that is a dog or a cat, and you can like use this idea and work on like different use cases, so like predicting different animals or some any classification, any image classifications. And yeah, so that is all. So I'll just give you a quick recap of all the things that we have done from the start. The first is like we are importing this dataset from Kaggle, this dogs versus cats. So this is the same of uploading the kaggle.json file and configuring the path, and then extracting the data through API. And then we are like extracting the zip file, this dogs versus cats.zip and train.zip and so on, and counting that there are 25,000 images of dogs and cats. And then we are importing all the dependencies that we have, and then displaying the image of dog using this matplotlib dot image module, and image of cat and so on. And then we have seen that the first three letters have this dogs and the next three letters have this cat and so on, and we use this to find how many dog images are there and how many cat images are there, and saw that there are equal images, number of dog images and cat images, which is 12,500. Then the important task is we are resizing all the images. So we are creating a new directory called as image resize, and then resizing the first 2,000 images, resizing it of dimension 224 comma 224, and saving it there in the new folder that we have created. And finally we are displaying these images and seeing that these two images having the same size. So we have resized all the images. So the next step is to iterate through this resized folder and create the labels for this. So if it is a dog image, we say the label should be 1. So we are doing this here. And if the image starts with this cat, we say the label is 0. And then we have seen that there is an almost equal distribution of dogs and cat. And then we run this particular code snippet in order to read all these image files and convert it to a numpy array. And later, like we have seen, like there are, like we took like 2,000 images of this dimension and RGB images represented by 3. So next one is like this train test split. So X train, X test, Y train and Y test. So we are taking like 20 percentage as the test data and so on. So 1,600 images will be your training images and 400 images will be your test images. And then we are like scaling the images of 255 and so on. Okay. So the next step is like building the neural network. So we are taking this MobileNet model, MobileNet V2, from this particular link. So this is the pre-trained model that we are using. So you can just go through this code. So we are just applying, adding like one output layer. So this is nothing but 2, the number of classes that we have. And this is a model summary. And we are like compiling with Adam optimizer and sparse categorical cost entropy and so on. We have seen that we get a very good accuracy score, right? And then we have also seen that we got a test accuracy of almost 98 percentage and so on. Finally, we built a predictive system where we can paste the path of the image and it will tell you whether that image is a dog or a cat. Okay. So that is all from my side, and I hope that you have understood all the things covered. So make sure that you are practicing all the code by yourself and try to, as I've told you, try to build a UI for the same, and that will be like very helpful for your portfolio. Yeah. So that's it from my side, and I'll see you in the next upload. Thanks for watching.